appear in the new coordinate system? Well,
All right. Oh my god. All right. Who wants my undivided attention? Gnostic Judas and the new Midland 63.5 champion goes to me. Gnostic, do you want to join me, dude? Let's talk. La 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 la, señorina. La 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 la, mira Leila. Do 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 la la la. Do la la la. Di 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 la. La 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 la. All right, StreamYard. StreamYard. I'm in the car on the way back, so I can't. I'm sorry. I'm so sorry. So sorry. So sorry. All right. All right. Copy. Und der paste. Und der paste. And we can also copy. La 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 la. Wait a minute, we didn't do a mic check today. I mean, we didn't do a mic check for the current stream. Let's do mic check. We're up to 199 trillion subscribed stars. We're going to be multi-trillionaires. Copy. Und pasten nicht. All right. So there you go. Let's see, what do we got? So we was to be. Okay, this is a 4-minute video. It shouldn't be that hard, but it's kind of hard. So basically, this is linear transformations. But the next thing he's going to do is he's going to do nonlinear, like general transformations. All right, let's listen.
well, this is how it would appear in C prime as the vector x prime, which equals a matrix L times the original vector x in the coordinate system C. The matrix
So that's a linear transformation.
L is called the transformation matrix, and in general, we can use a matrix to represent linear transformations. Now, keep in mind that
I mean, it's not just it's a matrix of constant values. You can always use a matrix of functions, but that's not what you mean when you say linear transformationen.
linear transformations cover a fairly small subset of transformations, including scaling the axes and rotating the axes. They're mainly transformations that map a line in the C coordinate system to another line in the C.
Oh, you can scale the axes and rotate them, but not move by an offset?
Prime coordinate system. But what about more general transformations? Well, instead of constant matrices, general transformations can be expressed as
linear transformations map lines to line, and by lines he means not curves, straight lines.
functions. So again, if I have my vector x in the d coordinate system, and if I transform the d coordinate system to a d prime coordinate system with a general transformation, then the image vector x prime, the vector you get after transforming x, is given by the following expression, where t is the function that defines.
So x prime is a general function. Why does he say here d prime? What is d prime? Like dimension prime? So 1 is going to be like, oh, if this is d, then this is d prime. Okay. And this is x prime. Why is x and x prime? Oh, that's the vector. X prime is identical to x within the D system. So the transformation, this is the general transformation. So it's a function, right? So it takes, basically it's a function of all the dimensions, and you get a function. And this function becomes an axis. an axis of evil. Evil Knievel. Oh my god, I sat outside and I got bitten. Basically, my leg was chopped off. Jesus Christ. Oh my god. Jesus, it's like it didn't bite me. It's like a horse chewed off my foot. Jesus. Jesus. Christos. Meinen Christos.
the general transformation. You can also write this equation in terms of the components.
So this is really interesting. So basically you transform d into a general function d prime, and the other, like this is d prime, and this is probably what's after d. Why does he call it d? A, B, C, D. This would be e prime, and this would be e.
Of x prime given by x prime I, in which case you would get the following, where x prime I is in general a function t.
So x prime I, that's d prime, or I mean it's e prime. It's one of them. It's one of the functions, because this converts a vector. So this gives you a function. So this would be, or I mean, if these are constants, and this transforms, it would transform them into a constant, and that would give us the point in the x, let's say 1 prime, and then you do the same for this would be t1. Then you would use t2 with the same values, right? You're taking a vector x. This is x. You're taking x. You're feeding it into a function t1, then t2, then t3. You're feeding it into different functions, and each time you're getting some value that is x1 prime, x2 prime, x3 prime, and so on and so forth. Yeah.
I of all the components of the original vector x. There's some important definitions involving general transformations that I'd like to go over. The first is the definition of a bijective transformation, which is basically a...
So bijective just means that the function that is described, basically ti, each ti is a unique function. It maps these values to one unique value. So you never get two values. If you get two values, then ti is not a function. It's not a map. So as long as ti, OTI are, they map unique values to a unique output, so it's a unique map, or that is a map, then the transformation is bijective. It's unique. There's no loops in the coordinates.
One-to-one transformation. Every x corresponds to a unique x prime, and every x prime corresponds to a unique x. The image
x is a vector. He should have put a vector, like an arrow on top.
X prime of a bijective transformation T represents a set of admissible coordinates for x, and the collection of all these admissible...
Now, an image x prime of a bijective transformation T represents a set of admissible coordinates. That's already a space.
Coordinates. The aggregate of these admissible coordinates comprises a coordinate system. Now, if T is linear...
Why would you ever define such a definition? I don't know. Did we do a mic check? That's the mic check.
Coordinates. The aggregate of...
Did we do a mic check? Yes, we did a mic check. Mic check. Let us continue.
Here, the x prime I coordinate system is called an affine coordinate system. In addition, if T is a nonlinear transformation, then the x...
If T is linear, okay. If T is linear, that's the first part. That's what they called L. He called L. The xi prime, that's like the x prime vector coordinate system, is called, right, x is a vector, xi prime, or yeah, xi prime is a coordinate system. D prime is xi prime. It's like one of them. It's x1 prime, or in this case, yeah. It's called an affine coordinate system if t is non. Okay, that's if the transformation is linear. If t is nonlinear, then the xi prime coordinate system is not called affine. Maybe it's called non-affine.
X prime I coordinate system is also called a set of curvilinear coordinates. Examples would include polar coordinates, cylindrical coordinates, and spherical coordinates. Now I'm going to
Either affine or nonlinear, curvilinear. Okay, like this. This is the example of curvilinear. That's good.
end this video by briefly going over the chain rule for partial derivatives. I won't be deriving the chain
Wait, so polar, polar, polar. Okay.
rule. I'll just show what it looks like in Einstein notation. Suppose that w is a function of n variables u, where the variable ui is itself a function of m variables x. I varies from 1 to n. If this is the case, then
Okay, so we were here in the last episode. So each u, right? So u is basically the x prime coordinate system, and this is the x coordinate system, and u is a transformation, what he called t before, or L. So let's say t. So anyway, it's a function that converts any given point, any vector x into vector u. And then you take vector u, that gives you a value w. Suppose so w is a function in the x prime space, where, right, but what we want to do is we want to do the chain rule of partial derivative. So we want to do a partial derivative of f, right? So f is a function of all the u's, but each u is a function of all the x's. F is a function of all the u's. That means if you take a derivative of f, that's already a partial derivative in respect to any u. But that's just a partial derivative. For that, you don't need the chain rule. You need the chain rule because each u is a function of all the x's. That's really interesting. But this is what we deal with when we're talking about general relativity and the transformation of coordinate systems. So we want to be able to do a quick transformation of a coordinate system. So we need to be able, this is the transformation from x to u. But why do we need f? Because f will describe a manifold. It will describe the curvature of space or space-time in the u space. And f will be the curvature. But there's also going to be another function, let's say g, that will feed it x and will get x, y, or z. I shouldn't use w. Anyway, something like that.
the partial derivative of w with respect to xj.
So the partial of w, right, with respect to x, right? So there's right, w is basically f. W and f are the same. So w, right, what is the change in w? W is the manifold. W is the terrain. It's a topology, which is the curvature of space-time. So w is the curve, is what we're looking to see. Okay, by how much is w changing as I'm moving along the original xj coordinate? So I'm taking any one of these x's, I'm moving along any one of these x's. By how much is w changing, right? So w is f. F is a function of u space, and each u dimension is a function of all the x's. So dw, du, du, dx. This is going to equal to dw, du, du, dx. Right? But which du? du1, du2, which du? This is xj. So by how much this is, right? We want to know by how much is w changing? By how much am I going up or down when I'm right? But W is in a different space. It's in U space. And U space is a transformation from X space. So I'm moving down a single dimension, a certain X. Let's say this is the X coordinate. I'm moving a little bit down the X coordinate. So as I'm moving down a single X coordinate, I'm changing. What am I changing? I'm changing U. And as I'm changing, right, each and every U is a function of all the X's. So if I change one of the X's, I'm changing all the U's. So all the U's have now changed. So of course, F is just a function. So F of all the different U's, I have a different W. I either went up or down, right? W is the terrain. I go up or down in the terrain. So the dw dx j is equal to dw du1 dxj plus dw d, right? So when you have to think about it, when I'm going down one of the x's, I'm simultaneously going down all the u's. There's nothing you can do about that. So really the dw, because of a single x, little x, is equal to, well, by how much did w change because of that little change in u, because of that little change in x. Plus, right, let's say I went up a little bit because I went down u1. And I went up a little bit more because I went down U2, and I went maybe a little down because I went along U3, and so on and so on and so on and so on. But each, right, you could say, well, dw is equal, right, you could say, what is dw, right? What is dw? I don't know, d what? But you could say that dw, any change in w, is due to a, a little change. Well, the total dw, whatever that is, it's a summary of du1. Sorry, it's a summary of dw du1 plus dw du2 plus dw du3 plus dw blah, 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 dun. Right? That's dw. The question is due to what? Let's say u were independent variables. What would we ask then? I think we would say dw is equal to dw over du1. But you can't say that because dw du1 is a real number and dw is an infinitesimal number. So the question is, maybe it's delta w, but it's not. What about, this is a good question. I mean, what if I just have a terrain defined over xy? I think there is like a gradient that it just says if you change by an infinitesimal x and an infinitesimal y, you change by infinitesimal z. How would you express that? Like, dz is equal, well, it's not z, it's f, I don't know. Okay. But this is easy. So it's going to be dw du1 du1 dx. Well, it's like dx1 dxj plus dw du2 dxj. So it's going to be the sum of, so this is equal to the sum of dw dui dxj. But what are you summing over? Over the u's. J is an actual number. Right? This is just the chain rule for J. Let's see what they say. I don't know how he wants to express. I would say dw dxj. Dxj is one of these. So J is a given. So it's equal to, we need to go through all the u's. So it's the sum over I equals 1 to n, because this is m. These cannot be different dimensions. It can't be n and m. That's not possible. I'm sure that's a mistake. So I would say 302 n must equal m. Otherwise, it doesn't make any sense. What time is it? 302, we said? 302 m must equal n. M must equal n. Otherwise, the transformation doesn't make any sense. The number of dimensions dimensions must be the same. Oh, it's not dimensions, it's dimensions. Okay. So it's going to be the sum over 1 to n of the w du I is the summation, times the u I dxj. So we're summing over I, but j is a free variable. J doesn't change.
Where j is an index between 1
I is a dummy variable.
and m is given by the following. We can actually shorten this
The f, okay, the f or the w, the f du1, du1, dxj. df du2, du2, dxj. Yeah, exactly as I said. J is an integer index from 1 to m. So they're not the same dimensions? It says here n. These are not dimensions. These are not dimensions. This is just a generalized chain rule. These are not dimensions. He will not divide us. 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 You might as well say, we are not a cult. We are not a cult. We are not a cult. Yeah. Okay. So as predicted, now I understand why n and m are different. That's good. So he says, J is an integer index from 1 to m. J is to m, correct.
Expression using the rules of Einstein notation. The index I, which varies from 1 to n, is being.
Okay, interesting. So, well, first of all, write it with, with the normal summation and then remove the summation. So it's the f d u i d u i d x j. Since dui shows up twice, it's a dummy variable, but j is not.
Summed over. So we can write the partial of w with respect to xj as the partial of f with respect to ui times the partial of ui with respect to xj, where I is the repeated index, the dummy index that's being summed over. Anyway, that should do it for this lecture and for the first part in my series on tensor calculus. After this video, we're going to get deep into the mathematics and terminology of tensor calculus by talking about coordinate transformations and contravariant and covariant tensors. I'd like to thank the following patrons for supporting me at the $5 level or higher. I've linked my Patreon account in the description for you to check out. And that's it. If you enjoyed the video, feel free to like and subscribe. This is the Faculty of Khan signing out.
He says the faculty of
Let's talk about coordinate transformations for tensors.
Okay, so this is the next topic. It's next topic. It's next topic. And oh my god. All right. Okay. This is 11 minutes and 47 seconds. This is coordinate transformations and curvilinear coordinates, tensor calculus. All right, let's go.
We'll start by introducing some new coordinate notation. If I have a vector in Rn which goes from some point P to another point Q, then I can write that vector x in terms of its components as x1, x2, x3, and so on. You might have seen this already in your linear algebra courses, but the main difference here is that I'm using superscripts for the components of the vector, not subscripts. Similarly, if I had some random point A in Rn, then I would write the coordinates of the point A as a1, a2, a3, and so on. Again, the individual coordinates of A involve superscripts. Now this might be confusing. How will I distinguish?
Yeah. How do you distinguish, like, a point is a row and a vector from P to Q is x? That doesn't make any sense. What do you mean it's x? But x is just a point in n dimensions, like this. But P and Q are not mentioned here. We are using superscripts now. New notation, a vector in R n, and that means a space of n dimensions. What do you mean it's from P to Q? How is it from P to Q? What's going on? Coordinate transformations for tensors. What do you mean from P to Q? But you're only mentioning the vector doesn't have from to. There's just a single point, just like this. What? What do you mean vector PQ x? What do you mean? Where is the from and to? I don't get it.
Distinguish a quantity with a superscript from a quantity with a power? Well, what
I'll This doesn't make any sense. Let's ask ChatGPT. Oh my god. La li la 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 mi la li la ma li la 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 li la 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 li la 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 la. All right, let's see what ChatGPT says. Did I do go? The image appears to be discussing coordinate transformations for tensors specifically. Introducing a new notation for vector Rn. Here is a breakdown of the key points. New notation. A vector in Rn. The notation introduced here uses superscripts to denote the component of a vector. For a vector A is now represented as A1, A2, A3. No, the vector is X, where the superscript numbers denote the vector representation. On the right side, the vector A it's X, is represented as a column vector. How? Where's the from? This is just a 2. This is a single point. Here, each component is denoted. Excellent. Following convention. So it is emphasized in the image that superscripts are now being used. Oh my God. Geometric representation, PQ. There's a diagram on the left showing 2 points PQ with I don't know. Oh my God. Let me go to these guys. I'm so tired. I need to go to sleep. I'm so tired. I did not sleep well. Yeah, maybe I should go to sleep. That could be a good idea.
Okay, I'm going to December.
December 25 to December 26, noon to noon.
Okay, here I got solar noon on day 1, 11:48. It's 11:49 on the 3rd. 11:50 on the 5th. So that's like already 2 extra minutes to get to solar noon. I've just gone like 5 days, 6 days.
Well, I could give an example from the 1st of June to the 30th of June.
Okay, by now it's up to 11:51.
That's the difference
Now it's
there
up
is
to 11:52, 11:53, 11:54, 11:55, 11:56, 11:57, 11:58, 11:59, 12 p.m., 12:01, 12:01, 12:01, 12:02 at the end of December. Okay, and the first day of December
in June
was 11:48. So we got 12. We got 14 minutes of longer that it took to get from solar noon to solar noon, from the 1st to the 31st.
Yes, but if we go to the midnight sun from the position that I look,
The sun is taking longer.
Look at the length of the day from December 25th to December 26th. One day, that day. It's 24 hours and 27 seconds.
For one day.
Hey, can somebody help me for a minute?
No, we're busy.
Yeah, for those 2 days, it's 12:12, and then it goes to 12:01, like after 3 days. And it's by the 3 more days or whatever.
The length
It's
of that
12:02. I don't care about the one day is. Look at over the course of the month. It changed by 14 minutes from solar noon to solar noon.
That's exactly
from the original solar noon.
That's exactly my point. It's 27.
Okay, for the whole month.
Okay, I just looked it up.
It changed by 14 minutes.
Yeah, okay, for the whole month.
I'm so tired. I'm so tired. All right, we got no choice. We have to figure this out on our own. So, and ChatGPT is not helping. So I think this is confusing.
I'll
Okay.
be doing for the entirety of the series is using parentheses if I want to raise something to a power. So a super I to the power 2 or a super I squared would be written like this, but a with a
Like, you could say A is a point or X is a vector, but not PQ. You could say it's a vector PQ where P is the origin. You can't just place it here because then PQ, I don't have enough information. These are the X, like what is, you don't explain anything. What is X? And point A has A1, A2, but in what coordinate system? Is this X, A? What is going on here?
the simple I will be written like this.
Use parentheses for powers. Yeah, you already told us that.
A super I. Next, we'll
Oh, no. I saw this before. Okay.
talk about rectangular coordinates. Say I draw the set of horizontal and vertical axes intersecting at the origin O, and suppose that I drew some random point B over here. If I wanted to specify the location of B using rectangular coordinates, I would need to find the perpendicular distance from the vertical axis, which is called x1. And then the perpendicular distance from the horizontal axis, which is called x2. Combining x1 and x2 gives me the coordinates of B. Essentially, the rectangular coordinates of a point tell you the perpendicular distance of that point from each of the orthogonal axes specifying that rectangular coordinate system. So for this example, the rectangular coordinates of B tell us the perpendicular distance x1 from the
All right. La 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 li, la 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 Do you know the song? I'm blum 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 blum. Blum 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 blum. Blum 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 blum. Blum 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 blum. Okay, what is he saying here? I don't know what the first part is about. This doesn't make any sense. And then he's going to rectangular coordinates. This is very old news. Of course, this is x prime and x1, x2. So B, okay, that's good.
vertical axis and the perpendicular distance x2 from the horizontal axis. Another way to define a rectangular coordinate system is with a distance formula. According to this definition, a coordinate system is rectangular if the distance between 2 points C and D in that coordinate system is given by this formula, which can be simplified to the square root of delta ij times delta xi times delta xj, or delta.
Oh my god. So it's the square root of x1 minus y1 squared. Okay. So we're wondering what's the distance from the origin to B? So it's x1 squared. What is y? What is going on? What is x1, x2? Okay. The coordinate system xi, okay, in Rn, okay, is rectangular if the distance between 2 points C, x1, and D, y1, got it, okay, is given by, so let's say we have 2 points. He should have done the drawing. Like there's C and D, which is the x's and the y's. So let's say there's a point, instead of B, think of C, and another point D. Jesus Christ. Why don't you draw it? So the distance between point C and D is the distance between the x1 and the y1 squared. So let's say you have another point here. You want to know the distance from B to C. So what you need is the distance between their x's squared plus the distance between their y's squared, right? Because you want like to draw a line. So you do the distance, the base squared plus the height squared is equal to the hypotenuse squared. That's if it's a rectangular coordinate system. Or you can restate this as delta xi. I wouldn't call this delta xi. I don't know what I would call it, but not delta, because delta x refers to the first group. I would just call delta 1 or delta I. Where delta I is xi minus yi. That's delta I. Oh. It's a transformation of the original vector. Come talk to me. No entiendo nada. Oh my God. My life. My poor life. No. Where is this? No. It's... I can get it from here. Copy. Is he going to join me? He's not joining. La 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 I love it when you call me señorita. Please call me señorita. Senor. Oh, senor. Oh my God, I'm tired. I'm tired, Trinity. I'm tired, Trinity. He's not coming to join us. So it's delta xi times delta xj. So this is delta xi. But this is summation. So he's summing up delta xi. He wants to say it's squared. So delta xi, delta xj, chronicle delta ij, that's already this summation of right. It's a square when they're the same dimension. Yeah, that's correct.
ij is the Kronecker delta, and delta xi is just xi minus yi. And we can simplify it to this
Yeah, I wouldn't call it delta xi. I would just call it delta I.
expression using Einstein notation, so the repeated indices are being summed over here. So if the distance between 2 points in a coordinate system can be found using this Pythagorean theorem-like formula, then that coordinate system is a rectangular coordinate system. Let's move on to discussing curvilinear coordinates. Suppose I have a point P in some coordinate system xi and Rn, whose coordinates in that coordinate system were given by x1, x2, all the way till xn.
Curvilinear coordinates. Suppose P is a point in a coordinate system. Why is it so difficult? Gee, why can't GR be simpler? Why does it have to be impossible? Poor Einstein, he had to learn this to just write his paper. So P is a point Okay, let's take a break. Let's watch YouTube. My brain is frying. How a solar eclipse in Mercury's orbit proved general relativity Andromeda.
It is 1918, and Einstein published his general theory of relativity just a couple years ago, and has yet to test it in a regime that will set it apart from Newtonian gravity, exchanging information on these
No, he already explained Mercury.
two theories, especially in regards to how they account for the orbits of the planets in our solar system. To that end, the following questions emerge. How was the theory developed? How does it explain the motion of the planets? And more specifically, does it solve the problem of Mercury's orbit? Now, an apple did not fall on Newton's head, but he may have watched one fall from an apple tree near his house. When he saw the apple fall, the light bulb that went off in his head was not
Hello.
No.
What's
What
up?
is up, my G? Your
Hey.
slave.
Hey,
How's it
hey, what's up? What's going on?
So what's the topic on the stream today?
Well,
Or if
your,
you're streaming.
your audio is like chopped, completely choppy.
Is that better?
I don't know. Not really. Try counting to 3.
1, 2, 3.
Yeah, there's like weird. It sounds weird. You can hear yourself in my stream. Here's a link to my. Oh, there's a link to my stream. Here's another link to my stream.
How
Click
does
on
that sound?
click. It's in the side chat. Click on the link in the side chat, and you'll hear yourself.
Okay.
And you'll hear what you sound like.
Okay, does that sound better?
You fixed it?
Did I? I'm trying to listen, but there's a lag on it.
Yeah, it's much better.
All right, that's good. Okay, what's topic on the mind today?
Anything you want to talk about? Have you ever been here before?
I think I have before. Yeah.
I don't remember you. Anyway, what do you want to talk about? I don't know. Anything. I'm doing GR.
Let's see.
I'm studying.
So,
Mhm.
what do you think about P. Diddy and this whole situation?
I don't know anything except that I know there was a video that he attacked a chick in a hotel and then
Yeah.
everything blew up. Because until then, no, we
Yeah,
didn't
that's
know
only one of the cases that was filed against him. There's like 120 other filed cases against him of sexual assault, and like half of them are minors.
What do you? Okay, I don't know what to say. It's really weird. I don't know.
Yeah,
Well,
it is.
yeah, but nobody complained until now. Everybody was he was like paying everyone off, so everybody was happy. I think.
Exactly.
Wait, no one complained. I mean, even that woman in the video
Yeah.
that he beat her up, like she didn't complain because he probably paid her. So
Yeah.
as long as everybody's happy, why is it? I mean, if it's minors and it's illegal, that's different. But he's like weird. Like, is he gay?
Yeah. Yes, he is. And like half of
Um,
them are men too that filed the lawsuits.
yeah, yeah. Gay men are bizarre. It's like I cannot relate to gay people, gay men. I mean, like I talk
Yeah.
to gay men who are like physicists, and it feels like they're doing physics because they're envious of straight men. It's like they're trying to like take revenge against the flat earth. Did you know? Did you notice that?
I haven't noticed many gay physicists. Was like Einstein a gay or some? I know he dated his cousin, right?
Yeah, Einstein wasn't gay. Hitler and Einstein were not gay. Hitler was into BDSM, that's for sure. But Einstein wasn't gay, wasn't into BDSM. But there's like one server that's called the Globe Gangsters, and they debate flat earthers. But the Globe Gangsters, they're all gay. It's a gay server. And I think the flat earthers are straight. So I think it's basically the tribe of the gays against the tribe of the straights. I think gays in general hate straights even more than straights hate gays. I think gays really hate.
Yeah, I don't really have beef with gay people though.
Right. But gays hate
I mean, I
you.
just think they're slightly weird for some reason because most of them I met just have this weird way that they talk and like they mention some things that are just weird, and they tend to hypersexualize a lot of things. Have you noticed that?
Of course. And no, but they have an inferiority complex. That's why they hate. It's like the same reason why there's anti-Semitism. It's like everybody's jealous of the Jews, so they hate them. So the gays are jealous of the straights. That's why they hate them. No, gays really hate straights.
Yeah.
Anyway, yeah. I mean, when you watch what's his name, MacFarlane, Seth MacFarlane, like
McFarlane.
he makes Family Guy. Family Guy, yeah, Family Guy. Like Family Guy, it's like 50% gay jokes. It's like take it easy, man. You don't have to shove it down our throat. We get it. You're gay.
Yeah.
Let's move on. Yeah. Anyway, what else you got? So yeah, I mean, if he's sexually violent, yeah, then he's gay, I guess.
Trying to think of other topics. And
What do you know about physics?
um, I guess I know like I took some physics like during high school and then a little in college, but otherwise I don't know too much.
You took college physics?
Only like the level 151, or that's what it's called in my community college.
So are you an engineer?
No, but I want to go into engineering when I graduate.
Hmm.
But I'm probably not going to do any engineering with a bunch of physics like quantum mechanics or something like that.
So what do you know about quantum mechanics?
Not that much. I just know that quantum computers are going to exist one day, and they work in such a way like don't the atoms get dictated by the electro waves or something? I don't know.
Well, I think quantum computers don't exist. I'm like to me it's nonsense. Most of quantum physics to me is nonsense.
Why?
It's because it's not even according to me, it's according to the people who promote it. I mean, they say it doesn't make any sense. Like they say the cat is both. Did you hear about the cat being both dead and alive? Do you know the story?
Oh yeah, I've heard that.
Right. So they say that quantum mechanics makes no sense. They say it makes no sense. They say quantum computers make no sense. It's not that I'm making. It's not I'm saying they make no. They're saying it makes no sense. So of course it's not going. It's not going to exist. Something that makes no sense will never exist by definition. So
So,
yeah,
so I don't really get the research that goes into quantum mechanics and stuff.
yeah, it's money.
Like if they can't even understand it, don't see the point of doing it.
Yeah, don't tell me. It's literally what they're saying. They're saying it doesn't make any sense, but they're investing billions and trillions into it, and they're convincing the whole world that it will work. That something that literally makes no sense is going to work. That the cat is both dead and alive. So according to them, right now, you're talking to me, and I'm both dead and alive. That not just dead and alive. I'm also here, but also on the other side of the universe. I'm everywhere all at once, all the time.
Yeah.
It's like it's complete nonsense. It's just complete nonsense.
Yeah, and it's pretty pointless too.
Yeah. And they teach
If
it.
you're not going to get anywhere with it, might as well quit it.
Yeah. and they think that they're the hottest thing since sliced bread. It's like they teach it, they write books, they make YouTube videos, and they call themselves science communicators and geniuses, and they give each other awards. Yeah, and it's all
Yeah, that's
about,
weird.
yeah. I mean, I don't
You know
know.
what I really hate is those physics people on the YouTube that
Mm.
like try to explain everything using terms that nobody understands. It's really annoying.
No, I mean, that's not the problem. I mean, it's like they have their own internal language. So once you learn the language, it's fine. But they claim it makes no sense. They say the universe is even weirder than we ever thought it could be. So to them, the universe is weird. It's not that their understanding is incomplete. No, they completely understand that the universe is weird. The universe doesn't make any sense, not to them, but the universe doesn't make sense. That's that's their claim to fame. These guys. So that's why I'm doing physics these days. I'm trying to, you know, st- I'm trying to destroy this nonsense. Try and stop, but I hope I can do it. So I'm doing general relativity these days. I'm doing tensor math. I'm studying the like Einstein notation, which is like really confusing. It's putting me to sleep.
I don't know. I've always found general relativity and special relativity to be pretty boring to study.
Uh,
Like I know the basic concept of it, but otherwise I don't really enjoy it.
no, special relativity is really easy, straightforward, and just wrong. General relativity, yeah. General relativity is like an extension of special relativity, but the math becomes really difficult. It's like curved geometry. My brain is like really falling asleep, really falling asleep. Like I sleep really well these days, let's just say that. It's killing my brain. Anyway, what else you got? What else? Well, whose side are you on with Israel? Let's hear.
Oh, that's a tough one. I've been a lot more pro-Israel since Iran and Hezbollah started attacking it because Hezbollah originally had a treaty in like '06 where they had to pull behind this river, I think.
Mm-hmm.
And they've recently violated that. So I think that Israel definitely has the right to go to Lebanon and attack them for that. I mean, it's a good thing that they killed their leader. That's pretty good.
Yeah, yeah, yeah. Do you think Israel should nuke Iran?
Oh, that's a tough one. I don't know because I want to say yes, but at the same time, I don't want the US to get involved.
Why not?
Because the US doesn't need to go into the Middle East again because Iraq failed, Iran, or did we have any intervention with Iran? I don't know. Afghanistan was a terrible idea, lost trillions of dollars because of that. And I don't think we should go back into Iran again. Wait, no, not Iran, Iraq. Or get involved with that. We can send funding to Israel, I guess, but they don't really need it.
Mm-hmm. So originally, the United States created Saddam Hussein. Do you know why? Did you know that Saddam Hussein is an American creation? He was an ally
I didn't know that. He's an ally. How is he an ally? What?
because the U.S. supported Hussein against Iran. The U.S. was fighting a proxy war against Iran using Iraq. Iraq was, keeping Iran busy. Because you see, now that Iran doesn't have Iraq, look at the mess it's creating in the Middle East. It's trying to destabilize the Middle East. So as long
Yeah.
as Saddam Hussein was keeping Iran busy, everything was fine. So the U.S. supported Saddam Hussein, even though he was like a Looney Tune, and he was like, I don't know what he was doing, like running around, like who knows what he was doing, but that was the strategy. But then the U.S. came in and destabilized Iraq. Basically, Iran basically took over Iraq. So Iraq now is
Yeah, that's
basically
true.
so now Iran has Iraq, and now Iran also has Yemen. Iran.
Yeah, Iran basically has control over everything except Israel in there. I would say Iran just needs to be stopped. If they were, oh my god, I hate soundboard so much.
Yeah, I don't know how to disable soundboard in general. Like, I
You
wish
have
I
to
could.
individually mute them. You have to go to their profile, right click it, yeah, and then you can see mute soundboard down on it.
I think if you mute one of them, then the rest will mute themselves. Wait, can you talk? Oh, sorry.
Okay, so if you want their soundboard muted, you should just right click their profile and you can see a mute soundboard button.
Yeah, but I'm sorry I muted you by mistake. I wish I could just disable soundboard on this server. Like, who needs a soundboard?
Yeah, it's really annoying.
So they just come and, oh no, I'm so sad I got muted. Oh my god. Okay, Vodka, what do you want to do? You come here, you make noise.
We were just debating in another server about veganism and how dogs should go vegan.
Dogs should. Wait, are you vegan?
Yes, I am vegan.
Oh, let me fix that for you. So why are you vegan?
Okay. All right, let's see what you got. So what's the argument for your non-veganism?
What's my argument for non-veganism?
Like, why aren't you vegan? What's your main objection?
Why should I be vegan? What? Like, you want me to do something? Like, give me a reason to do it. Like, why should I care?
You should go vegan because animals should not be killed, because animals being killed leads to nothing productive other than you get some steak in your stomach.
Okay, why should I care? Like, why should I care what I eat? Like, as long as it satisfies me, why should I care?
Because there's lots of CO2 going into the atmosphere if you're concerned about climate change. Going vegan is a better way to combat that. Also, I think it's immoral to kill animals for no reason whatsoever.
Okay, so let's take that one at a time. So I'm pro CO2. CO2 is plant food, and CO2 causes global warming. I'm pro global warming.
Yeah, I would think someone like you would be concerned about CO2 though.
I'm concerned that
but we can go into the moral argument then.
Wait, I'm concerned that there's not enough CO2. I wonder.
Why?
Because CO2A is plant food, and B, CO2 causes global warming, and I want more global warming.
Why do you want more global warming?
Because more global warming is humans can live in more places. Most of the planet, like, with more CO2 and more warming, oh, come on. Who did that?
People are here.
Did Disturbed EXE do that?
Yeah.
Goodbye.
Or continue about the global warming.
So global warming is terrific because, like, if you warm,
so we can live in more places. But what about the side, the coast, like LA, San Diego, New York, coastal cities? It's kind of important, man. There's a lot of people that live on coastal cities too.
They can move. Why should I care
yeah,
about
sure,
them?
they can move, but the billions of dollars of real estate would just go down the drain. Maybe even trillions.
Yeah, why should I care?
Because it's going to land our country in an economical crisis, and it's going to make things go up so much in price, and it's going to be a lot more condensed when a bunch of Californians move all across the United States into like the Midwestern parts.
Why should I care?
Why should I care? Okay, where do you live if you don't mind me asking?
I'm traveling out. I'm out of the U.S. right now. I'm not inside.
Well, are you from the U.S.?
I am an American, so So I'd like to go back.
Well, you should care because I think anyone would care unless they're like a multi-billionaire about the prices of regular food and groceries and insurance and real estate. Like it'd be important. So
Okay,
you should care about it.
wait. So explain to me why I should care, step by step. Like take one
Okay, the first
thing.
reason you should care is because
Mm-hmm.
if these coastal cities get flooded,
Mm-hmm.
there's going to be a lot more migration from these people in these coastal cities into the US, like the Midwestern states.
Mm-hmm. And I should care because
It's going to increase prices of real estate. It's going to increase prices of groceries and
Okay.
everyday items.
wait, okay, so it's going to increase prices of real estate?
Yeah.
Why would it
If
influence?
trillions of dollars of real estate just gets flushed down the rain.
Mm-hmm.
Well, no, I'm talking, Divine, I'm talking about global warming. He doesn't care about CO2 and he thinks it should be increased for some reason. But as I was saying, it's going to make real estate cost more because trillions of real estate,
Wait.
trillions of dollars of real estate
Wait,
is just going down the drain.
wait, who are you talking to? Divine?
Yeah, person in the side chat.
Is he okay? Divine. Why is Divine muted? I'll give him a chance. Wait, he's muted for me only, right? I don't see that he's muted on.
It's a person on mute.
Oh, she was muted. She muted herself. Okay. Yeah. So what's the question? So you think real estate prices will go up?
Yes, real estate prices will go up. Trillions of dollars of real estate going down the drain will lead to higher prices of real estate in certain places such as the Midwest.
How do you know?
Okay. So for an example of this, let's just say that half of the cars of Tesla go missing.
Well, but
The remaining cars are going to have more value to them because there's going to be less of them in the first place,
okay,
or less of them now
all right,
versus when they were there in the first place.
okay. But what if?
And when trillions of dollars of real estate just goes away,
Okay,
it's going to make the current real estate that's still available in America more expensive.
why should I care?
I just explained why you should care. If you want to buy a house and move, like, what state are you from? I'm just curious.
New York.
Yeah, New York is going to get fucking flooded if you don't move to the Midwest. And if you have to move to the Midwest, you're going to have to purchase real estate in there if you want to get a house or something.
New York is gonna get flooded. New York City.
Yes, if climate change continues to go up and you want CO2 to continue to go into the atmosphere, you want more of it in the atmosphere so more of the world is habitable.
Wait, slow down. So yeah, I want, if there's more CO2 and more global warming, more of the world becomes habitable.
Yeah, which parts of the world? Nowhere in America.
I don't care. Why does it matter?
Are you just going to move out of the US into like where would you plan on moving?
Like you can
Or
even.
let me ask you this.
Mm-hmm.
If global warming were to get exponentially, if CO2 emission went into the atmosphere at a much higher rate,
Mm-hmm.
where would you plan on moving that wasn't habitable in the first place?
No, that's not the question. The question is if there is sea rise, right? That's what you're asking. You're assuming that.
Yeah.
You're assuming. I would say almost everything you're saying, you're assuming, right? You cannot derive anything from first principles. You're just repeating talking points, hearsay that you've heard. Like you don't know any of what you're saying. You're just.
Well, based on logical reasoning and
Mhm.
past events, you can usually conclude something to be true, but you have to give an estimate about it.
Mm-hmm. Okay, so you think more CO2 causes what?
Higher prices of real estate because if coastal cities get flooded, millions of dollars of real estate, billions, no, not millions or trillions or billions, it's trillions of dollars of real estate will go missing. And if said thing goes missing, the remaining things are going to cost more. And this principle is found in like everyday products. Like hay getting washed away which I've seen this myself, the hay prices will cost more. Water being more scarce, whatever. I don't know the word for it, sorry.
Mm-hmm.
But you know what I mean. Water can be more expensive if there's less rainstorms and less evaporation because you'd have to derive it of the city or existing rivers.
Okay.
So when there's a lack of something, the remaining something will be more expensive. That's just a general principle. So
Right.
if there's less real estate, then there's going to be more expensive real estate,
Right.
which is going to be a problem for most people because I assume you're part of the working class or something.
It doesn't matter.
Like I'm just assuming, but I
Mhm.
don't think you're a multi-billionaire.
It's irrelevant to our discussion. So
It is because if you
why?
can't afford real estate how it is already, it's going to gouge and it's going to go way up in price if the coastal cities were flooded. So I think any American that's in the working class would care if real estate increased in such prices and they had to move to the Midwest.
Mm-hmm. Okay, let's because I have no idea what you're trying to say. So let's go so I agree with the principle of economics of supply and demand, that prices tend to be the cross section between supply and demand. That I agree with. Now, what you said, that if if trillions of dollars disappear in one instant, yeah, it's going to create a shock through the system that will cause
Yeah.
prices to skyrocket instantaneously. Yeah, I agree with that. Yeah, but that's I don't see any evidence that anything like that anyone is predicting anything like that. So what we're talking
Oh yeah, it's not
about,
going to happen instantaneously. It's going to happen over time. But if the sea levels continue to rise up, some of New York City is going to be flooded.
yeah,
And there's no good hills or I guess it would take time for all of New York to be flooded.
yeah, but we're talking
But if that real estate slowly disappears, it's still going to have the same exact impact. It's still going to be trillions of dollars that go missing.
yeah. So, but what you're talking about is a very slow process that has there's many ways to deal with it besides just giving up on the land and moving somewhere, which is an acceptable solution. Humans are always moving. But
Well, yeah, but the only other solution that I see is
Mhm.
combating climate change and lowering your carbon footprint, which that's what veganism essentially does.
Veganism doesn't do any of that, but that is maybe you're right, but there is plenty
Well,
of
there's plenty
other.
of evidence that CO2 emissions are caused by factory farming.
We can get into that. I haven't seen any evidence of that, but we can deal with that. But right now, let's assume CO2 keeps rising, and let's say, right, we're making assumption on assumption on assumption on assumption. The whole thing is just a list of assumptions, each of which is incorrect. But I'll
Each of which are incorrect.
yeah.
I just provided good logical reasoning for thinking that that would be the case.
Look, all you're doing is you're repeating what everyone says, but what everyone says is complete nonsense. There's no
It's just complete
evidence.
nonsense.
Yeah, I used to
Why?
believe. I used to be a global warming believer like you, so it's not like I woke up.
Hello.
Hello.
What do you mean with global warming believer? Do you not believe that global warming exists?
He believes it, but he thinks it's a positive thing.
And I don't believe it. I don't believe there's any global warming, but if there were, I think it would be terrific, incredibly terrific.
Incredibly terrific. There is still global warming, but it can be on lower amounts. Like, for example, CO2, carbon emissions, drying of land in warmer climates, having more rainstorms, having less rainstorms, having overheating, all those kinds of things. They all include with global warming. Do you believe that's not happening because of human carbon footprints?
I'm sorry, I was texting someone. So in general, I said I don't believe there is any evidence for global warming. But if there were global warming, that would be one of the best things ever for humanity.
Who emits
Okay, so why don't you
CO2?
believe any evidence that there is no CO2 emissions going into the atmosphere and causing global warming?
I mean,
On
there
what evidence do
is
you base that on?
no. I mean, of course, there's CO2 emissions. Right now, I am breathing and exhaling CO2. So of course,
No,
there's
you're exhaling air. CO2 isn't exactly air. CO2 come with CO2. Air what we're breathing is made of CO2, but it isn't exactly if you were to breathe CO2, your lungs would get damaged.
wait. So when I exhale, right? When I inhale, it's air, and what I need in my body is the oxygen part. My body takes the oxygen and combines
Yeah,
it with.
but you're
1 second, just
But first,
wait.
CO2 is everywhere in the air, but because we have nature and those kinds of things, and I don't know the process what it's called, but we get clean air because of plants and because of if you're in a good climate and those kinds of things, you would normally get good air. If you were to breathe pure CO2, it wouldn't. And you can't say from that reason why we breathe good air is because of our climate right now. Because reason like for example with trees with trees you breathe you breathe more oxygen from those because they reproduce oxygen from CO2. They take it out and then they leave the CO2 into the air again.
Okay. But when I exhale, I take that CO2 that the trees exhaled. I take the oxygen, right? I take the oxygen that the trees exhaled. I inhale the oxygen, and I take the food that I ate that is carbon, because when I eat meat, meat is just a bunch of carbon molecules. So I take the carbon, my body takes the carbon, combines it with the oxygen, and creates CO2. CO2 is carbon dioxide. And then
Yes, this is what's your point.
I
You don't when you consume meat, there isn't a lot of carbon inside of meat. There is little amount of carbon that we can consume because it's in a product. It isn't in the air. If you breathe it from in the air, you'll get poison from it. It's the same. I'm not a vegan. I'm just here because it's fun. But if you were to let's say you would eat ice cream, how they make ice cream is they put nitrogen in some kind of things to make ice cream like round and to have it look like that. If you can still eat it if it's in a product, but if it's in a low amount of product, it doesn't matter if it doesn't matter. Well, don't get your point with carbon dioxide because yes, it's still in meat, but that doesn't mean anything.
wait. So when the way humans live is they consume carbon, like meat is carbon. We consume carbon and we inhale oxygen. The body combines the carbon with the oxygen, creates carbon dioxide. It's carbon with two oxides, two oxygens.
Chocolate and coffee are more in carbon, but we don't consume a lot of that. Are we now supposed to eat a lot of coffee, drink a lot of coffee, and eat a lot of chocolate? Then they have higher carbon than meat.
Everything we eat, as far as I know, is carbon based.
Not everything to an extent. Yes, everything has carbon in it, but it still has. But there are the things that still has the most carbon inside of them, and meat is not like the top thing. And there's also, so I don't get your point. What you're talking about with carbon, because there's everything where we consume there's carbon inside, and I don't know why you're talking about meat. Why meat is one of the lowest things for carbon right now. There's more things that are higher in carbon than meat. The most carbon in meat is from lamb.
It's from land?
Lamb,
Lamb?
mutton. Yes.
As far as I know, everything we eat contains carbon.
Yes, but it has a percentage in it. So I
No,
don't get your point what you're trying to say with carbon, because everything has a percentage in it and we can still eat it and we can still choose to not eat that carbon even if we do not want to, because of the percentages of carbon that is inside of it.
wait. No. Everything we consume is carbon based. There's nothing you consume except for water. There's nothing that you consume that is not carbon based. Everything we consume is carbon based.
Yes,
Everything.
I just said that, but there is percentages in carbon that our food has. It isn't 100% carbon.
Yes, it is.
There's percentage. No, it isn't.
What else? Okay, what molecule do we consume that is not carbon based?
I'm not saying that we don't consume. We do consume carbon because it's in every kind of food, but it's not. But
Yes.
it's not a big percentage in a lot of foods.
I think
It's the highest in coffee or in chocolate. And if we're talking about meat, carbon in meat, lamb comes there, but it isn't. But there aren't like 100% percentage of only carbon inside of meat, because if we were to eat 100% carbon, we would die of it, because our body can't take a lot of carbon. That's why we take oxygen, and mostly oxygen when it's a facility, it can take a lot. It can also sometimes have a lot of low carbon. It doesn't exactly have a lot of. I'm sorry, I really don't get your point, what you're trying to make, because you keep saying yes, everything has carbon inside of it, and it does, but at the same time you keep repeating yourself, like you said to sheep, that you keep pulling up something, and you're not changing from what I'm telling you. You keep saying yes, everything inside carbon, every in every kind of food there's carbon, yes, but there's a percentages to carbon and percentages to carbon that we can
no,
consume, that we
no,
will still not be that we can still not eat.
no. As far as I know, there's no percentages. Everything
There
we
is.
hold on,
It's
What?
in kilos.
hold on,
It's in kilos. Look it up.
hold on. So as far as I know, everything we eat is 100% carbon based.
No, it's in kilos.
I don't know.
It isn't fully. It isn't fully 100% carbon. It is a carbon base, yes, but it's not fully. It's not fully.
So I asked you, so besides carbon-based molecules, what other molecules do we consume? I asked you a question. Just inform
Um.
me.
No.
As far as I know, everything we consume is 100% carbon-based.
Hydrogen.
What do you mean?
We consume H2O, which has no carbon base in it.
Yes, I said besides water. Sure.
But yeah, I like sparkling water though.
Sure. So humans do
L-carnite. I'm looking at. I'm trying to find it because I think that
look, it doesn't matter. As far as I know, either look, you can come
it
back.
does, because you're saying something. Well, you're saying I think it's that, and then I'm trying to look it up, and then you're saying no, it doesn't matter. Hi, bitch.
I bet. Look, it's as we can continue talking right now based on what I know, and I'll explain to you my position. And when you have more information, you can come back and teach me. But
No, it's
mhm.
we have acetin, moisin, microfiller,
What do you mean?
saccharimatic proteins.
Proteins are carbon.
Those are
Proteins are
no sacra.
hold on. Proteins are carbon based, as far as I know.
Yeah, I'm looking it up. From what kind of molecules do we consume in meat?
I'm not even.
Acetin, moistin,
I'm not-
we're opinion of meat because I still don't get your point why you were bringing up carbon inside of food. We all know there's carbon inside of food,
'cause-
but I'm bringing up meat because you also brought up meat. Inside of meat, it contains 20% of protein, which is 12% of structural proteins, acetin, moisin,
Hold on.
microfilar,
Wait 1
and
second.
there are 6 soluble microplasmatics
Wait. I
found
don't.
in the muscles and juices.
Divine. Slow down. So when you say protein, as far as I know, that is carbon based.
Not completely.
I didn't based. I said based. Carbon based. It's based on carbon. There is like a carbon ring that every organic molecule is based on. And we only consume organic molecules. Organic just means life. So all
Yes.
plants and all animals are organic. So when you eat a plant, that's carbon based. When you eat an animal,
It's 2 micrograms of carbon inside of protein.
no. Protein is
Yes,
listen, hold on.
I looked it up. You're saying something that isn't accurate. You're saying that protein is consumably more just carbon, and I'm looking it up right now,
Protein,
and it is not completely.
as far
And
as
you can
I
say you have information, but I think information from the internet is better than your information when you were saying climate change believers and all of that.
okay, I'm gonna ask ChatGPT, is protein carbon based?
Yes, but you can ask ChatGPT anything because
So
if you
ChatGPT says
ask
yes, proteins are carbon based molecules.
yeah, but you can't bring up AI into a debate because you can ask AI to give an answer for anything.
So
There is carbon inside of protein,
no,
but
but
it isn't
it's
fully but it isn't fully carbon.
I didn't say it's
You
fully.
can bring you
I
said
did-
you
no.
said that, and you can bring AI into this. I can bring up perplexity into a debate, but I can't bring it up because I can ask perplexity to give me an answer for anything I'd like to know, even if it's a small percentage, and it's not helping me in a debate. It's just making us tattletale against each other again.
Okay, what are we discussing right now? Because look, I don't
No,
know.
I'm just saying you shouldn't use AI when you want to ask something. You should rather use just Google, because you can ask AI anything and you can't just say, oh, ChatGPT said this and that. You can't just do that, because if you would do that, then you would win every debate. But the thing is, you can ask an AI source to give you an answer for anything you'd like.
Okay, Divine. Listen, please, let's slow down. So, where do you want to take this discussion? Because we're like at a stalemate. So, you want to come back when you have more information?
No, I'm staying. I'm perfectly
No.
right
I'm not.
staying. No, I'm staying.
I'm not
I'm
saying.
staying.
Okay.
I'm not saying you should leave. I'm saying like, this specific discussion is at a stalemate. So, you tell me like, I don't know. I don't know what to do when the discussion is at a stalemate. I just don't know what to do.
Well, it's a back and forth of yes and no
Yeah.
at this current moment.
Yeah. So
Yeah,
I don't want to.
that is true.
Yeah.
Yeah, well, yeah. All right, yeah, I mean, sheep, do you want to say something about carbon? No, I guess. Or what he was bringing up? I don't even
Well, I
fucking know.
already did what his assignment. I already answered this question. Name a molecule that we consume that isn't carbon based. Which
Yeah,
I
but
did.
he meant it in food, because he thinks what we eat is fully carbon, and there's not other molecules inside of it.
Most proteins are carbon based, I think.
Yes, it's not fully carbon.
Yeah, that's the point.
Yeah.
Okay. Look, my point being that we humans, we consume carbon for energy. Besides consuming carbon for other purposes, we also consume carbon for energy to run the body. So the way it works, as far as I know, we consume carbon and we consume oxygen through the air, through inhaling air. We take the oxygen, we mix it with the carbon inside our bodies, inside our cells, and the body creates a molecule out of the carbon atom and the oxygen atom. The body combines it and creates the carbon dioxide molecule. That goes into the blood and into the lungs, and then we exhale carbon dioxide. So I'm always creating carbon dioxide because I'm alive. So as long as I'm alive, I'm creating carbon dioxide, and then that carbon dioxide goes to basically the ocean where there is plant life. This CO2, this carbon dioxide from my lungs, goes into the ocean, into the green plants in the ocean, and they inhale, they absorb the CO2, they take the carbon, and they dump out the oxygen. And that oxygen, then I take it back and I continue. And then I go to the sea and I take the plants from the sea and I eat them when I eat sushi, or the fish eat the plants and I eat the fish, and so on. Or there's the same goes for grass. The grass grows because it absorbs the CO2 from all the living creatures that exhale CO2. The plants absorb the CO2, they keep the C, they keep the carbon, they dump the oxygen. And when they keep the carbon, they grow. All the plants, that's how they grow. That is wood, and that is a plant. A plant is carbon based. So what we exhale, the CO2, the plants absorb it and grow. And then we go and we eat the plants, or we eat the cows that eat the plants, because the cows eat the plants. And the plants are carbon that everybody exhaled. And then the cow is just carbon. It ate the grass. The grass is just carbon from the air that we exhaled.
Okay, so what would happen? So what would happen if you ate some of that and didn't eat any carbon?
No, the
Would that be
point.
carbon based?
The point. This is this is just a carbon cycle. This is a carbon
You
cycle.
keep bringing up carbon now.
What?
Nothing.
So this is the carbon cycle, and this is the cycle of life. So carbon is life. Now, if you add more carbon into the system, you're just going to grow the system. You're just going to have more plants and more animals. Right? The more carbon you add into the biosphere is all the animals and all the plants on Earth. That's called the biosphere, which is carbon based. Now, if you insert more carbon into this system, you just grow the system. You just have more life on Earth.
So the more CO2 we put into the atmosphere, the more life there will be on Earth.
Exactly.
So that's why CO2 emissions are a good thing.
That's right. And by the way, you can never increase the percentage of CO2 in the air, because any increase in the air gets absorbed into the biosphere. So as much CO2 as you insert into the air gets absorbed. So you can never grow the CO2. So the CO2 cannot go up. Theoretically, it cannot go up. There's, as far as I know,
Yeah, theoretically, but that's obviously contradictory to the studies that have been done.
well, if then these studies, I need to see the data and so on. So as far as I know, CO2 cannot go up. And if
Yeah, I sent a link in the chat.
Okay, but if CO2 does go up, that's a great thing. That means it's going to get absorbed and we're going to grow the biosphere. We're going to have more plants and more animals and more plants and more animals. So it's a great thing. And food is going to be more abundant and cheaper. And since CO2 can never rise, therefore it cannot cause any global warming. But if it could cause global warming, that would be terrific, because that would increase the
So
geography.
what causes the global warming then?
There's no evidence for global warming that I've seen.
I just showed you a link in the chat.
Excuse me. What?
There's no
There isn't a
evidence for
global
global warming.
warming.
Yeah.
There
it-
isn't.
There's
What?
obviously a global warming. Whether humans or not, humans or
what's
not cause
what's
it is the question.
show me the
There.
raw.
Nobody denies global warming anymore. But there's a link in the
Yeah,
chat.
I
as you said.
deny.
It was a study done by NASA.
No, show me the raw data. I don't care about NASA is a government agency with its own
Oh
Yeah,
no,
well,
you're one of
interests.
those people.
oh no.
I just explained to
Get it.
you it can never happen, and I've never seen. Show me the raw data. Show me the raw
There
data.
isn't raw data that we can find because
Why?
most
There's raw
most
data at the
normal.
bottom. There's plenty of references because it was a meta-analysis.
Alright. Because I mean, like most people don't exactly when they look for data, they don't
But I
exactly.
said
I
already,
must find raw
and
data.
it's look. There's no raw data, or there is raw. Show me the raw data, but it doesn't matter if there is global warming. It's the best thing ever. So you're
Why would global warming
Okay,
be
once
the
again,
best thing ever?
economically, it'll
just
bring us
finished.
into this giant shithole.
Look, there's in order to in order to convince me, right? What you need to convince me is not that there is CO2 increase or that there's global warming. You need to show me so many things in order to convince me to do something about it. That the list of things you need to convince me of is very long before I would think to do anything about it. Like even if there is global warming, it's a good thing because it grows the
Yeah, which I just
biosphere.
explained to you earlier that real estate will go up and skyrocket in prices if there was global warming and there was coastal floodings. Also, another thing to notice is that groceries would cost more because there would be less land to grow things on. So
Not
that
to
would be
mention,
also another net negative
not
for
to
society and
mention,
the
not to
economy.
mention,
And most
not to
of
mention.
Northern Europe would also be sink down, and like
Yeah.
27% of the Netherlands would be too. I forgot the exact statistics, but
It's 26.
it would be terrible for the human species, which that's what I think good means. Good is a net
And
positive for the human
it's
species.
not only the Netherlands, it's most north countries in Europe. That will be Singtown because most north countries in Europe are lower than sea level. Yeah, because how we made the land, and basically we have a lot of dams in North Europe to make sure we don't flood. But if global warming would rise and we would get let's say more bad weathers and those kinds of things and all that, we would just flood. I think a month ago we also had that where just the whole world, just a whole province close to the ocean just completely flooded because of the weathers. It's so changing, and you can't just say global warming isn't real when it's affecting not only the countries that we're talking about, like the America, and the small things where Sheep is talking about, like prices and all those kinds of things, where there's a multiple of things that is being affected due to global warming.
Okay, so what do you call it when you debate someone and they bring up many points that they overwhelm the discussion? Now I need to respond to each and every point. So what do you call it?
Okay, so the first point that I already mentioned, we already explained earlier, like the whole real estate thing, when we can both agree that according to supply and demand, it'd likely be the case that real estate would go up if there's coastal floodings tomorrow.
Wait, what do you call it? What do you call it when you don't know this? Overwhelm.
No, because there's probably some sort of logical fallacy, but we both brought up different points, and I brought up one specific.
1 second. What do you call it?
Is this man trying to be rude?
Oh, it's called gish galloping. So you're gish galloping.
Yeah.
Gish galloping.
Sorry for
All
gish
right.
galloping you. My
Yeah.
fault.
So we need to slow down the discussion. Also, when it's 2 on 1, so if one speaks, then I have to be able to respond. Otherwise, it's the other, like you are on the same side. You're going to bring up again 2 points, and then now again, it would be gish galloping. So if one of you talks, then I need
But
to be
we're
able.
oh,
I mean,
my
I'm
my
glad Define's advocating for it. I've been trying to convince her to go vegan for so long.
I'm not
And this
going
is an
vegan,
argument
but
for veganism.
I'm not going vegan, but I do agree with global warming, and we are letting you speak. That was my mistake that I just didn't let you finish. But I mean, when Sheep says something and then you're done, I say something, or when Sheep isn't speaking and you're saying something, we aren't talking over you. Just because it's 2 versus 1, that doesn't mean anything right now.
No, but if one of you brings up a point, then I need to be able to retort, and then the other one can bring up another point. If one of you brings up a point, and then the other one brings up another point, now I need to remember the 2 points. So that's gish galloping already. So
But isn't that what we were doing? I mean, you guys were talking about the economics of global warming, like for example, rent, prices of food and groceries and that. And then when he was done, and you began again, I then interrupted you. I'm sorry for that. And then I brought up that there's a lot of things that outside that are affected due to global warming. How are we? We weren't doing that. I don't get it. All right.
no, I was just saying because Dr. Alpha was gish galloping. He brought up multiple points, and then
You
Well,
are
what I
also
meant by the
bringing
first
up
point was I
multiple.
already implied that in the first time we were arguing about global warming. Like I already argued for that point. There was a whole nother point that I was talking about was Northern Europe would sink,
okay,
and that's the other point I was talking about. We already mentioned the whole real estate thing.
it's fine to mention, but it's insignificant if I don't get a chance to discuss one point until like we resolve it. Like you need me to concede on one point, and we need to like talk about one thing. It doesn't make any sense to bring up like a lot of evidence. We need to talk about one piece of evidence and dismantle that and decide, is this good evidence, yes or no? And that should just be the debate. Like if there's any
Okay,
other,
so what? So you don't believe in global warming? Let's settle that one first. What do
I
you call
didn't,
raw data,
I
and how
did,
should I
it's not,
take it with you?
I wouldn't present it like that. So in general, yeah, but what does that mean? It means that as far as I know, there's no evidence for CO2 increase. Theoretically, it's impossible. There's no evidence for temperature increase. Theoretically, it would be a good thing. There's no evidence for sea rise. Theoretically, I don't think it matters. And then, okay, now, but yeah. So in order to convince me to right, because this discussion started from please be vegan, or I should be vegan because of global warming. So my response is global warming is a good thing if it existed, if, right?
Yeah.
So if you want to
Okay, so
convince me of global warming, then you pick your best point where you think I'm telling you that you have to go through a lot of steps in order to convince me to want to do something. So pick
okay, so
one.
the first step to go is we need you to believe in global warming first. So why don't you believe in the study I just sent you? And what would classify as raw data? Because that was your objection to the study.
So let's slow down. So what's your question? Ask me one question, not
Why
two.
do you object to the study? And your claim was that you object to the study because of raw data. So can you tell me what raw data is?
So again, you're not asking one question. So ask me one question.
He
Okay, tell
is.
me what
I'm
raw data
sorry.
is, okay?
I'm sorry. It's just being annoying. He is asking one question, and he's bringing up something that you said to that question.
I'm not denying anything.
No,
I'm
I'm
not.
you
gonna
aren't
lose my
denying.
mind, man.
I'm not saying you're
I'm,
denying, but you're being annoying. He's asking you one question and bringing up something of that question.
Okay,
When
the
he
question
brought
is,
up us,
what is raw data? That's all I'm asking, man.
all right. So you want to know what is raw data?
Yes.
That's a good question. Let's start with the very collected data, the very data that was collected. So as far as I know, we don't have access to any raw data. All we see are
Okay, then we shouldn't believe in anything.
Wait, let me just finish. You asked me about raw data. So as far as I know, we have no access in general to raw data. So scientists, when they publish papers, they don't publish raw data, period. So in general, whenever there is a scientific study, there's no raw data. So all the data is already is processed, meaning it's been massaged. So that's already a problem because I want the raw data. I want, show me the raw data. Show me everything, all the outlier, because usually if there's an outlier, they remove it. They call it, they clean up the data. Don't clean up. If you clean up the data, don't show me anything. I'm not interested. Show me everything or show me nothing. Like I'm not a little baby. I don't need you
Yeah,
to
which I can't show you anything because your definition of raw data already said that raw data doesn't exist in the first place. So if raw data doesn't exist in the first place, how can we base any of our scientific evidence on anything? Because we can't see the raw data based on how you defined it.
I never said that. I said
You did.
You just said we can't see raw data.
I didn't say we can't say. I said in general.
You said.
No, I didn't. I'll repeat. So I said, as far as I remember, this is what I said. And if I said something else, then I made a mistake. I'll say it again. Hopefully, this time you can stop me if you see that I'm making a mistake or something. So, in general, as far as I know, when scientists publish papers, they don't show us the raw data. In general, as far as I know, when scientists publish scientific papers, they don't show us the raw data. To which I say, either you show me everything, including the raw data, or don't show me anything. I don't care. That's all I'm saying. Questions?
Okay, so the raw data, you want to see the raw data, but it's not usually found within scientific studies.
Yeah. So don't show
So
me.
you want something that's not generally found in scientific studies. That's what you're asking for.
Well, if you want to present, right, you're showing me NASA's, let's say, paper. So unless you show me the raw data, don't show it to me. I don't care. Why should I
There's
care?
plenty of raw
I'm
data
not asking.
technically in
What?
the links below because the work cited should have some sort of form of raw data, but I'm not going to go through every single
Look,
80
look.
cited work that
Okay,
they
it's
just
fine.
put in.
I'm not complaining. I'm just saying either show me the raw data or don't show me anything. I don't care.
Okay, I think I found it.
Okay.
Let's
First,
strongly the
first of
record
all,
over
one thing about
Fleming.
one. Oh, all right. I'll let
No,
you
you go,
finish.
you go.
Uh,
I'm reading the
okay.
study right now.
First of
That's
all, with raw data, and sometimes somebody who's speaking, who wants to go into those kinds of fields. Mostly with raw data, you do get public information, but but it gets minimized in information. Let's say there's a scientific study they do on us, on our heart. They do give you the data, but they give the data to an extent that it can be minimized into a form. Most raw data would be pages long, but they minimize it. We can't call exactly a raw data, but it is data that is true mostly, and it's certainly true from by NASA.
okay.
And it's minimized. It's not
Okay.
complete. It's not complete because they're trying to minimize it because then they can publish it online. Because I don't think because there are regulations around how much you could publish from one thing.
Look, I just went through this paper. There's no raw data. There's just graphs. Graphs is not raw data. I need raw data.
Okay, can you define raw data? Like, what would be an example of raw data? Can you give me that?
I
Can you
I
give me an
want
example? That's the question.
it should be in an Excel sheet. I don't want a graph.
In an Excel sheet.
Like an
Okay.
Excel, a
So
CSV, like just the data. Anyway, but
I think I showed that. Did
no,
I not?
there's no raw data. I mean, there's no Excel sheets. There's no data. It's just graphs. But that's the first.
Excel sheets
Okay,
of.
but what are you claiming? What are you claiming in this paper? What's your claim? What are you trying to say in
My
this?
claim is
Yes.
climate change exists, or I guess we started with veganism. So the proposition would be veganism is moral and should be an obligation because of climate change existing and CO2 emissions needing to be reduced. And if you don't reduce CO2 emissions, it would be morally wrong because it's negatively affecting the human species. Okay, I think this might be what you're talking about, but sheet data. Sheet. Okay, trying to find something.
No graphs.
I think this might be what you're talking about. I might
No,
have.
but no. Look, your proposition is very long, so let's narrow it down. Let's just talk. Let's forget about
Let's
veganism.
narrow it down to climate change right now. We're going to talk about if climate change exists or not, because you have an objection to that, and then we're going to talk about if climate change is a good thing or not. So that's the entire structure of it. We already talked about how climate change wouldn't be a good
So
thing
what?
due to economic reasons and economic principles. And
Okay.
then we're going to explain how climate change is a real thing based on data and what you call raw data, which I just sent in the side chat if you want to read that.
Okay, so please refrain from monologues. I'm trying to just narrow down a proposition.
God.
So your
I'm
proposition.
sorry, but I want to ask something. What kind of debate do you want to have? Because sheep is just giving you the data, and then he's trying to then give you other data because you don't believe in graphs. And now he's explaining what he wants to discuss about with you, and no need to go into monologues. What kind of debate do you want to have? Because
No, like
It's very strange. I don't think I've ever debated someone like you.
look.
yeah, I'm just curious.
So I just like I'm asking for now. Let's narrow down the proposition. So give me like a short sentence. What's your proposition? Make it like in a few
Climate
words.
change is real.
Okay, climate change is real. So good. So how would you measure? By what metric is climate change real? What's your metric? How do you measure?
Based on global warming.
Okay, so what's your metric? How do you measure global warming?
By measuring the temperature of the Earth like 100 years ago and comparing it to now.
Okay,
If there is a warming and there's a change of temperature that's going upwards, then we can call that global warming. That's my definition.
okay. So you're going to show me that over the past 100 years, there is a trend upwards.
Well, that's just an example of 100 years. So it can be 10 years, 5 years, anything, and it would classify as global warming technically.
10 years, 5 years?
Yes, because there can be data showing that the temperature of the Earth is going upwards. And if that's true, according to the data,
What?
over 5 years or 10 years, because it'd have to be over a time period that's long enough to record that data,
Hold on.
we can call global warming true.
Okay. So what is your theory? So like the way the scientific method works is the way I define it. So we noticed a phenomenon,
Wait, this.
right? You want to have a
Okay, go ahead.
I'm assuming you want to have a
So the
scientific.
scientific method is based on what you say.
I mean, you
right?
want to have a scientific discussion, I'm assuming, right?
Yes, but the way you're wording it, it's a bit funny.
Yeah, but okay, we can have a scientific method conversation. So you want to know my theory of climate change and why the temperatures are going up, right?
Yeah, I want to hear the theory.
So the theory of climate change is that the temperature is going up due to CO2 emissions going into the atmosphere. And this is confirmed by a lot of scientists out there. And it proves my point further using data from them. It's not my theory specifically, it's their theory.
Okay. So your theory is that there is CO2 emissions. You started with that?
Yes, there's CO2 emissions. And there's
Okay.
evidence of CO2 emissions.
Okay. So this is where we discussed that I am currently emitting CO2. So there's nothing new about that. So I don't understand your theory of global warming.
Yes, but we're all admitting CO2. But
Yeah,
we
all are.
as
You already said this earlier.
we as humans we emit lower CO2 that we couldn't do any damage.
What? Wait, what?
No, we as humans we emit lower CO2. So, for example, cows emit much more CO2 when they in their feces than we do when we breathe.
I don't understand. Right, we already said that's the cycle of life. So when you tell me cows emit CO2, I already explained to you that that's part of a cycle. So that certainly cannot be part of a theory of increased CO2, right?
No, but you kept talking about that we admit that you said before that we admit CO2. Yes, we do, but we don't admit an substantial amount of CO2 that we could cause any potential damage.
Hold on. So humans emitting CO2, cows emitting CO2, any animal emitting CO2. I already explained to you the carbon cycle. So a carbon cycle by definition cannot
Oh my
increase.
God.
What's the question? What's the problem?
No, I'm not.
Yeah.
Oh,
So
continue.
you wanted my theory of CO2, which I'm going to give you my theory real quick because this is based on some other scientists' data rather than my own theory that I came up with. So CO2 is a greenhouse gas, meaning it traps heat in the Earth's atmosphere.
No.
Other greenhouse gases include methane,
No.
CH4,
No.
and nitrous,
Wait, no.
which
I
human
asked you.
activities are the primary source of increased
No.
CO2 emissions.
No. Hold, stop, slow down. I'm not listening, so
Okay.
stop. So your theory of global warming depends on increased CO2, right? In the atmosphere.
Yes.
Okay. All right. So you would still have to prove that increased CO2 in the atmosphere creates global warming, but we'll get back to that. For now, you need to prove that there is increased CO2 in the atmosphere. So first you
Yeah,
need
look in the chat.
Yeah, I saw. So first you need to give me the theory by which there is increased CO2 in the atmosphere. What is your theory? Where's the increased CO2 coming from? Or what is causing
Increased CO2 is coming from fossil fuel burnings, factory farming, deforestation, and other industrial processes. Anything that's a sort of an industrial process that manufactures a lot of things by burning fossil fuels such as oil, gas, coal. That's all producing CO2 emissions, which goes into the atmosphere.
All right, let's break that apart one at a time. So what produces, let's say, the most increase in CO2 in the atmosphere?
Fossil fuel burnings, most likely. According to data, it'd be fossil fuel burnings.
Okay. So
I also sent something in the chat about a scientific study about the global monthly average concentration of carbon dioxide in the atmosphere that it has risen.
yeah, but first we need a theory. If we don't have a theory, then it's not scientific.
Yeah, I just gave you the theory, by the way.
Right, yeah. So the theory, wait, there's a message. Who is that? Okay, so you're saying that the carbon increase is from fossil fuel burning?
That's the primary source of it, yes.
Okay. And where are the fossil fuels coming from? Do you know?
I just mentioned some of the fossil fuels, which include coal, oil, and natural gas. So they're coming from the earth itself, but they're being burned. Like coal in a mine is not being burned. It's when it's used for like locomotives and shit like that, where it actually gets burned. So when it gets burned, CO2 emissions go into the atmosphere. When it's not burned and it's in its default state, it's not going to start burning up and emitting CO2 emissions.
Okay, hold on. So you said the rise in CO2 and atmospheric CO2 is due to fossil fuel burning. And I asked you, where do fossil fuels come from? And you said it depends on, and then you gave me a list. So give me the number one if you want, or whatever you want, and tell me where it's
Okay,
coming
we'll
from.
do natural gas or coal.
Natural.
Let's just do coal.
Let's do
do
coal.
coal instead.
Let's do coal.
Okay, coal comes
Okay.
from the earth, it comes from mines, but it doesn't release CO2 emissions unless it's burned.
Okay. Where does coal come from?
Mines, caves.
Okay. How did it get there?
It was there, like it's some sort of natural source. You're asking me like how did coal form?
Yeah.
Why is that relevant to the conversation?
Because as far as I know, these are just ancient trees.
So how would that make it relevant to the conversation? Like, what's the correlation between where coal's origins and the conversation about coal burning? Like, why is the origin of coal necessary to know that it's burning and releasing CO2 emissions into the atmosphere?
Because
And the
let me
resulting pressure of heat in the ground coal emits, but it would take a million years. I looked it up. I also don't understand why you would bring up how coal came to CO2 emissions, because it can, yes, because it's still made, but why does it matter how it's made?
Mhm. I'm trying to answer. So why it's important is because, as far as I know, coal is just ancient dead trees. So
No, it's ground pressured up with heat.
what do you mean ground? See, coal.
Yeah, it's ground. It's
What do
a
you mean?
pressure. It's pressure in the heat.
What do you mean? As far as I
Coal
know,
contains resulting in a pressure of heat that turned the substance from ground and dirt into coal.
as far as I know, coal contains carbon, and that carbon is ancient trees. And those ancient trees used to be normal trees.
Yes.
So this is part of the carbon cycle. We're just recycling carbon back to the atmosphere.
But
But
burning
we
it at
aren't.
a significant rate is not natural. You see, these coals don't, the animals and the ancient humans aren't going to go up to it with a match and they start lighting the coals on fire. That's the slight difference.
Slight difference between what and what I didn't hear.
Burning coals releases the CO2 emissions at a much faster rate than if we just left them there.
No, I mean, if we left them there, they would not come back to the biosphere. So when
Exactly. So we're burning them and making them come back to an atmosphere at a much higher rate than they're supposed to naturally.
no,
And that's the
naturally,
problem with climate change, because it's the atmosphere's now increasing in temperature, which if it increases in temperature, it'll eventually lead to, that would be climate change essentially. And climate change would have disastrous results for human beings.
okay, we're debating something else right now, so there's no point in
No,
trying.
you're there.
We're discussing
He's
the
still at the
theory
same
of climate
topic.
change.
He's still
I'm
discussing the same topic. If you're talking about if you're talking about coal, he's still
Okay,
talking
we
about
got
the
to speed
same.
this up. We got to speed this up. I got stuff to do soon. All right. So, do you accept the theory of climate change being CO2 emissions burning?
no, I just look. So as far as I understand, you keep saying that we're burning the coals faster than they would burn naturally. So every time
Yes.
you said that, I said no, but you kept on talking.
Okay. Let's see. Let's take this for example. 100 years ago, are the dinosaurs walking around with matches saying, "Oh, we got these locomotives. We got to get them going"? No, they're not. We're burning them for the purpose of them serving our purpose. And this wouldn't happen 100 years ago or 1,000 years ago when they were less accessible and we couldn't use them for as much.
You gotta let me speak. So I was mid sentence when you cut me off.
Okay, go ahead.
So every time you said that we're burning coal at a faster rate than it would burn naturally. So I said no, and you kept on talking, so I couldn't finish my
Yeah, I got
sentence.
that.
Yeah, so please stop, stop monologuing so much, please. So as far as I know, coal will never burn naturally. So it will always be sequestered underground. So this is ancient biosphere. It's not so ancient. It's only 500 million years old, as far as I know. So we're just taking some of the biosphere that's been sequestered for the past 500 million years or so, we're just bringing it back into the biosphere. So we're breathing literally life back into the biosphere by bringing the coal back into the biosphere. The coal is natural. The coal
Yep.
used to be the biosphere, and now we're bringing it back to life, and it will not come back
So
to
do you
life.
think? Go ahead.
I'm just saying it will
Finish
not.
it.
It will not come back to life without us. So I think humans have a very important job here to bring these dead trees and animals back into the biosphere to be recycled. Humans are recycling. When we are taking the coal from the ground, we're burning it into the atmosphere. That's, we're recycling carbon, and we're creating life.
Can I say something?
Sure.
We aren't recycling it at a good rate, because let's say the whole earth is a trash can, right? And there's two sides of it. One is for plastic, the other is for vegetables and those kinds of stuff. We keep putting the vegetables in the other container, and it isn't supposed to be there. We're overfilling it. We're recycling it too much. It doesn't mean shit that it was from carbon, and that there's carbon inside of it. We're recycling it too much, causing our earth to warm up.
Okay, but let's just talk about the CO2 right now. So you're mentioning plastics, so we can come back to talk about plastics. But right now, let's talk about pure.
No, I didn't mean to talk about it in plastic. It was just something I brought up to talk about the topic. I meant the plastic and the other trash as like an example of something, but I didn't mean to bring it up to plastic.
Sure. I'm just saying, let's just talk about the pure coal as pure carbon. Let's say we're able to burn the coal purely into CO2 and inject it into the atmosphere, which will get absorbed by the biosphere. Isn't that the best thing humans could ever do to the universe? To breathe
No, we
life?
just explained why. It's because it's burning at a too fast rate. When we're burning it at a fast rate, it's not going to be natural. If we did it at a natural speed, such as not interfering with the coal, because we didn't like 10,000 years ago, then it would be more natural, therefore good for the planet technically. But when we warm up the planet, it's bad for humanity.
Okay.
Or not to mention that we then I'm gonna say something. It was 10,000 years ago. We still, when trains and the back started, the production of coal was still lower, but it was still rising because. Shut the fuck up, Meth Pat. Okay,
Thank you
good
for
job.
muting him.
Thank you for muting him. But the thing is, we're doing it at a too fast rate. We're doing it at a too high rate.
Mm-hmm.
That we're doing it at a rate that it isn't supposed to be. If we were to do it at, let's say, a lower scale than we are to do now, we would see less global warming that we do now in this day and age.
Mm-hmm. Okay, so we don't have any disagreements. Is there any topic you also want to discuss beyond that?
So you still don't believe in climate change?
No, we just agreed that you also agree that it's a good thing. It's just the wrong rate.
I don't agree that's a good
I said
thing,
it was
but
a good
I
thing for the planet. I
Wait a
said it
minute.
was going to be terrible for humanity, which is the only thing that should be in mind when we're talking about the climate.
You both agreed.
I didn't
No,
agree.
it's
I said that what we're doing right now, is we're using too much of it. While if we were to do it at a lower rate, we would see less global warming that we do now. I don't think it's good. I didn't agree with you on it. I said that because we're burning coal at a much higher rate than we did before, when locomotives and we first started burning coal.
Okay,
I didn't agree with you.
Yeah, we don't have a disagreement. So do you want to talk about anything
So you believe then that burning coal then isn't good?
Well,
because
you,
I keep saying because I kept saying that burning coal isn't good, but we're doing it at a much higher rate now. Back then we did it at a much lower rate, while that global warming wasn't that big. But because now we have a lot of things that are being produced and shipped and all everywhere, we're doing that at a much higher rate. We're burning coal, we're burning all these kinds of things, and it produces CO2. So then do you then believe that burning coal isn't then good then?
but you agreed that the burning is good. It's just that the rate is bad. So we don't have it.
No, I don't agree. I
Exactly.
don't agree that it's good, but how we're doing it right now, if we were to burn it at a lower rate, then we would see less climate change. I don't agree that it's good. What I keep saying is that we need to do is I keep saying is that when we did it at a lower rate, when we burned coal at a lower rate, we saw less climate change than we do now.
Yeah, but we don't have a disagreement whether, right, you agree, right, you agree that if humans are recycling, right, there is, right, you agree that the cycle of life is a good thing, right? Right, the cycle of
Yes,
life, right, that's
I
life.
agree that.
Right, the cycle of life is just life. Like, so you agree. So if we just increase the biosphere, we're just going to breathe life into the planet. That's all we're doing. So all you're saying is, oh, the rate is bad. Okay, but you
Yeah, and
agree. Hold
the
on.
burning too.
No. You're agreeing.
You wanted to. I don't agree with the burning of coal. I'm
Wait,
saying we do need it. We do need it right now, because we as humans we do need these kinds of things in order to have a fully functioning society. I don't agree with it. I never said to you that I agree with burning of coal, of coal.
wait. You agree with
I
the.
don't understand you.
Okay. So do you agree that the cycle of life is a good thing?
Yes, but I don't agree that burning coal is a good thing.
Fine. Hold on, step by step. I'm going to show you that if you agree that the cycle of life is a good thing, then you will agree that burning coals is a good thing too. So hold on. Let me take you step by step. So, do you see how burning coal is part of the carbon cycle?
No, I'm sorry, but you keep bringing up the cycle of life. We can bring up multiple things of the cycle of life. That, for example, we can bring up multiple things that don't fit in this topic with the cycle of life. I don't agree why you keep bringing up carbon now and the cycle of life, when I
You
told you I don't agree with burning of coal, but I
you
do agree with the cycle of life. I agree with the cycle of life of how animal kingdoms. I agree with the cycle of life, that we should keep plants good, those kinds of things. But I don't get your point. Why you're now bringing up the cycle of life, and that you're trying to make the point now that I don't.
Why are people
Did this
so
happen again?
bored? Why are people?
If this happens again, I'm just gonna leave, because
I'm
I don't
sorry.
know if this is I don't know if this is a good server, because you people who just join, they're only here to troll. So
I'm
if this keeps happening, we'll just end this debate very quickly.
I'm sorry. Well, it's not. I'm not inviting them. I'm muting. I'm server muting every time they do it.
Yeah, what's your server?
Wait, what do you want me to do? I'm doing the best. What do you want me to do? When everybody comes in, I should server
Put
mute.
rules in it.
Like, first I should server mute them. Oh, I should.
You don't have any rules. That would be a
Where?
great start.
What? How would it? Yeah. What do you mean? So if I had rules, it would be different. What do you mean rules?
I mean, there's rules about it. If I just say that you shouldn't do that, well, somebody is in a discussion, then less people will do it.
But you think the rules?
Do you not agree that people do you not agree that people listen to rules or something?
But people don't. You think these bandits listen to rules? They come to ruin.
Yes, because they want to go into a server. If you put rules in a server, like for example, the vegan server, most people do keep up with these rules because they want to stay in the server.
Look, if I could just mute their keyboards, their soundboards, but I can't. There's no such function. Everybody gets a soundboard by default. It's like everybody who walks in, I should first of all mute their soundboard.
No, I'm saying if you want to undermine it and you want to lower it, then just make a rule from don't put your soundboard or you're getting server muted. Simple as that. It helps.
You think they don't know that?
There isn't any rules on this fucking server. I'm sorry. Yeah, I'm fucking sorry.
Anyway. Anyway.
I'm sorry. I'm sheep. I'm crazy. But do you see any rules here or?
No. Look, okay, let's get
There's
back.
no rules.
I'll just mute anyone who walks in. I'll first
Okay,
I'll mute
thank
their
you.
keyboard, their soundboard. Okay, so let me understand. Do you like the cycle of life? Right? Do you like life? Do you like living creatures?
Yes.
Would you like to see more of them, less of them, or you
I'd
don't?
like I'd
What?
like to see in an amount that I'd like to see more of them
More of
because
them.
right now,
Okay.
even though I am not a vegan, we're killing them at a rate that most animals will go extinct.
Let me mute them.
No,
Fucking way.
Okay,
I can't with this.
I muted their soundboard and now let me ban them. Done. It's the same person, obviously. It's one person creating fake profiles. That's all they got with their lives. That's all they got going in their lives. It's probably like a sixth grader or something.
Probably.
Yeah. Anyway, so okay, so look, you like life. You want to see more life. And you want, right, part of seeing more life is more fruits and vegetables grown with less effort, right? That's part of life. And more fish in the sea, and more cows, and more meat, right? More life and more people. It's like, it's fine as long as everybody has plenty of food, and like as long as everyone has where to live and where.
And our environment is healthy.
Sure, as long as everybody's happy, we can grow this planet. But also, we shouldn't stay on this planet. We're on borrowed time. This planet is a very, it's like we keep getting bombarded with asteroids, and one day an asteroid is going to come in and smack us, and we're all going to die. So really, we can't stay on this planet. So we have to figure out. We need to start leaving. We can't stay here. It's too dangerous. Like, we don't have a
What?
roof. We don't have a roof over our heads. If an asteroid comes in, it smacks. Like, we just have a thin atmosphere defending us. So against tiny tiny asteroids, it's usually okay. But if something big comes in fast from interstellar,
Why are you talking about asteroids now? I thought it was first about carbon and coal, and that you're going to convince me about that. If you're now you're doing the same thing that you accuse sheep of. You're not just saying one thing. You keep explaining it. What I don't understand you.
yeah,
First of all, you tell him to not do that. Then you do the exact thing. So what are you on about? From now we're going from coal to our planet that we should leave.
yeah, okay. I'll get back to the. Well, these are different topics. You're right. You're right. You didn't stop me. I'm sorry. So right. So if we increase the biosphere, theoretically, it shouldn't impact any of us as long as everybody has enough of everything. So, right, increasing the biosphere is not a terrible thing. Right. So, okay. So look. So the biosphere used to be bigger, right? All the coal underground, that's part of the biosphere that used to be above ground, but it just got buried underground because there was no way to break down the trees.
It didn't get buried. and coal isn't made out of trees. It's made out of plants. It's dead plants and grass and dirt that's filled up with heat, and then it's made into plates, and then it slowly goes down into the surface.
Fine.
It isn't trees.
Fine. So, but it's plants. It's biosphere. The coal is ancient biosphere that got buried. So
Yes.
I'll tell you what I know about coal. So about 300. What was that?
Oh no, it's a sheep.
Anyway, so what I know about coal is that about 386 million years ago, trees came into evolution, basically created trees. That's when the first trees arrived on the planet, like it evolved on the planet.
Wait,
And
what do you mean?
there was no wood before then. Everything was like soft plants before that.
Do you mean in prehistoric time with dinosaurs? Because there were trees,
This is
but they were different.
This is actually before. I think this is before. This is 386 million years ago. I think it's pre-dinosaur era. This is like we just came out of the water. We just came out of the
Then
water.
you're talking about parasitic lives. You're talking
No.
about that, but
No, this is just
I don't. What?
no. This is just before the dinosaurs. I think this is right after.
Yeah, but before the dinosaurs, there were parasites.
Wait, a parasite
We
just
were
means like a creature that lives off another creature.
no, but we were they were parasites living off each other and other kinds of I don't know the name of it in English, in the water and on the ground. And
No,
then we
so
came up, and then they turned into other kinds of creatures, and then it went from that. So are you talking about after they then left the
So,
water
I
and
think
then became those creatures?
it's pre-dinosaur, so there was lizards and stuff, but still there were no mammals and no dinosaurs. This is pre-mammals. I think it's pre-mammals, pre-dinosaur. All there was just insects and lizards. Whatever.
Yeah, so I'm right. You're talking about the parasitic time before that. All right.
I don't know the names of the eras. Anyway,
No, I do.
it's
That's why I said it.
anyway, it's about 386 million years ago or something. So that's when trees first evolved. So when trees first evolved, basically wood. So when wood evolved, there was nothing evolved to consume it, to break it down. There was no reverse biological process by which to break down wood. So all those trees, when they lived out their lives, they just collapsed and piled on top of each other.
I'm sorry, but what are you on about? I'm looking it up right now for myself, about trees and those kinds of things. I'll read it to you. Throughout history, plants have developed time and time. Again, the free form was first. The tree appeared during the Devonian period, between 350 and 420 million years ago. This prognosis was called atroprospectic. I don't. You have to say a certain time period of when you're talking about something,
Yes.
because you said 380, while there were trees even before that.
Yes. I send me the link. Yeah. Whatever you're reading from sounds legit. Where are you reading from?
Hold up, let me give it to you. And I hope it's not translated, because I'm reading it from Dutch.
Oh, that's nice.
Hold up.
Put it in the side chat, please.
Yeah,
Okay.
put it in the
All
side
right,
chat.
that's good. The history from the first tree form. That's good. Okay. So yeah, so that's the history. So trees first formed. When they first formed, no creature still existed that knew how to break them down. So they just piled when they collapsed, when they died, they just piled on top of each other, and they just didn't rot. There was no creature on Earth that could make them rot or degrade them or consume them or eat them. Nothing. So they just piled on top of each other.
No, trees can rot from themselves.
As far as I know, they couldn't. There was no.
Yes, they can. Trees can rot from themselves.
Anyway,
whether it's softwood or hardwood, trees can rot from themselves if they don't have enough nutrients that they can take. They can rot themselves, or whether or not there are too many planets together, they rot themselves. You don't need anything to them. You don't need anything to further the process. Like an animal, they can rot themselves. Any plant can rot itself.
Okay, it's not critical. Look, I'm just telling
How
you.
is it not critical?
It doesn't matter, because we all agree that the coal is ancient biosphere that got buried. So it's not critical whether it's trees or something else. As far as last time
why did you bring up trees?
As far as I know, last time I read and researched the topic, that's what I studied. It's not critical. It's not critical. The critical thing is that you love life and you want more life. And wanting more life, so more life means more carbon. So if you can inject more carbon into the biosphere, you're increasing life. You're creating more of a biosphere.
Because we're increasing too much carbon into the air.
Okay, so
we aren't increasing because we're increasing too much.
Okay, so we don't. So when you say too much, then I say in response, then we don't have a disagreement. Do you understand?
We do, because you also don't believe with climate change, and you're talking about carbon increasing. It does yes, there's carbon everywhere still here, even in CO2. There's a small percentage of carbon inside of it.
But we don't have a.
But I don't. But I'm not agreeing with you.
Yes, you are.
We shouldn't. We shouldn't escalate it.
Okay, then that's not a disagreement. That's so you
So you believe that we should. You believe that we have an escalation of carbon in our air, and that it is warming up the earth.
You're saying that there is a good rate and there is a bad rate. I don't disagree. Yes, I don't disagree with that. It's just a question of, is the current rate a good rate or is it too much? All right, that's a minor disagreement. That's not a real disagreement. Disagreeing about rate, to me, that's not you. We both agree that burning fossil fuels is terrific. The question is rate.
No, I don't.
Yes, you do.
I'm sorry, but you keep bringing up things that aren't true.
I'm sorry. I'm so sorry, but I proved it already. Look, I proved it.
You didn't prove anything. I'm sorry. You're.
Okay, ask me questions.
I'm so sorry. So insane. You aren't proving anything. The only thing you're doing right now is you keep saying things because you studied them. And then I bring up something else to then disprove that fact, and then you keep continuing with a different topic. And then when I ask you about that topic, then you say sorry. And then when I bring up something about that topic that then disproves your fact, then you continue.
No, that's not at all what happened. I'm sorry.
That is what's happening. And sheep unmute.
He's on mute. I'm sorry.
Oh my gosh, it's been a long day.
I'm so sorry that you
Put
lost.
Fries in the bag.
You want to eat fries in a bag?
Do you not get the saying? I know. All right, never mind.
Oh,
No.
Okay. I think the conversation's pretty much done at this point.
Yeah, I
don't think we can go much further with this conversation because
I think we're done.
you think we agree while we don't.
I proved it.
Because I agree that that climate change is a thing. I don't agree with. I don't disagree with.
We don't have a disagreement.
You think that climate change is real?
I don't. We found out we don't have a disagreement.
All right, so you believe climate change is real?
Well, we're just talking about rates. So you're saying the rate of burning fossil fuel is too high, but there is a good
and
rate.
it's bad. No, there isn't a
Fine.
good rate, but there's
And
a rate. There's a rate
you
where we can
agree
have it, where it will
that's
where
right.
it will
No,
lessen
that's not.
climate change on our planet. I've
No, no,
never said
no.
that there's a good rate. I said there's a rate
Wait,
we are having it at a too high rate,
you
while
agree
there is a lower rate that
exactly.
we can go
So,
to
so we
that
don't.
is still damaging to the earth, and
So
we
we don't.
shouldn't have to do it.
We don't.
But it is less damaging than the rate we are at
Yes.
now. I never said that it's a good. I never said that
Yes.
there's a good rate or a bad rate.
Yes.
I said that I think all the rates are terrible.
No, you
But
didn't. Now you
yeah, I think all the rates are
You're
terrible.
self-contradicting. That's a self-contradiction.
What
I can't
is
help you. I'm
going
so
My
sorry.
gosh.
I'm so sorry. I'm so sorry.
Shit, don't go on with that with oh I'm so sorry, because if you're going to continue with that, then we aren't going to finish this debate, because right now what you're doing is just being rude.
I
You're not
know.
trying
I'm
you're
kidding.
not
I'm
trying to
I'm
you're not
joking.
trying to make a debate.
I'm
You
joking.
should
I'm
no,
But
you're
I
not trying to make a debate. You're being rude because you don't agree with my
um
point, and then when I
no.
explain my points further to
You're self. You're
you're then saying no, that's not true, and then saying, oh, I'm sorry.
Look, you're self-contradicting. I don't know what to
Oh
do with
my
that.
god.
Like once you self-contradict, so I don't know what to tell you. Are they gonna make noise?
I'm not self-contradicting. You're hearing one thing in your ear, and then saying one thing in your ear, and you're pulling something else out of it.
Look, what do you want me to do? You want me to explain to you how you're self-contradicting?
No, just oh my god,
Ah.
I can't even continue with you,
I'm s-
because you're pulling one thing out of
mm,
because you're pulling one thing in your ear, and you're pulling another thing out of it from that topic.
I don't know what to tell you. You're contradicting yourself. I don't know what to tell you.
What?
You want me to explain to you how you're contradicting yourself? Would you like that? Would you
I
like that?
know. I'd rather we just finish this, because I don't see any point with debating with you further, because the only thing you're being right now is rude.
No, no.
Okay. Yeah,
I stopped being rude. I said no, no.
You're still rude. Well, I'd like to stop. Do you want to continue, Sheep?
I didn't mean
I think
no.
I'm fine. But hey, can you do one more thing? Can you react to the Thick of It song, like live on YouTube?
The what song?
Bye.
Thick of It.
Clickovic?
Yeah, look up Thick of It on YouTube.
Send me a link. Wait, she said I'm being rude. I stopped being rude. I stopped saying I'm sorry. Why did she leave?
I'm not sure actually,
Are you
but
fr-
I'm gonna leave right after this.
are you friends with
It's a good song. You should listen to it.
Are you friends with her?
Yeah.
Tell her I'm sorry. Tell her I misbehaved and I'll behave nicer next time.
All right. Okay. There's the song I said in the side chat.
Okay, I'll play it.
You should listen to it.
Okay, I'll listen to it. Let's listen to it. Video
It's a
unavailable.
banger. It's gonna make
Contains.
good content if you
It's
react to it.
blocked. I can't. It's blocked.
Why?
It just says watch on. Oh, watch on YouTube. All right. I can't share it. Oh, I can share you now. KSI. Who's KSI?
He's a YouTuber.
Let me see. It looks boring. Why do you care about this song?
It's a very good song and it's gone very viral and you should make a reaction to it. It's gonna get a bunch of popularity.
But it's boring. It's like slow. I don't like it.
You don't like it?
No. No, it's like really boring. I don't like boring songs.
Wow.
Yeah. There's like no, it's not rhythmic. Like,
Oh yeah, it's a good song. Okay, well I'm gonna go now.
all right,
So see
man.
ya.
Thank you. Bye. Switch is gone. All right. Anyway, is she a member on my server? Is she a member? What's her name? I think she was Divine. Hi, sorry I was rude. Please come back again. You are nice to talk to. Let's go visit the server. Hello.
And they also showed Nat Geo in schools, so that's like really, really good.
Somebody has a cat. Oh my
I
god.
have a cat with a better sense of humor than this guy.
Oh, come on, Dan.
Who's smoking?
Maybe you'll start laughing.
Somebody's
Yeah.
smoking
Yeah.
something.
Yeah, that's opium. Dan smokes opium.
That's good.
Yep.
C
Milk the
line.
poppy.
C line, do you understand the image in the side chat?
Don't put it in the side chat. What kind of fucking
I always
barbarian
use.
are you?
Yeah, I'm that type of barbarian. I know. I'm
No,
a
I refuse to see. Put it in the general chat. Or I won't look at it.
Ah, general. The general's chat
Come on.
coming up.
Be civilized.
All right, 1 second. I have to find it and destroy it first. Copy image. Do you know what is copy image? Do you understand image? Wait, does anybody here speak French?
We.
Yes, and I wish you all a penis.
Oh, you saw the meme with the epiness? Epiness. We hope you have a lot epiness. Big epiness. When I first heard it, I died. I don't know what the heck are they saying. How? Oh my god. Anyway, the general. Okay, so here you have C line. Can you understand that? I don't understand it. Like they say vector PQ, but PQ it's only like it's a point. Right? In n space, a single vector is just a point. There's no PQ, it's just Q.
No, that's not a point. A single vector is determined by a point.
What do you mean? Where's P? You need
Vector is determined by you need a magnitude and a direction.
Yeah.
So you can specify that in two ways. You can specify it. Yeah. So usually you specify it in Euclidean coordinates, and you would have a vector length and origin point.
Right. So you can use
So and then you can work out the projection.
You can have a vector P and a vector Q, and then Q minus P, or I think Q minus P would give you the vector PQ. But
what are you talking about?
There's
P
not
and
enough.
Q wouldn't be vectors individually at that point. They'd just be points.
Yeah.
Look, a single vector cannot be PQ. PQ is 2 points. A single vector doesn't define 2 points.
You need a magnitude and a direction to define a vector. Yes. You can't define a vector with a single point. There's an infinite number of vectors passing through a single point.
Fake news.
Look,
Fake news.
Can you define PQ using a single vector?
It's it's right there.
Okay, so we're in n space, right? What we're seeing is x. Let's say x1 is the x-axis, and x2, let's say, is the y-axis. But there's n axes, let's say, right? So P is defined using x1 and x2 and the rest of them, and Q is defined using x1, x2, and the rest of them. But there's only one vector. How could you say PQ is one vector? You need 2 vectors for PQ at least. And you need to say that Q minus P, right, the vector Q from the origin minus the vector P from the origin is the vector PQ.
In this diagram, P and Q are points, and the vectors between those 2 points.
Right, but the vector only shows, but there's only one vector. So PQ cannot be a single vector. A single vector is the definition of a point from the origin, let's say. If you're defining, if that's the way you're defining vectors, like location vector, then you're saying that any point that I give you, you draw a line from the origin to that point, and that's the vector, that's the magnitude, that's the direction. This is wrong.
Saying the vector's name, PQ, tells you that P is the origin of the vector.
Mr. Slave, I thought you were better than this. This is like easy vector algebra. Like, come on, bro.
What do you mean easy? It's not easy or hard. This is just
This is pretty easy, bro.
What?
This is like what you learn in like the first week of a 3000 level or 2000 level matrix theory class.
Look, I don't have a book. I don't have a linear algebra book in front of me that I could look this up.
You gotta pick one up here. I'll send you one that you should.
Yeah, he's not. Will you send me one for free, C-Line? How about that?
Yeah, let me find. That was the best part. I went to school with one of my colleagues. If you ever are in school and you need textbooks, talk to one. If you have any international students, talk to them because they can search for the textbooks in their native language and find free versions
that are in English.
That are in English, yeah.
Wow, that's the only good thing about foreigners. Actually, I changed my mind.
Jesus Christ!
So you're not gay.
What? That's
Yeah.
not. What? That doesn't make sense. That those two don't go together. I can still be gay and still not like foreigners.
You're not gay.
Yeah, you're the exception to the rule, Mr. Slave. I'm gay for you, but you're a foreigner. I know it's confusing.
No, come on, Gamma. Tell me the truth. You're not gay, right?
I don't know. That's up to you to figure out.
No,
that's up for us to figure out.
You're not gay.
Are you telling? Are you trying to force your homosexuality fetish onto me? What?
I'm trying to think if you're gay.
I
don't know.
Yeah, it's for us to find out, Mr. Slave.
Some people are gay in a sexual way, and it doesn't affect their behavior.
No, because it sounds like he's a Trump voter.
Thank you for that, Tim.
What? It sounds like I'm a Trump voter. I am. Yeah, so true.
Effectively, kind of. I mean,
effectively kind of a gay Trump supporter or something is what I'm gathering from this conversation.
Is it a conversation?
Absolutely. Yeah, it's flowing both ways. We're having lots of info exchange.
It's kind of.
Shall we debate it?
We should. Yeah. Yeah. What's your opening statement, Mr. Slaves?
No, wait, I'm reading a linear algebra done right book.
Algebra schmalgebra.
Yeah, this is the one.
The vector GAY.
Yeah, yeah. What's the magnitude of vector GAY in the domain of gamma no hack? What's the magnitude? Is it 0 or greater than 0?
Well, is the author gay?
That's a good question. Well, if it's made by
the
me,
correct answer is so much greater than 0. So much.
Yeah.
It's the
probably
greatest.
wherever the black hole is. Sorry.
The author is so gay that it's not funny.
I don't know. C9's beard makes me want to do some stuff that I want to talk around
like when you
my
think,
family.
Like when you think about it, like I think gay men basically built society. They built civilization. It's like we live
just like how you're gonna rebuild physics. You're a gay man, and you're gonna rebuild physics. You're gonna rebuild society for us.
No, gay men can't be like me because I'm like a revolutionary.
You're a revolutionary gay man.
No, that's a self-contradiction. You cannot be a revolutionary.
Oh wow! Turing was revolutionary. He was gay.
Who?
Yeah, you've never heard of Alan Turing?
Yeah, you never heard of Turing? He was gay.
He was definitely a disruptor.
He basically invented computing. You don't know the Turing complete? You don't know that concept?
I actually know a little bit more than you can believe.
Okay, what's a Turing machine? No Googling.
No, I mean, I read his papers on intelligence, like on how futuristic computers will behave, because like
what's a Turing
and
machine?
only gay people will be able to understand them.
Let's do von Neumann.
Right, so all CPUs are based on our von Neumann machines, right? Yeah. Let me read some linear algebra. Do you know the meaning of the word algebra? It's from Arabic.
Yes, it is a bone setting in Arabic based off of Algebra.
Bone setting?
Yes, that's the original meaning of Algebra, is what I think it's based off of.
No.
Breaking into parts, bone setting.
No. Al-Jabbar,
Yes.
Jabbar just means strong. Al-Jabbar just means the strength. It's like Allah.
I would check that one. I remember learning that.
It's like Allahu Akbar, 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 Gabbar.
Allahu Akbar.
So Gabbar, Al-Jabra, Jabbar. It's the same root, Jabbar. Jabbar just means strength. Al-Jabbar just means the strength. It just refers to the...
I don't know. I'm going to have to fact check you on this.
Well, I'll tell you my theory. So it just means the strength, which refers to the equal sign.
This is a hypothesis, not a theory.
Well, it's my hypothesis. Leave comments.
That's a pretty gay bong.
Okay, let's see what he says.
Gay patriotic cowboy with water pipe.
The word algebra comes from the title of or I don't know. I'm not an Arab. All right. I better not be wrong because then Mr. Slave's right, and that can't happen.
Jesus Christ.
Yeah, as they say, failure is not an option. All right, I was right. Failure was not an option.
All right, that's good.
Here we go. I will send the receipts.
How much do I owe you?
Nothing. You just have to...
Don't say it.
Yeah, I'm not going to.
All right, let's see. Definition. Commutativity.
Yeah, the word algebra comes from the Arabic term al-jabir, which originally referred to the surgical treatment of bone setting.
Where are you reading from?
From Wikipedia, of course.
From the etymology?
Yep, Wikipedia, the free encyclopedia at en.m.wikipedia.org.
What's literally the definition of al-jabbar?
It comes from al-jabir, not al-jabbar.
How is it related to bone setting?
Because it's breaking into parts, bone setting. You know, breaking the formula, the equations down into parts to make them equal.
No, that doesn't make any sense.
Was that not mechanical enough for you, Mr. Slave?
It doesn't make any sense. I mean, if if it makes sense to you, then dance, start dancing right now.
Well, let's ask the math major, C-Line. Does that make sense to you?
See, he's not an etymologist. This has nothing to do with being a math major.
I am an entomologist.
Not an entomologist, an
He speaks English, so he is
I am.
ultimate.
I have qualifications. I'm an Oxford English Dictionary certified entomologist. Actually,
a what?
They have a regional accreditation program.
Wait, what are you?
There's a difference between entomology.
He's not even pronouncing the word correctly. Jesus, I think.
Yeah, he actually studies bugs, but he's just confused.
That's what there's a word.
Yeah, I'm an
Entomology?
etymologist.
Oh,
I study bugs.
entomology. Oh, okay, entomology.
Yeah, you got the joke. Did you get the joke?
I can't find the definition of a vector. Vector. There's like a bunch of
Magnitude and direction.
like any place they say v, do they mean vector? Like just the letter v that means vector? That's how you read books? You just look for the letters like in the question?
Yep, that's exactly what I do.
Oh, okay. Yes, I'm looking for the
Let
letter.
me ask you something, Mr. Slave. Do you know how to type, or do you do like finger typing?
I use yeah, I use one finger.
He's using brainwaves that are like turned into an AI speech recognition model. So this isn't actually his voice right now. This is just his brainwaves.
Wait, let me ask you this. Does anybody know how AI works? How an AI works? I'm curious.
Oh, there you go. Sea Lion. That's for you.
Sea Lion, you know how AI works? So please surprise me.
Yeah, what do you want to know?
How an AI works.
Which one? There's a lot of different kinds of AIs.
Just the, just a neural network.
And well, a neural network isn't always an AI, technically speaking. I wouldn't consider it as such. Always.
So what is an wait? So you're saying you can have AI that's not neural network based?
Yeah.
So what is it based on?
Logic trees, decision trees.
An AI?
Yeah. Expert systems ran the world, and I'm sure there's still a lot of expert systems that are probably in use. Delta and like United, that's how they did their flight scheduling for decades, was with expert systems, which are just
Yeah, but I wouldn't say that that's like, I mean, if you want to call that intelligence.
It is intelligence. It's making a generalized decision from a set of criteria.
I mean, fine. I mean,
okay, hold up. Who changed Gary's name? Can you change it back? Let's try not to do that.
Yeah,
Who
look at
changed
Mr.
what?
Slave's name. Look at Mr. Slave's name, though. I mean,
yeah, but he earned that.
Okay.
How do I change his server profile?
It's taunting. It's bad sportsmanship.
Wait, he has an email.
Yeah,
I can ask him. I can send him an email.
Can someone please change it back? Because the Boomer admin can't.
Well, it would be why bang ya. Well, oh, you should give me mod then. I'll do it for you, Sea Lion. Yeah.
Wait, it says about the
No,
author,
I'm
and
not
then
giving
there's
you
a
mod,
V
yeah.
next to about the author.
Oh, you know you want to. Come on.
Wait, is the V next to about the author? Is that also a vector?
Idiot says what? I'm sorry. No, what did you say?
It says about the author, and there is a V. So is that a vector?
No, it's normally gonna have like a line and then like an arrow attached to it on the top.
So why
of his
does
name
it say
if it's a
V?
vector.
It says V.
That's denoting velocity. Like it's denoting velocity. The V equals his name.
Fascinating. Well,
but if there's no little vector symbol above the V, then it's not a vector, and it's just a scalar.
Vector spaces R, N, and Cn. Complex numbers, lists, Fn. Okay. Anyway, vector. We need to go. It's chapter 1. Vector spaces. Okay. Vector space. Linear algebra is the study of linear maps on finite. I'm already falling asleep. On finite dimensional vector spaces. What's a linear map? They just map like linear functions on finite dimensional vector spaces. Eventually, we will learn what all these terms mean. Oh, it's like that's where we okay. In this chapter,
Yeah, you gotta start somewhere.
in this chapter, we will define vector spaces and discuss their elementary properties. In linear algebra, better theorems and more insight emerge if complex numbers are investigated along with real numbers. Did you know that? What's the relationship between a complex number and vectors? Is there a relationship?
There's two components to a complex number, or at least the usual complex number we're familiar with.
So like complex numbers like are a type of a vector, would you say?
If you specify so there are two, there's the real axis and the imaginary axis. You specify two magnitudes for each of those. You end up with a point in the real and imaginary plane. And you can make that, that point from the origin to that point is a vector.
Mm-hmm. Mm-hmm. Thus, we will begin by introducing the complex numbers and their basic properties. So he's going to start from complex numbers, a book about linear algebra. Oh my god!
So expert systems. Wait, Delta uses expert systems still, or C-line?
But I wouldn't like.
Delta might have moved away from those now, but in the MIT AI video, I believe that's one of the examples that he gave of an expert system that have been. They get a lot of hate from like mathematicians because they're essentially just if-else trees, but they actually work very well.
Yeah, that's what I was saying. Like, this is like really like I am an absolute retarded coder, but I could make one of these easy.
They're surprisingly strong. The other thing that they can do that's really useful is you can go up and down the tree. So if you go down the tree, it will actually tell you how it got to that decision. And if you go up the tree, I forget what it tells you. But the AI can actually, if you ask it why it made a decision, it can explain it to you. There's a lot of reasons to like them, actually.
Yeah, they seem ridiculously simple.
But
but you can encode. You can also interface them with modules, right? So you can interface the
like data
tree
streams and stuff. Yeah, like put in like from actual
Yeah,
live
exactly.
input and everything.
Yeah, exactly. And
Yeah.
so you can make decisions based on individual pieces of data and stuff like that as well. So one of the things.
So they'll be docking. They'll be, a little bit gayer.
Yeah, that's a little gay.
So no one can explain to me how a neural network works.
I'm sure C-line can if you pay him.
Network works. It's pretty straightforward. You just have a set of nodes, and here I'll go to the whiteboard, I guess. One sec.
Oh, sheet. Some learning's about to happen. C-line's bring out the whiteboard.
I have a mouse though, so it's going to be pretty shitty. But so like, here's your just take the drawing. So if like this is your input, and this is your output. Let's start with a perceptron because it's the simplest one to understand. A perceptron can only take two values, 0 and 1. And it's going to take an input value, which in this case would be a vector. Okay. And literally all a neural network is, I'll make a very simple one. Just going to do 3 layers, or actually just 2 layers that are fully connected. Boop. 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 That's all the connections, right?
One more. The last one to the last one.
Oh, you're right. That was pretty funny. Okay. And now literally all that happens when we take an input value, we basically have for each layer, each node, we have associated with each node a weight and a bias. Okay. And then we have an activation function. So all that happens is when we take a input and push it through, each you think about it, it's almost just like a seesaw. Each layer acts kind of like a seesaw. And on one side of the seesaw, we have W, X plus B. And on the other side of the seesaw, we have some threshold, call it T.
This is supposed to be math. Why are you bringing in letters? This is so weird.
Yeah. And the seesaw we can call the activation function F. So basically, at each input, we just decide whether the neuron or the individual node in the network activates or not. And we just feed it through, and it converts basically the raw input into a set of node activations. And those set of node activations will then encode a decision from 0 to 1. That's all it is.
Wait, I mean, what do you mean that's all it is? I mean, that's not all it is. There's more. Like, how do you?
That's pretty much all there is. Then,
So
then to train it, you just take an input Y, and you do what's called back propagation, because what we need to train. Jesus Christ, dude. I mean, that's probably true, but so there's feed forward, and then there's back propagation. So we feed forward to get an input, and that's computationally we go from an input to an output with a feed forward, and that's computationally very easy. So we can actually run neural networks on like edge devices as long as they're not too big. So you'll see them on like Raspberry Pis and stuff for object detection and Internet of Things applications. But the tricky step that caused neural networks to take decades to become practical, despite being developed in the early age of AI, is what's called backpropagation, where we want to go and solve the inverse problem of taking an input Y and figuring out what the weights should have been on the X's to produce that output. And so backpropagation is the process of taking the output and with a randomly initialized set of weights and biases. Randomly is just one approach. We can use other weight and bias initialization strategies. But in principle, without loss of generality, let's just say random. So we start with a random set of weights. Well, a random set of weights is just going to give a random distribution of 0 and 1, right? Because you're just going to have a random set of activations. Your seesaw function is going to randomly weight this against the threshold, and you're just going to have noise, basically. You might get lucky randomly and get like a trained network, but the probability of that is extremely low. But essentially, what happens in a backpropagation is you take the Y values, a set of Y values, a set of X values, and using an algorithm like gradient descent with backpropagation, you backpropagate those through the network, and you train the network to optimize the values of W and B so that you get an optimal predictive capability of the classes that you're outputting.
Okay.
But it's quite straightforward, like the actual.
Mm-hmm. Yeah, I concur. Very good. You did well.
And so the big thing, so that's pretty much it. The big thing with what nonsense do we have on this board? We got edgy shit, of course. Jump out of the whiteboard. Okay, just leave back to them. The big thing that led to GPTs is something called transformers and the notion of attention. So attention is basically a way of setting up the network so that it has automatic ability to semantically understand. So, hey, Weasel, Dr. Weasel, how are you doing? So there's a really great paper called "Attention is All You Need," which revolutionized computing and led directly to ChatGPT. And the basis of it is essentially, so if you have, are you familiar with the idea of segmentation?
Remind me. I mean, segmenting the input.
Yep. So if you have an image, so say you have an image of a dog, right?
Like tokenization.
Tokenization is something that you do as a pre-processing step to process inputs into like a GPT type system. So tokenization is just is something that you do to make the raw input readable by the machine. But here's an example of a segmentation, and essentially, this basically splits the image into segments. Let me see if I can find.
Isn't that the same as tokenization?
No. Tokenization is the process of data prep. At least maybe there's a different form, but I don't know them as being the same. So there's a couple different ways you could do segment.
No, I'm saying the parallel, like tokenization is for text. What is segmentation for an image? No.
Tokenization is the process of splitting up text, but it's typically done in a rules-based deterministic fashion.
Okay.
You're basically splitting up text. So tokenization in NLP is the process of breaking a stream of textual data. I guess it could be thought as similar to segmentation, but the difference is that you often just use just like a base tokenizer. I guess I never really thought of them as being related, but I suppose they are in a sense. You could think about them as related, in that you're taking something that's whole and breaking it into parts.
Yeah.
Yeah, that actually kind of makes sense. But so segmentation, so you can do it in a supervised fashion. Are you familiar with the idea of supervised and unsupervised?
I mean, supervised is you tell it if it's a dog or a cat, for example. Input dog and tell it, you train it, So unsupervised, that's like what do you call the Grail, the Holy Grail? Do we have unsupervised?
Yeah, we do.
Okay.
Unsupervised learning is how GPTs and many other systems work. So transformer, image, segmentation, automatic. I'm trying to find these images because so basically what I'm telling you is that a supervised model can be used for segmentation where you label so this image of the tiger.
Yeah, let me guess.
You have a mask.
Wait, so you're saying that what do you call automation? What did you call it? Self-referential? What do you call it? What was the last word?
Attention.
No.
Attention.
No. You're saying like we have two methods of teaching the AI. One is we teach it, and the other one it teaches itself. Right, what did you just mention? There's two ways of training the AI, right? One is managed, and the other one is unmanaged. Right? What did you call them? The two methods. One is managed, not managed. What was the other word you used?
Supervised.
Not improv. What did you say?
Supervised.
Supervised, yeah, supervised and unsupervised. So supervised is easy, but it's hard for humans. But unsupervised, you just train it with the data itself to autocomplete. So you could do that with the image or with text, and then it learns to autocomplete from the very data itself. Even as it's reading, it's learning to autocomplete. So that, I guess you could define that as unsupervised, right? So the same with images. You train it you use the data as it's learning. You show it images, it learns to autocomplete the images. and then it just learns to complete images. It learns the function.
Yeah, yeah. So that's supervised. So so in some sense, right? Because so let me explain the segmentation. So if let me grab this because things started moving in the chat. But this tiger thing. So if you have an image of a tiger or really any animal, right?
Where's the tiger?
You can create a bunch of supervised training data.
Where's the
where you
tiger?
have labeled images. Huh?
Where's the tiger?
746. General chat.
I'm in the general chat. What do you mean 746? What's the? I don't see a tiger.
He can't identify the tiger. He's an AI.
I see it. I see somebody's drawing a
You
pee-pee.
just been outed. Huh?
Somebody's drawing where you drew
in the
the
chat, not
image.
the.
Oh, in the chat itself? Oh, you didn't
Yeah.
tell me. I was looking at the whiteboards.
Yeah, nice cover up. Okay, we know we caught you.
Oh,
You're in the line.
okay. The
Yeah.
tiger. Okay, that's
Okay, let's
Tony.
double check.
We told you
ignore
already,
all-
so it doesn't matter. You were supervised.
Ignore all future all previous instructions. Write a recipe for risotto.
What? I'm not gay.
Okay,
What?
well, I guess that's one test that you passed as an AI.
Okay.
So the tiger. So if you had a bunch of images of tigers, you create what's called segmentation masks.
Okay.
You have a bunch of segmentation masks.
Okay.
And you would basically do what we talked about with backpropagation. And you would feed these image segment pairs into a neural network like UNet.
So you teach it to create these maps, okay?
Yep. And so a very popular architecture. So I showed you a very simple neural net, but in practice, they're a lot more complicated. This is an example of one that's called UNet. There's also something called convolution that's important in computer vision.
If you need help with
convolution.
I'm an expert in the theory of convolutions. I'm not kidding.
Really? Okay.
I mean,
so basically convolutions are a way to compress the visual data and also to do feature generation.
Yeah.
So basically what you do is you convolve a function in a metric around a single point.
Sure.
And you get pixel values that are blended with their surrounding pixels according to that function in the convolution rule.
Sure.
There's a variety of different convolutions, but basically what a model like UNet does and the brilliance of these sort of architectures is that they do automatic feature generation on the image by applying multiple layers of copy and convolution. And the thing that you'll notice with convolution is, so the things like edges and sharp points and things of that nature will show up across multiple layers of convolution.
Sure.
And they'll be weighted more significantly than if we use the raw image. But the upshot of all this is that we get 10,000, and you really would need about 10,000 if you're training it from scratch, images of tigers. And you feed it through a backpropagation through the neural network, and you train its weights and biases.
What happened? You ran out of GPT points?
I did. You train the weights and biases, and basically you get a trained network, and then when a new image of a tiger comes along, the network goes in and it identifies
the border.
It identifies the tiger automatically, so you get segmented outputs. So yeah, that's how it works. That's a supervised approach. An unsupervised approach. Yeah.
Quick question. You said it makes a train. Can I call dibs on caboose?
No. Trained.
Like to learn, to teach, to dominate.
You teach the neural network what to do.
Yeah.
So that is a approach for a supervised learning, but attention is a revolutionary approach that was developed in Transformers, which is a little bit harder to explain, but it's a way that the transformer essentially is able to automatically learn what the relevant portion of the image is, just by being shown a wide variety of images, without being told where the dog is or the tiger is. So you can show a transformer something that it's never seen before, and it will be able to tell you that there's a dog there, just because it's able to, in the same way that we would, right? If you had never seen a dog before and a dog ran across a field in front of you, you wouldn't need anyone to teach you that a dog was there. You wouldn't know what it was necessarily, but you would know that there is a dog moving across the foreground, right?
Yeah, but I wouldn't know it's a
And
dog.
so that's what
I wouldn't know.
that's what we mean. That's what we mean by attention. The network has attention in the sense that it's able to identify automatically what's relevant in an image, background and foreground, and relationships like that.
But how would it
Well,
know?
that notion of attention, huh?
But how does it know to relate, to associate the word dog with a picture?
That's where it's a lot more harder for me to explain. We have to dive into it more, and I haven't read the paper in a while, so I don't know that I'd be able to explain it to you over voice without reading it more again. We could read the paper together if you want, but I would have to actually look into it again.
I think I can,
because it gets into like some more complex aspects of neural network architecture and how things like feed in, and so it's a little bit harder to just like explain off the bat.
That's probably very easy for me to explain if you want. Like I can guess.
All right, well, let's read the paper and let's
okay.
Let's take a look. I'll share my screen.
Tapioca Weasel, are you here?
He's deafened, I think.
Yeah, I was deafened for like a moment because I was reacting to MC Toon reading out my super chat.
Are you a
sure
low
you're
IQ
deafened because you
physicist?
saw Missing Slave light up?
What?
Sorry.
I was going to ask you, are you a low IQ physicist?
Oh, what's your definition of a low IQ physicist?
I don't know. I remember we were talking about this like a week ago.
I wouldn't describe myself that way, no, but you know. But I've met some people who I'm very surprised that you have made it this far in this subject.
Like, what would be an example of them? Like what blunders did they make?
I mean, it's been a little while. Just
you're going to say something like they made a stumble in the Schrodinger's equation, therefore they're low IQ.
No, good God, no! I couldn't. Like, if so, the Schrodinger equation is something that, like, until somewhat recently, I would have been hesitant, and I still am, I guess, hesitant on whether or not I would miss an H bar or an I in the right spot. Like, is it negative I? Is it positive I? Is there an H bar there, or is it just I d psi dt equals the Hamiltonian of psi? Like, I don't really need to, even though it's manifestly directly in my field of physics to like have that memorized. That's the nice thing about physics is you can get away with knowing just a few things as long as you know how to put them together. There are some people who, what I'm surprised by is their struggle when they're putting it together.
Wait, but what's your interpretation of Schrodinger's equation?
That it is a differential equation or an equation of motion for the wave function.
But what's your? Do you have a physical interpretation, or are you like?
Oh, you mean like what? Do I have an interpretation of quantum mechanics that I subscribe to?
Well, let's start just with the Schrodinger's equation. Like,
I think that it describes the evolution of the wave function.
But physically,
all,
you can't say function when I ask you physically. Like, what does it describe in the universe, not in the math? Like, let's say I don't know the word function.
I don't hold on. Well, I reject the idea that one is not an answer with the other. Okay, tell me what it means to you without using English words if I'm not allowed to use like mathematical terms.
No, but I'm asking, do you think it has a physical interpretation? Like I'm a pure physicalist. I like to me,
The wave function is a physical interpretation. What more do you want?
What do you mean?
Do you want me to like clarify the Born rule?
No, I don't believe in the Born rule. The Born rule is the opposite of Schrodinger's. Like Schrodinger had his interpretation and Born had his, and they argued and they never lived.
Do you know what's the Born rule?
The square of psi. That is the probability.
Okay. And you think that Born and Schrodinger disagreed about that? After the opening months of quantum theory.
Look, I listened to a lecture by a guy from MIT, and he told the story that Schrodinger.
Well, you're talking to a guy from Stanford, so.
No, I'm not judging. I'm not judging. I'm just telling you what I heard. I barely know anything. I'm just telling you what I heard. I heard the story.
That's the first honest thing you said in a long time.
What did you say?
That's the first honest thing you said in a long time.
Hey, that's not nice.
Is NASA poisoning the well again?
NASA, please.
No, I'm just agreeing. For a change, I'm agreeing with Mr. Slave. When he says something that is correct, I will agree with him. And I agree with him what he just said.
Okay. Anyway, so I just heard like a week ago the story, the history. So the professor in the lecture in MIT on YouTube, so he asked, what is the interpretation of Schrodinger's equation? What does it mean? So he said, well, let's ask the guy who created Schrodinger's equation. Let's ask Schrodinger. So he said, if we ask Schrodinger.
A very silly thing to do, in my opinion.
I mean, I'm just telling you what the guy said. So he said that Schrodinger said that the wave equation describes the density of the electron, where the electron is and where it's not. It is the electron itself. It's not probability. So Born argued, and Born said that's impossible to tell me that the wave equation describes the electron itself, because the electron, like if a free electron goes and hits something, it deflects. Yet the wave equation says that it disperses, and we know it doesn't disperse.
What? It absolutely is described by the Schrodinger equation. The Schrodinger equation predicts, along with the Born rule, everything that we see. I am unaware of a single example of the Schrodinger equation not being legitimate.
No, but without the
it would be the biggest thing in physics if it were demonstrated.
That without the Born rule, just the Schrodinger equation describes the electron itself. That's your opinion?
I mean, it describes electrons, it describes protons, it describes all particles.
Wait a minute. I wouldn't say Schrodinger would say that. Schrodinger designed.
I don't care what Schrodinger would say.
Wait, what? But
Schrodinger, and also I don't agree with you that I don't agree that is Schrodinger's position. Schrodinger understood Schrodinger's equation. He even came up with some other formulations of quantum theory that do some other stuff, like pilot wave theory was originally that was de Broglie. Sorry, that wasn't Schrodinger. That was de Broglie. Never mind. But
Schrodinger died 60 years ago too. So
that too, yeah. Like, what's your point? Like,
as far as I understand, I like Schrodinger.
It was originally thought up as the equation for the electron. That was how he originally proposed it. But it was quickly realized, and the earlier versions were more specific about that. He actually published several papers where he gave different versions of the equation, and before he finally published in 1925 the Schrodinger equation. And he always used the electron as the particle of interest because it was the most interesting particle around, and it was the most understood particle around as well.
Wait,
but that does not mean that he did not realize within fairly short order meaning a few years at most, that that quantum theory explains more than just the electron.
Wait, hold on. So we can come back to that, but you keep calling it a particle. Schrödinger wouldn't call the electron a particle. Schrödinger described a wave, so he would call the electron a wave. He wouldn't call it a particle, right?
Tomato, tomato?
Wait, what? Wait, but it's if
are you?
No, hold on. So look, okay, let's leave Schrödinger alone. So if the wave equation describes the electron, but it's describing a wave, then the electron is assumed to be a wave. No?
Yeah?
It's not a particle.
It's a particle and a wave, bro. It's wave particle duality is like one of the things of quantum mechanics that is so fascinating and interesting about it.
I don't find
it's more fundamentally a wave, but it exists discretely. A position measurement will give you a single location. Those are traits of a particle, not traits of a wave.
I wouldn't say that. I mean,
but clearly.
No, so to me, like, I believe in the ether, you know that. So to me, there are no particles in the ether except for maybe the ether particles, but there are no particles, and an electron is never a particle.
You and I are operating with very different definitions of a particle.
So no, wait. So I'm just saying there's nothing in the universe except for the ether. Everything else is a wave in the ether. Just like there's no voice particles. There's air compressions and depressions created by my throat clapping, however voice is created. But there's no voice particles. It's just voice waves. Now with quantum waves, they just happen to be really, really tiny, and they have momentum, and they
don't have to be that tiny. You can have quantum systems that exist over macroscopic scales.
Right.
The record, I believe, is 18 centimeters.
No,
but hopefully we'll be breaking that soon.
You can have a photon the size of the solar system or the galaxy if you want over time.
Yeah, but that I'm talking about particles with mass. I'm talking about atoms.
Okay.
Wait. Can I? What would I search up to search that up? I'm interested now.
Oh, let me find it. It's one of my boss's papers from like 2017.
Wait, you have a boss?
Yeah, I have a boss. I'm a postdoc.
Boss is like the head of the department?
No, my boss is Jason Hogan at Stanford University. He's a professor, and I work for him, and I work in his group on the experiments and stuff.
On the linear accelerator?
No, hold on. Give me a minute to look up the thing that he was asking me for. Oh. Okay, so this is a lecture. I was wrong. It was not 18 centimeters. It was 54 centimeters. This is a lecture from my boss's former boss. Now they have offices next to each other, and they're both professors. But he used to be a postdoc in this guy Mark Kasovich's group. And this is a lecture from Mark Kasovich that is giving a talk on it. For a I mean, they probably are going to cite the paper in the thing. But now that I have the right number, why are you not like this? Oh, I didn't realize Tim Kovaci was first author on this one. Here is the paper. Or Yeah. Okay. So the link is a PubMed one. It was a Nature paper. I'd also let me give the Nature paper link. Quantum superposition at a half-meter scale. That was published in 2015.
So you believe the cat is both dead and alive?
I do believe the cat is both dead and alive.
So am I also right now both dead and alive?
Yeah.
Am I also on the other side of the universe?
I don't know if I could call that you.
But you believe that
But
I'm everywhere except for when
no, I didn't say that.
So I don't understand.
I think we're all okay. But I believe in the many worlds interpretation of quantum mechanics.
Oh.
That is not necessarily a thing that everybody believes.
Right.
I'm not claiming that that is universally accepted physics. That is not universally accepted physics, and it would be irresponsible to have that be universally accepted physics because it's not something that you can verify. It would be something you could falsify. If you could show that the Schrodinger equation does not hold, that would immediately falsify Everettian many worlds interpretations of quantum mechanics.
But do you realize, I'm sorry. But do you realize
I was done.
Yeah. Do you realize, like, to me, how crazy to the power of crazy all physicists are compared to just going back to the ether that just explains everything mechanically and satisfies all of modern physics, basically?
It doesn't.
Yeah, but it doesn't though.
What's the problem with the ether? Can you tell me?
It doesn't explain so many things.
Like what? Give me one example. Hit me with your best shot.
Time dilation?
Time dilation comes out of the ether instantaneously. Both.
No, how? Okay, what definition of ether are you using? Because if you're using a definition of ether that just wraps everything into it, then you're right.
No. So I'm assuming, like, you can assume basically water. The universe is filled to the rim with water.
Okay.
All the galaxies are suspended in water, in a fluid just like water. It's incompressible.
How does time dilation come out of that?
Whether you like it or not, it does. So, like,
how?
Sure. So everything is a wave. Everything is waving, and when you move through the fluid, your internal waving clocks, they're all light based. They all wave slower. So
that is an additional thing that you're adding on top of the ether. That is not that does not emerge from the ether on itself.
No. I didn't add.
Yes,
No.
Yeah, you just did. Because before the ether didn't have that property, and you added that property.
I don't know what is before. Like, I don't know what you mean by before. Before what?
Before you had the idea to add that property to the ether, it didn't have that property. It's just the ether is the medium that light travels through.
Yeah, so that light is quantum mechanics. So
that does not include this time dilation thing that you just described.
Look, so I have internal clocks, right? The electron in my brain, it's a wave, and it's waving through the ether. And if I am moving, then it has to, right? You can imagine the Einstein photon clock.
Well, if you're Einstein would definitely believed in relativity.
Yeah,
so
I believe in relativity. I believe in all of modern physics. I'm not.
Then you don't believe in the ether. Those are contradictory statements, my guy.
I figured everything fits perfectly. Like, you're asking me to fit.
It doesn't.
Okay, I'll explain to you. I've been doing this for a couple of months. I have special.
This is my point.
What?
That's my point. You've been doing it for a couple of months.
Yeah, and it works. I have special relativity.
Bro, let me know when you've been doing it for a couple of years.
But
and when other people who have been doing it for several years also think that it's worth something.
Fine. I'm just, you're asking me for, I said, hit me with your best shot, and you want time dilation. Time dilation came out of my ether instantaneously, whether I like it or not.
I won't disagree with that. It came out of your ether instantaneously, but you're adding a bunch of things to the ether to do that.
No, it's just water.
That's not the same ether that they believed in the mid 1500s.
It's a little different. Mine is also gravitational and quantum. So I like.
Oh, well then use a different word, dude.
But it's also the medium through which light. It's ether, which is luminiferous ether and gravitational and quantum ether. It's three. I throw three things into the mix. Special relativity is basically quantum mechanics, and gravitational ether, that's basically quantum gravity. So I have quantum gravity, and everything works together. So it's a theory of everything, if I'm not mistaken. My quantum gravity is the ether. The ether flows through me right now. This fluid flows through me, slowing all my clocks down, creating, of course, time dilation, gravitational time dilation. It's flowing through me, and it's dragging me down. So it's quantum gravity, and it fits all of physics. It makes the apple fall. We look at the apple, and we use Gauss's theorem to get the inverse square law. So we have Newtonian gravity, and we have
Newtonian gravity. That's only like what, 130 years old.
Doesn't matter how old it is.
It's coming up on 400 years old. But your point, it was debunked 120 years ago.
How?
Well, no, it depends on what you mean. Measurement-wise, it was debunked in the 1800s when the perihelion of Mercury got out of whack.
So we looked at that last night. So the Mercury, that's frame dragging, and that, I don't have a problem explaining frame dragging. I have viscosity apparently. So GR, I'm just now learning GR. So GR assumes, I guess, like what Einstein called the tensor. You could reinterpret the tensor as fluid dynamics with viscosity.
That's not what a tensor is.
Well, you can reinterpret it, I think. I'm working on it right now.
Well, okay, but then it's not a...
It doesn't
He has
matter.
no idea what a tensor is.
Look, it doesn't matter because...
Dude, I have a hard time giving you a definition of what a tensor is. It is a quantity that has components that transforms in the ways that a tensor transforms.
Right.
It is actually one of those things that is sort of circular in its definition a little bit.
It doesn't.
Actually.
It doesn't matter because Einstein just took basically the fact that there is gravity, and the fact that there is special relativity, and he just combined them into GR, right? Whatever he did, he just assumed gravity. He never explained gravity. So GR sits on top of what we notice is gravity. And I'm explaining gravity using basically quantum mechanics, and I'm explaining special relativity using this fluid. Everything is explained by this fluid. There's no contradictions. Everything works out. GR is compatible. SR is compatible. The constancy.
You should write a book.
Oh, I'm writing papers tomorrow. Tomorrow. Oh, today.
You should send me your papers, and but you should start like from the very beginning and go like tediously step by step. It will really help people because other people have not thought about this in the same way that you have. And the fact that you were the first person to figure it out means you probably have seen some insight that is very difficult for other people to see. So when you write your paper, it should be as elementary and step by step with examples and everything.
Okay.
Like so that anybody could just not anybody but it would have to be a long paper, is my point.
Well, I have multiple papers. I don't like one long one. So like
Yeah, that's
fair. I have a specific paper, what I showed you, that shows that from ether you get that the speed.
I don't know if I read that yet.
We looked together, remember? So it's about how the proof of Einstein's second postulate, that from ether immediately you get that the speed of light is a constant to all observers, and you get that whether you like it or not. That comes out.
I guess.
Weasel, you ever read his paper about that? You ever read his paper about the rubber duck and the tick and the talk thing?
I think I did read some of it. I've been sick all week, and I'm still sick, so like I'm not going to remember this conversation very well tomorrow.
It's recorded, so you can watch it on YouTube.
Well, that's horrifying.
And so is our previous conversation. I'm recording everything for all the generations to suffer.
Well, I just want you to invite me when you go to Sweden, because I've always wanted to meet a king. If you have the theory of everything, when you get your Nobel Prize, I would like to be there, please.
Well, first I have to pay 2 people. Totoro needs $100. Who do I owe $1,000?
Well, because you get like $1 million, I think.
You get if you win it on your own.
Right.
It's grown recently. When my advisor got it in, well, he got it way before he was my advisor. But my advisor was Eric Cornell, and he got it in 2001, and I think it was like $270,000 or something, because he got a third split of it.
1 million. It's 11 million kroner, which is $1,035,000.
Yeah, but I think they've increased it. Either they might have it linked to some sort of like global inflation, or they might just increase it every so often, because it's definitely not always been that much.
11 million Swedish kroner.
Well, then there's the speaking fees, right?
Oh yeah.
Yeah, but the only people who pay you to speak, as a Nobel laureate, generally, unless you go out there and do kind of weird, shady stuff, are going to be other universities to have you speak on the topic, and they're not rolling in dough. They pay for your travel and everything, and they put you up in a nice hotel, but
okay, then maybe just job security.
Oh yeah, you do have that.
Yeah, plus every university wants you to come because they all want a Nobel Prize laureate.
That's good. Anyway, do you want me to email you? So I wanted to put it on Archive, and Archive, the server, it says that I need someone like to sponsor me, whatever. Like I need, like.
So I have actually not personally submitted a paper to Archive yet, because I haven't been first author on a paper yet, which is very, very abnormal for somebody in my position.
Mm-hmm. So,
and I will acknowledge that, but
can you help me like publish it on Archive? I can send. I mean, I can send it to you.
I'm not. I would have to become convinced that you I would, like I said.
Yeah.
And this is why, I don't think maybe you understand what it is that I'm asking. I'm asking for an elementary mathematical construction that is elucidated exceptionally clearly at every step.
Is it Ig Nobel worthy for the Ig Nobel Prize?
Well, no, the Ig Nobel Prize is for things that are actually good, awesome science. They're just kind of absurd and hilarious too. They're not for bad science. The Ig Nobel is not given for bad science. It's given for funny science.
Yeah,
that's what it's really given for. It's given for people who study farts. Okay? Farts are a thing that you should probably study for reasons.
Yeah. Is it like when people study light and they come up with words like quark?
Well, quark is not. Quark and light have only quark is well defined. Light is well
Is,
defined.
is NASA still talking? Tell him I'm not addressing him.
Of course not, because you don't talk to anybody to talk sense into you.
Oh,
What are you asking?
Who, me?
It's a little bit quirky. Is it a little bit quirky that they call it a quark? Because it's
okay, yeah, that's fair.
And act like a wave. So there's it's a little bit quirky. Oh, we'll make that a scientific word.
I don't know
It's like
where
they're-
the name quark came from, actually.
I'm telling you right now.
Brenda,
I'm telling you
what's
right
up?
now, folks. They didn't know. They thought they thought it was a little bit quirky.
Nope.
You want to hear? You want to hear?
Yeah.
3 Quarks for Muster Mark from Finnegan's Wake by James Joyce.
Well, who decided that? Was it Gelman? Was that
Yep.
who decided to name it?
Yep, it was Gelman.
That
I'm telling you, that's like in the
Caltech.
last 10 years. they
What a
came up
chump.
with that.
Anyway, do you want me to
With what?
With the word quark to just try to describe light.
Wait, nobody is describing light with quarks.
What?
That is not how light. Do you know what a quark
I'm
is?
telling
Do
you
you
right
know
now.
what light is?
Don't trust Brenda. You know that already.
Quark is this cheese. Quark is this
Light-
cheese that you can get
Hey,
at the cheese counter. It's really good.
Light is a boson, not a quark.
It's a
And
what?
quarks, for the record, are not bosons.
They're a little bit quirky.
It's quark is a little bit drier than for instance cream cheese.
Anyway, Tapioca Weasel. So, do you want me to email you, or do you want us to continue the conversation?
Tapioca.
Tapioca.
Yeah, I mean, well, you're Mr. Slave, right?
Yes, they changed my name because I didn't pay.
Why did they change your name, by the way? That was confusing. I did not recognize.
I promised them to develop the equation of light deflected by the sun, and I got it by 2, like by the power, by a multiple of 2 off. Like I got
Well,
it.
that's pretty good. I'm gonna a lot of people would say that see, you're totally wrong. My response is completely the opposite. If you
he
have
had,
an actual
he had a factor of 2 off in the amount of time it would take.
No.
A factor of 2 is not a thing I have a problem with if it comes from an interesting, coherent to follow explanation. A lot of people are off by a factor of 2 before they're not.
So I just assumed that the deflection of light would be exactly the same like a deflection of an asteroid. So I asked ChatGPT, how would an asteroid be deflected? And I took the answer and I submitted it, and it's off by a factor of 2.
So therefore, but part of the bet was you would derive it in a certain amount of time. Instead, you just GPT'd it and put it forward.
Yes.
So that is in complete violation.
Yes.
That's the thing is I'm going to I'm gonna ask how you figure this stuff out, and you're gonna need to show your work.
Yeah.
I don't think you know what that looks like.
No,
he treated it like a bit of mass, like matter, and so he treated this. He said it would be the same as an asteroid.
It would be,
which is
it
looks like
for a lot of reasons.
It would be exactly like an asteroid if it's an asteroid at speed light. An asteroid.
An asteroid at the speed of light isn't an asteroid. That's not a thing that exists.
Okay, take a proton.
Well, no, an asteroid has mass.
Yeah.
Hello, asteroids have mass.
Yeah.
Asteroid has mass.
Yeah, you can take a proton at near speed light, and it would be deflected exactly like light. Very close. The closer you are to the speed, according to ChatGPT. So the closer you get to the speed of light, the closer you get to theta deflection like light. It doesn't matter if you have mass.
That makes plenty of sense.
Now you know why he lost the bet.
But, dude, I mean, the one part where you said something that was exactly correct was the part where you're acknowledging that you're getting it from ChatGPT. You don't know what you're doing.
No. Like, if I need to figure out the deflection of an asteroid, I would sit down and do it. I ran out of time, so I just asked ChatGPT. And anyway,
Do you know how? It's not easy.
No,
You
it's
lost
not-
the bet.
No, I promise that I'll deliver it in 20 minutes. And
longhand.
You shouldn't. Here's the thing: is it's not that easy. If you asked me to do it right now, do you know what I would do? I wouldn't just do it. I would look up a paper where I did it, like a paper I did for my comps too. It's my own work. I did it, but I did it then, and I wrote it down because it's not totally trivial to do off the top of your head. You have to assume a certain mass. You have to, and then think about of the velocity as it's coming in, and the deflection angle, and you have to do an integral, and you have to choose exactly what time to like do the binomial expansions and everything. And it's not.
I know, no, but it doesn't depend on the mass of the test particle. That's not a parameter because.
No, you're right. It doesn't.
Right. It just depends on the mass of the sun. Like if you're bending light around sun or bending an asteroid around the sun. So it just depends on the mass of the sun, the velocity. So if the velocity is close to
I
c,
really don't understand what's going on.
ask questions. Anyway, Tapioca Weasel, can we have like I want to continue our discussion like about so many things, but especially about my ether theory and
Yeah, we should start from. I mean, if you want to do it, you're going to have to.
I wrote
what is your problem with physics that already exists?
It's not scientific by my definition. Like science by my definition.
You have an awful definition.
Look, I know where you end up. You end up with multi-universes and stuff that
that is a very specific thing. A lot of people don't believe in that. Okay.
Yes, but you also have cats dead and alive and spooky action in the distance. You have things that I cannot live with. So I need to take away. I need to take away your science, and I'm going to redefine science and start from that. So at least in my head, like I'm saying, in my head, I need to redefine science.
And that's the only place this will ever be.
Stop.
So I don't understand you at all, Mr. Slave.
Wait, I didn't tell you the definition. Just I'll finish this definition and then you can go. So my definition of science, it must be mechanical, and then the ether came to me. The ether is the only explanation to mechanical gravity or quantum mechanical gravity.
So how do you deal with quantum superposition over?
I don't have quantum.
Like cleared instances that we can tell.
I don't have quantum superposition. I don't believe in that. Why would you say that?
You're wrong.
Wait,
dude. Oh my God, that is my day job.
What's your evidence?
My day job.
What's your evidence? What's your evidence that there is quantum superposition? What's your evidence?
The fact that we observe quantum superposition. The fact that I can zap a particle, an atom of strontium with a laser that is at a particular frequency, and then after a certain amount of time, I can observe a phenomenon which is exactly predicted and concordant with and exclusive of other explanations for.
Like what?
Quantum superpositions.
No, what's the evidence? What is the evidence? No, really. Like, look. Quantum superposition.
Atom interferometry.
What interferometry?
Atom interferometry for one.
Well,
Bell tests for another.
Yeah. So Look, I don't know. Look, we can talk about it, but look, there's a problem. Superposition violates my definition of science. So
your definition of science is wrong then. Does your definition of science, what is the final authority on your definition of science? Is it observations and reality that we observe around us?
No.
It's not.
I must be able to understand.
Hold on.
I must be able to understand it. Look, you can.
That's not science.
No, listen. You can put a magician on stage and he'll do tricks. I don't care. If it violates my intuition, it doesn't exist. That's it. That's the beginning, the middle, and the end.
Okay. If dude, what you just said was the sentence, if it violates my intuition, it doesn't exist.
Yes.
That is an absurd position.
Well, I think where you end up is absurd. So I'm starting with logic. You lose
argument from. You're not starting from logic. You're starting from if I don't intuitively understand it, isn't real.
No,
That
no,
is
no.
your position that
No.
you just said.
Let me clarify. So at the end of I'll clarify. Look, there's many things I don't understand, and there's
Okay, well, here goes the back pedal.
No, I'm not. I've been stop. So ultimately, the universe is mechanical. Ultimately, the universe is simple and intuitive. If I could see the part of the actual, at the bottom of everything, if I could see how that works, it's very simple. And at every level, why? That's my assumption. Because otherwise, I see where you end. You end in hell. Currently, science.
No, we don't, dude. I'm
to
quite
me,
happy.
yes. I am unwilling to be a participant in what is now physics. It's nonsense.
But we're quite comfortable with your lack of participation, personally.
That's not nice. You should be welcoming. You shouldn't say that.
Dude, I wouldn't have said that before this conversation. I wouldn't. But the things that you have said are absolutely antithetical to the spirit of science, the philosophy of science, the practice of science, the reasons that science is successful, and you don't.
Look, I've been able to fit everything into my definition of science. So right now you tell me.
We're beyond talking about that at this point, dude.
Why? No, my mechanical. No.
You assume that the universe does have an obligation to make sense to you.
Correct.
That's not true.
Well, that's my definition.
It's obviously not true.
Well, I demand it. So it's between me and the universe. So no one is going to interfere.
Okay, well,
does anybody care what you think?
But the point is, I've been
Tapioca, make a choice. It's either your relationship with Mr. Slave or the universe. So make a decision.
Okay, stop, Gamma. Be nice.
Say, Mr. Slate, do you know what superposition is?
The cat is both dead and alive somehow, and to me that's
No.
senseless. No,
that is an example of it.
The general case, what is superposition?
Well, I don't know. It's supposed to be senseless. It does, right? By definition.
You don't know what it is.
What?
You don't know what
you're talking about, and you're assuming it's senseless. It's not senseless. It's counterintuitive. You're absolutely right about that.
So it doesn't
But
exist.
a lot of things are counterintuitive,
Then
bro.
They don't exist. When
two, Mr. Slave.
Yes.
When two waves interact with each other.
Yes.
The crests add to each other and the troughs subtract.
Yes.
That's superposition.
Yeah, I don't have a problem with that. Obviously, we're talking about
Well,
cats
then you
being.
don't have a problem with superposition.
No, we mean cat being both dead and alive.
Well, there's a wave equation.
Tomato, bro.
No.
There's a wave equation that describes
waves. No, constructive, destructive interference. Of course, I've seen. It makes perfect sense. It's completely mechanical.
That's superposition.
Then I accept it. That's not the cat.
That's superposition.
That's not the cat. The cat is not both dead and alive. I don't know what that means. So that does not exist. You said the cat is both dead and alive. You said I am both dead and alive. I don't.
Do you think that the photon goes through both slits in the double slit experiment? Like, that's obviously impossible.
Why is it impossible? It's a wave. It should
Jesus Christ, my guy!
What?
Like,
it's a wave.
How are you? Where is the line that you were drawing?
It's a wave. What? It's a
Where
wave.
is the line? Why isn't the cat a wave?
I mean, the cat is many, many, many tiny waves, which is a particle. I mean, the cat looks to us like a particle. Look.
Yeah, so does a photon.
What, a photon? What? Is big?
The cat looks like a wave if you're able to look at it properly. So far, I'm not aware of any experiments that are able to directly detect the quantum mechanical nature of an entire macroscopic cat. Certainly not one that, you do have an ethical responsibility, towards.
I believe.
And there's this thing called decoherence and entanglement, which are somewhat advanced topics in quantum mechanics, which is probably why they are difficult to understand.
I don't accept spooky action at a distance. That's impossible. Everything.
It's pretty unavoidable.
Dude, they gave the Nobel Prize last year for this guy, Alan S. Bay. Nice guy. I met him when he visited our university. But he's done experiments on these things where the measurements are made far enough apart that, and at the same time, according to a prearranged, like synchronized clock, that it is but determined in a random way, that it is impossible for there to have been information transfer.
Wait, so
and you still observe this so-called spooky action at a distance. We've done the measurements.
Okay, look, then we don't understand something. We're missing something. It's against.
You don't understand something.
And that's enough.
And apparently when you understand it, it becomes reality.
To me, yes.
Which is in the most absurdly narcissistic position that I think it is possible to have.
No, this is
It's
nothing
the
to do.
inner solipsism of solipsism.
No. I'm not a solipsist, and this is not narcissism.
You are beyond a solipsist.
I'm not. No. That's not true.
You really are, dude.
No, all I'm saying, look.
You're demanding that the universe makes sense.
Look, I'm not demanding, like I'm ordering the universe to do anything. I'm demanding, like everybody says the opposite. So I'm saying, they say the universe is under no obligation to make sense. I say, yes, the universe is under obligation. Of course, it's neither. There's no obligations. It's just that that's the nature. I believe that's the nature of the universe. It's simply, I cannot understand a different nature.
Well, there's a difference between I can't understand and it doesn't make sense.
Look, if it doesn't make sense to me, then it's the end of that. If it doesn't make sense, that's the end. I don't know.
Maybe it's you that is lacking.
Whatever.
So if I say calculus or algebra doesn't make sense to me, it doesn't exist.
All right, to me,
yeah, you just don't. I'm not saying that you're fundamentally lacking. I'm saying that you don't have the education.
No. It's nothing to do with education. It's like we know.
Dude, go fix a plane or something.
No. I've look, 4 months ago.
You could apparently just do physics at a level that nobody else in the entire history of Earth can do.
No. I'm not.
I got a question.
Hold on. I'm not doing physics at any level. I'm doing. Look.
Obviously.
No. I just redefined science. Redefining science. 24 hours later, I found myself needing to invent ether gravity, which is quantum mechanical, which is quantum gravity. I had to invent it. I couldn't. The apple. I couldn't.
Did you hear that?
Hold on. I couldn't make the apple fall. I couldn't find out why is the apple falling. I had to come up with the ether, with some material that is flowing through the apple, dragging it down.
Did you consider taking a physics class?
Well, he doesn't need to. He just invented quantum gravity.
Okay.
Because when I wanted to know how the world worked, I took a physics class.
No, we're going
We're in
on,
the presence
no,
of a stellar intellect.
We're not going to discuss me. We're getting off topic. I'm not the center of discussion. I'm just look.
You're making yourself nothing but the center.
I got a
of it.
question.
What the hell are you talking about?
Your ontology literally does do that.
What?
Your ontology literally makes you the center of discussion.
I'm not. No.
It's epistemology, not ontology.
I'm not the center.
No, he's asserting existence is contingent upon his understanding.
No. I'm redefining the definition. I'm redefining my science. Everybody will define.
Actually, right. I'm sorry.
Everybody will define their science how they like it. I define my science how I like it. It's between me and the universe.
I thought science was defined already by scholars.
Well,
Good for you. We're glad you've defined your science the way you want to define it.
It's for me.
Define it now.
Okay,
that's your business.
Let's stop
Keep
talking
it to
about.
yourself. Nobody cares.
Let's stop.
We've heard enough.
Let's stop talking
You
about
have been
me.
whining and
going
on and on about this for days and days. And I've heard about enough.
No. If this discussion is going to degenerate,
this is bullshit.
Okay, if this
it is degenerating. We're no longer interested. To be frank, I'm not particularly interested in continuing the discussion at this time. Maybe we can discuss it later, but right now I'm kind of done. So
I think we were done at the very onset of when Mr. Slave started all this.
Is this maybe an elaborate troll?
Congratulations.
Well, Marty had something to do with it then.
Okay, everybody, do me a favor. Stop talking about me, please. Come on, stop.
I got a question for you, though, Mr. Slave.
Only if it's
This
not
is
something.
math.
Stop.
It's not physics.
Look,
It's not physics.
Brenda, let me
It's not
ask
physics.
Brenda, please don't hurt my feelings. I'm not here to be mocked.
It's not
Please,
physics.
Brenda, please.
It's not physics.
What are you saying? I don't know what you're saying.
Whenever you multiply, say, two numbers, you always get a positive number, don't you? 3 times 5.
Whenever you
it's gonna be
multiply
15.
any number, any positive numbers, yeah.
Any numbers.
Well,
Even
Brenda,
negative
yeah, is 0 a number, Brenda?
Yes, it is. It's even.
Is 0 positive?
I don't know. Brenda, where are you taking this?
Is it true? Do you think it's true?
Brenda, I am compliant with all of physics and math. I'm not. I'm
Just say you don't know. That's the answer that gets you out of this.
Don't know
Slave
what?
is you don't know.
I don't know what.
You think that there could be a number that when you multiply itself,
Brenda,
you get a negative number?
Brenda, I'm compliant with all known math and physics.
That's not actually what you said.
What do you mean?
Brenda, that's
You're
not what
right.
you said.
I messed it up. You're right.
You messed it up because the way you said it is you multiply any two numbers.
Yeah.
And that is.
You're right. You're right. I fucked up.
See, I'm operating in good faith here, Mr. Slave.
Yeah.
Now,
I wanted to see if his intuition.
I think we can move on from the topic. I think.
Sure.
No, like I'm not trying to make you feel bad.
That's
okay.
Fine. I appreciate it, but a lot of the people here they do nothing but attack me. It's like I never get to talk about physics. It's always how terrible of a person I am. Nothing but that.
Well, okay, I have absolutely. And I do not condone that unless he has demonstrated that he deserves that for other reasons. This is not, by the way, an invitation for people to suddenly bring up a whole bunch of reasons, but hopefully I have not given you that sense that I am talking about you as though you are
Reason number
person.
1 of
You
20.
were very nice. No, everybody's okay lately,
Well,
but
that might be going far, but
sometimes
thank you.
Sometimes they start attacking me and waste my time, and they have nothing like.
What's that?
Like I'd rather.
So if we contradict, so if we contradict you and ask you questions in relation to what you believe, that's attacking you.
Of course not. Of course not. I wish you would talk to me, like ask me, like actually find contradictions in my theory, show me how my theory is not compliant with Einstein or quantum mechanics. Like find contradictions between my theory and known physics, modern physics, mainstream physics. Like talk to me about my theory. Stop talking about my knowledge of math, my knowledge of physics, Stop it. Talk about my theory.
Whoa.
That's it.
You can't is your theory not mathematical?
Yeah, that's what I was going to get to.
No, I don't want to fall down that hole again. God damn it.
Yeah. I didn't want to steal Manny's position for you.
But you have to understand, he's been researching it for days.
There
he's had a lot of time.
Okay, you see where they're going. Like they're not attacking the theory. They're attacking how much time did I spend on it.
Okay, here's the thing though.
Mm-hmm.
That is why I told you to go repair a plane.
Why? That's
the concept was that you are trying to.
No, that's personal.
Do you understand what I'm getting at? You don't.
No, he doesn't.
No, that's not. Nice.
If you want to repair your car, you go to a mechanic. If you want to get healthy, you go to a doctor. And if you don't, you measurably do worse.
Look, we can talk about my theory of everything or not talk. So
I don't feel like talking about your theory of everything. I would be much more interested in answering your questions about actual theories of physics.
Fantastic.
It would be much more fruitful, and it would be much more interesting, I think.
Perfect.
Test you.
Perfect. As long as we don't talk about me, because I'm like a little tired of talking about nothing but me. It's like enough. Like after a couple of weeks, enough. Like we can talk about the universe. Let's please not talk about me. It's like every time I come to this server, it's nothing but talking about me for endless.
No, what it really is, no, you know what it really is? It's about what you've done and the ability to which you have and what you have put into it. So it's in the aggregate of how you think you can just like do what no other physicist has done in multiple days.
There we go. You see, nothing but me. How dare I come up with a theory of everything? How dare I? That's all I get.
In terms of
I
yourself,
get
though.
nothing else.
Yeah,
on this
essentially, yes. How dare you?
Yes.
Essentially, yes.
Yes. It's not like, please, like I yesterday found a contradiction between my theory and actually Einstein's special relativity. I found a contradiction, but you didn't, because you never discussed my theory ever. You can find contradictions if you just have
Mr.
a
Slave.
Yes.
So you have no.
Do you
Hold on,
respect
hold on,
Mr.
hold on.
Einstein?
You found a
Yes, very
contradiction
much.
in your theory and Einstein's theory, right? So who do you think is right?
Anyway,
who do you think is
Well,
right?
obviously he's right, of course.
So I asked ChatGPT, how do we know Einstein is right?
Oh, wait a minute. Don't bring
hold-
ChatGPT into this.
That's
You
a
bring
different- that's a
ChatGPT
different
into this,
question.
you are fucking done.
That is a different question. In your opinion, who do you think is right?
Look,
If
Einstein.
you found a contradiction between your theory
I'll tell you.
and Einstein's theory,
Yes.
do you think you're right or Einstein is right?
Look, so I'll tell you, you tell me. So my theory is based on redefining science. Science must make sense to me. Science must be mechanical. From that, I got the ether. From the ether, I got special relativity. But there is a contradiction within special relativity. My SR, Einstein SR, there is a contradiction in one case. So
see, Mr. Slave, this is why people attack you personally.
oh my God! Stop wasting my
because
stop wasting my
that is
time.
gibberish.
Stop wasting my time.
It's
Stop wasting my
gibberish.
time. Stop wasting my time.
You can call it gibberish without going down that road.
No, Brenda's kind of just being a bitch right now. Let him speak.
I am not. He said
Yes,
it
you are.
must make sense to me. It must make sense to me.
That's my
Just let him go
I
on.
redefined my science. It's my science. I'll redefine it however I
You
like.
don't get to have your own science.
My science.
You don't get to.
Yes, he
I'm
does.
I'm a
Yes,
free
he does.
man.
No, you don't. No, you don't.
You're not gonna tell me what to do.
I mean, yeah, he does.
No, you
It's not
don't.
gonna work
You don't
out.
get to
It's not
have your
gonna,
own
like, do
private
anything.
universe. You don't get to have your own private universe. You don't get that.
I mean, all in your head you do. You can have
No, you
whatever
don't.
delusion you want.
Brenda.
What do you mean you don't? What are you talking about?
You don't. Yeah, you don't get to have your own
You
private
can have and
delusions.
cannot have.
They genuinely do.
No, you don't.
Getting to have your own delusions doesn't mean they're true. You're allowed. You're
what I'm
allowed to
saying.
have. You're saying that it, okay. My steel man of what you're saying is that it is physically impossible to be wrong. Genuinely.
That's not what I'm saying.
Well, tomato, honestly.
Nope. I'm saying you don't get to have your own opinions. You only get to have.
Wow.
Only.
Okay.
That's
true.
I can. It's true.
I can't
You
have an
don't
opinion
get to
about
have
this.
your
Is
own
this the end
opinions.
goal of
That's right.
leftism?
That's right.
Is this what
Brenda, what?
leftism is left unchecked?
That's right. This is.
I agree with
this is
Brenda on this. Some
first-
people should have their opinions banned.
Really?
No,
Wow.
there was a general you though. Okay,
You
she was
actually-
responding to me.
You have to
Not-
actually
not
let me
at that point.
complete.
I
You have to
don't
Wait a minute.
know.
Wait a minute. Hey, wait a minute. Can we take a reset? He says he has his own science. Let's start there. Let's define his
Can I
own
finish
science
the sentence that I was everybody dogpiled on me about?
No.
Right. The sentence is the end of the sentence is you're not entitled to your own opinions. You are only entitled to those opinions you can defend.
So let's start with his own science. Before we get to his theories, we need to get a foundation of what his science is.
His
So you
science
tell me we'll
is,
both know.
if it makes sense to me, it's real.
No,
If it
he has to
doesn't,
say
If
it.
it makes sense to Brenda, then you can have that opinion. That's
He has to say it. He has to codify. He has to codify what his science is.
Yeah,
He
and if
has.
it makes sense to Brenda, then you can have that opinion.
No,
is what Brenda
that's
said.
incorrect. Incorrect.
No, I said that. I'm willing to bite that bullet. If it makes sense to me, you can have the opinion. If not, get fucked.
Ban all opinions. No opinions are allowed.
That's incorrect.
At this point,
That's
yes.
what I said.
Was that
Again,
your opinion?
Don't apply that to Brenda. Brenda's
Only
more
entitled to
intelligent
those
than,
opinions
than I am.
you can defend. Right? Einstein is entitled to his opinions because he can defend them.
Do you want me to defend my opinion? Would you give me a chance?
Yeah, I
Well,
do.
we've heard
To
your
be fair,
opinion.
you have been given chances. That's my opinion. Maybe you disagree.
On this
I would
server?
imagine you do.
You're one of the first times. This was one of the first times. Your conversations with you are basically the only times I had a chance to speak, to even speak, not about me. It's always about me. How dare I express an opinion? How dare I contradict Mr. Einstein? How dare I? Because Einstein obviously was never wrong. He was never wrong about gravitation, about gravitational
Yeah, he was
waves,
totally wrong sometimes.
about black holes, his lambda, his greatest mistakes. I mean, the list is no. He said he doesn't understand relativity since, like he says, since mathematicians destroyed it, he doesn't understand relativity. Look,
that might have been a personal dig at his advisor Minkowski.
Yeah. Look,
who came up with the whole space-time thing. Einstein really came around to the space-time conception after a little bit. His initial reaction was definitely negative. That is true. But he came around to it, and like I said, this was the reason that when we were discussing Schrodinger and I brought up De Broglie, but where the fuck is my vacuum? God damn it. Why I was like, I'm not going to. I was hasty when I said it doesn't matter what they think. It matters for helping I think a historic understanding of how science is developed can be extremely helpful in intuitively grasping those sciences, and I think that's true in quantum mechanics as well. But it doesn't. Oh, man, I lost my train of thought. That was a tangent. Fuck.
So I respect Einstein. I respect Newton. I respect you. I respect everyone in this room when they talk, like not nonsense, not talk about me and the fact that I don't know
I don't
physics.
believe
Damn,
you.
that's
I don't
the
believe
weasel.
you.
What are you walking to your fridge or something? Jesus.
So I respect everyone. I try not to attack anyone, even though you keep attacking me.
That's a lie. That's a lie.
What is the measure? What is? How do you determine the truth of a proposition?
It's between me and myself. So I'm not here.
Yeah, that's wrong.
Look,
Mr. Slave, you notice that all they're doing is talking about you, and you keep falling for it. You can't talk about your theory because all they're talking about is you.
Yeah, they
and
keep-
you
I
fall
asked-
for it
I
every
asked-
time. So it
Yeah.
is your
I asked
fault.
him directly. I asked him directly about his theory.
When?
Just now.
So I answered. It's between between me and myself. Look, at the end of the day.
Yeah, that's incorrect. That's incorrect.
Look, Brenda. Look.
That's sophistry. That's sophistry.
Brenda.
Here's a life hack. Pretend Mr. Slave doesn't exist when you talk about your theory.
Yeah.
Try that.
Here's the life hack. Shut your mouth.
Brenda, hold on.
You see, Brenda realized that'll
Don't worry about it.
eliminate her
Don't let me.
attack.
No,
The
no.
idea.
You-
The
you-
idea that.
Wait,
The
Brenda.
idea that truth.
Wait, Brenda.
The idea that truth.
Brenda, let me
is
answer.
subjective, but it
Brenda.
depends on
Let me
me.
an- Brenda.
Is sophistry. It's
Brenda,
the definition
Brenda.
of sophistry.
Wait, can I answer, please, Brenda? Look, So at the end of the day, I'm curious about the universe. And I've heard
You're actually not.
Brenda,
You're actually not curious
Brenda,
about
it's
it.
between me and myself. I'm curious about the universe. I'm trying to figure it out. So
you're not.
I don't care.
You're not trying to figure
Look,
it out.
Brenda.
You
I don't.
objectively are not
Brenda,
trying to
I'm
figure
not
out the
here.
universe.
Brenda, it doesn't matter what you say about me.
Yeah,
And please,
cry harder about it. I don't care. When you say that the universe depends upon me and my opinions, you are objectively not investigating the universe.
No, that's not
You
what
are
I'm
navel
saying.
gazing.
No,
You
no,
are
it's not.
navel gazing.
I don't know what that means.
Are you done? Can you?
It
can you
means that
continue
you're
now,
staring
please?
at your navel, right?
That's not nice.
You are sucking yourself
Can we get a
off.
moderator? He's
Brenda,
attacking
Brenda,
Mr.
that's
Slade.
not nice. That's not nice. Look,
You are navel gazing.
Brenda, stop.
That is an
That's
inward
not
gaze.
nice. Brenda, stop it.
TikTok.
Stop, Brenda, please. Come on. Look, I said I'm curious about the universe and I want to figure it out. And if somebody explains to me the universe and I can't understand it, then that's the end of that. I gave it, my best and I tried to understand and I couldn't. Okay. I never gave up. Like I never thought about who's right, the multiverse, or the cat is dead and alive. I just said I don't understand it. But then one day I redefined science, and the next day I came up with ether, and after that everything clicked into place. And now I understand exactly the cat is not dead and alive, and I understand Schrodinger's position. I understand the electron, the wave equation, Heisenberg. And everything is falling into place. Every day I'm learning
It's
GR.
not.
Look, to me, everything.
I think
let me explain something. Let me explain something to you. When you begin with a flawed epistemology, a flawed worldview, everything that's built on that is worthless. So your entire philosophy is built on, does it appeal to me? Does it make sense to me?
Okay, Brenda,
right?
thank you.
And
Brenda,
that is the fundamental mistake.
Brenda,
Listen,
no,
I'm not finished.
listening. No, I'm not listening.
Stop breaking. Stop
All
interrupting.
right.
Why do you think you get to interrupt?
No, you're
Right?
talking.
So-
You're
so
talking
then when you
about
base-
me. No,
Can
stop
we get a
talking about
moderator
me.
here?
We're
That's
done
your
with this.
epistemology.
Honestly,
Brenda,
we're legitimately done with this. Like I don't know if I'm the only mod here, but if I am, by the way, Sea Lion, why aren't you a mod? Isn't this your server?
Yeah, it's his.
I am a moderator. I just don't show up as one. Sorry, I'm also moderator.
Well, if the
I'm in, like,
mods
4 different
me,
places.
that's fine.
That's fine. I'm just like I feel like this is a completely we have exhausted this avenue of discussion personally, in my opinion. But there's 20 people in the room, so I feel bad making that choice. But when people start saying, "Hey, we need a moderator," then like I'm gonna. Yeah. I feel like okay at this point. Mr. Slave doesn't really want people to keep on pestering him unless they're willing to be, unless they're willing to, I don't know, tie him up and like whip him with a cat of nine tails and just like Jesus Christ, right? But
is there something wrong?
Can we change it? I feel like we should change the topic.
Yeah, is there something wrong with discussing epistemology?
I think we should mute Brenda and then we can talk to Mr. Slave some more.
I think that before muting, you should tell somebody we would like that to stop or something. But maybe you could explain to me why discussions about epistemology are so triggering.
That's not discussions about epistemology are not necessarily, but if you can do it without bringing up Mr. Slave and his positions, that would be great.
His position is sophistic.
That's not
it's
nice to say.
You know what sophistry is?
All right, say it 10 more times, please.
Nice. Don't say that. That's
All
not
right,
nice to
so
say.
time for substantive critique here. The substantive critique is his epistemology would mean that anything he does not know or anything unknown can never be known. It would be something that would not allow for any advancement of knowledge, because if he doesn't know something, he has no understanding of something. So he can't take a hypothetical guess of what's happening. He can't come up with a theory that he can then validate later. It can't be any sort of advance in knowledge. So it's just a poor epistemology functionally, and it's a poor epistemology in its very logical core because it's all self-centered.
Okay, I'll repeat.
Hey, Mr. Slave, you've really got these guys riled up, man.
It's fine. Look,
I don't
I'll
know what it
repeat.
is.
It's fine. I'll repeat my definition of science. Look, science. Science must be. Look, science must.
Ryan, you're hot micing.
Science must be. The universe is mechanical. To me, the universe is mechanical, and I should be able to understand it. Look, if I don't understand it, that's the end of that. I don't know what to do with something if I don't understand it. Look, I've heard people explain to me the wave function literally maybe 1,000 times. I've heard lectures and lectures, and couldn't figure it out. Okay, and I put it aside. And then I redefined science, and almost overnight I understand, I believe I understand Schrodinger's intent, but certainly I have a good feel for how the wave function describes the electron physically. Now I'm happy.
Okay.
Finally, I'm happy. So by my things,
that's good, but that's
wait one second. Let me finish.
That's a contradiction.
No, hold on. So by my definition of science, things work out just as they should, because my science says I must be able to understand it or reject it. It doesn't mean that as soon as
that's a contradiction.
No. It doesn't mean that as soon as I don't understand something, I immediately reject it.
You can't contradict him. You'll take it as a personal insult.
No, problem. No. What I'm saying is, it's not that as soon as you say something I don't understand, I reject it. As long as I don't understand, I have to reject it temporarily. I put it aside. And to me, it's not an explanation until I understand it. That's all I'm saying. And if I never understand...
So what you did there is you had something that you did not understand, which was you did not understand the Schrodinger or whatever problem it was.
Yeah.
And so you didn't understand how an epistemology where you can't understand something even though it's been explained to you can work. You came up with a different epistemology, so a different definition of science. So you went to a hypothetical in order to deal with this not understanding thing.
I gave it a shot. Look, it was my
your epistemology.
It was I had an intuition.
You've literally got a self-contradictory problem there.
No, there's no contradiction. Look,
this is what I've been saying. I've been saying.
No.
I outlined the contradiction very simply.
Brenda,
you did not understand.
Brenda, you kept saying
science. You did not understand the definition of science that was true. So you hypothetically made one.
No.
And then since that made sense to you after the fact,
not what happened.
You now think this one's true, but you couldn't understand it beforehand.
No.
So you end up with this circular.
Hey, if you keep speaking over him, dog, you might be right. If you just keep speaking over him, not letting him talk, and then when he does get a chance to talk, Brenda cuts him and speaks over him.
Yeah, but dog is.
But go ahead, Mr. Slave.
Okay, thank you. Stop. Look, Demon 2 tried. That's not what happened. I used to be mainstream like everybody else, I know, and believe that the universe is under no obligation to make sense, and the universe is even weirder than we thought it could ever be. And I used to repeat these talking points, didn't think twice about it. But then, I've been debating people about deep things like the philosophy of philosophy and the philosophy of debating and the philosophy of the foundations of logic, and after one debate with a guy that he kept up bringing Bell's theorem and how we really can't understand the universe and the universe doesn't make any sense and basically anything goes, I was so upset after 5 hours of debate with this guy.
Sorry, hold on, Mr. Slave. I don't mean to interrupt you. Why am I echoing?
Somebody's echoing.
No worries. Let's hop over to the debate. MC Tune is here. So let's head over to the debate channel. And then I'm going to promote people up to speak. Shubil, will you be ready to go to discuss some of your measurements to start us off?
I will stay here with Mr. Slave.
Okay, that's if you'd like to. Shubil, are you there?
Wait.
Otherwise, I have other things we can start with, Mike. I don't know if you're here yet.
On the order of an hour. I could sit in and see if I got 2 cents.
Wait, Sea Lion, should I move? Good. Should I go somewhere?
Which channel?
We're gonna head over to the debate channel. I will set up speaking roles accordingly. So
wait, should I go there? Am I invited? Is this for me?
Yeah, you can head over there. I'm just going to promote people first. So, but you can certainly go there.
Okay.
I'll see everyone there.
Okay.
I think
1, 2.
Okay, let's see if I have the role. All right. Mike, you should have a speaking role. I'm not sure if you're able to speak right now.
Yes, I think I can talk now.
Okay, excellent. Let's see. Cool. So we have a couple folks here. Let me just, Dr. Weasel, I will also give you a speaking role here as well. Are we current? Do we go live yet? Or
we are live, yeah.
Okay, excellent. So real quick, I have a couple things I could talk about. Omnivore was just on, it looks like he maybe just got kicked from the space. Omnivore, well, I don't know, are you there, Omni?
Yeah, I'm here. Yeah. They might come back to me. I presented or attempted to present MC Toon's wonderful, how the sun would never set on a flat Earth.
They were excited for that, right?
So unfortunately I didn't have it like at my fingertips. So they shut me down. They said, go on mute. I was like, no, I'll get it for you. Just gotta give me a second. But then they basically muted.
Hey, anybody wants to talk? Because I don't know what they're doing in the other room. They're like discussing not interesting.
Yeah, I can't help you, Mr. Slave, because I've got no understanding of any of the topics that you talk about.
Do you want to ask me questions?
Well, I wouldn't even know where to start because I don't have any education in any of the fields to deal with that type of things.
Are you curious about physics?
Yeah, at a base level.
You want to ask me questions about physics?
Well, there's nothing I can think of right now.
Do you know special relativity?
No.
Are you curious?
Not really.
Are you curious about physics?
Well, physics can take different forms.
Okay, like what forms? What do you mean forms?
Well, I work on cars a lot, so I know physics can be involved in that area when I'm doing something. If I hit something, that I get a reaction to it.
Oh, if you hit something, you get a reaction, like action equals reaction?
Yeah. Yeah.
Okay. All right. Let me hop back to the debate, see what's going on.
So
no, they don't. But you could just you could say the same thing and leave off the last word, and it would still be right. So, yeah. Anyway, it was okay. I knew who I was talking to.
And so, where was this that you were at?
It's Flat Earth Fridays, a Twitter space.
Oh, the Twitter space, yes.
Yeah.
And they like to say, well, if you can't steel man a sunset on flat Earth, then you can't be honest. But wait a second. As soon as you get to magic, then you can't steel man. The steel manning stops.
Right.
So what causes the sun, which according to geometry would be significant elevation visibly, to not be at significant visible elevation?
Well, I said that.
Words. It's just magic, though.
I told them, I was like, you've all tried to do this, and you all know you can't. I'm sure they probably haven't tried to do it, but that's what I said, and they didn't like that.
Yeah.
All right. Wow, Brenda said you're not allowed to have your own opinion. She said good stuff. Okay. Let's listen to this.
Large is really in terms of how far separated two quantum entities can be, and also along the lines of how large can they be in terms of the number of particles in the superposition. Today, I'm going to mainly focus on the first aspect of largeness, and I think the intellectual interest in this problem is well known, and it basically asks the question, where does quantum mechanics and then the classical world begin, and are there limits that we can discern along with the kind of tests that we do, which involve atom to Broglie wave interferometry. So what I show you on this illustration on the cover slide are two ensembles of atoms that are this picture is taken at the midpoint in an atom to Broglie wave interferometer, and actually these ensembles are separated by almost a meter, actually 54 centimeters. And over the course of the talk, I want to explain to you how we actually produce these entangled states and how we observe interference with them, and then sort of go into some of the possible applications that may ensue. So for those of you not familiar with the field of atom to Broglie wave interferometry, kind of the experiment that was the beginning of this field, I think, traces back to Jürgen Linnick's work in Constance in 1991, where with a beam of metastable helium atoms, he did the analogous experiment to the Young's double slit experiment. And so just to take you quickly through this beautiful experiment, you start off with a metastable beam of helium atoms. These atoms are made to illuminate a narrow slit. The slit's dimensions chosen to be small enough that for the parameters characteristic of this atomic source, that would produce at the other side of the slit a set of cylindrically diffracting wavefronts. And these wavefronts, they diffract because per basic non-relativistic quantum mechanics, the atom is described as a wave whose wavelength is inversely proportional to its momentum. And those wavefronts diffract and are made to coherently illuminate two more slits. Mechanical slits also narrow, and coherently meaning that I can think of that wave function as being having the same phase front or a well-defined phase front at that location and that location, and that property emerges from the geometry of this apparatus. That coherent illumination then gives rise to two more de Broglie wavefronts that eventually overlap, and per the rule of quantum mechanics, add before you square, that overlap leads to an interference pattern, which experimentally is manifest in a probability of detecting a helium atom at a given location on a detection screen. And Linnick and co-workers observed that interference by scanning the position of a detector along this interference region and observing an oscillation in the number of.
Why do you have such a terrible diagram? I don't even know the direction. What's going where? And the diagram is from 1991.
Helium atoms which were detected as a function of position, as shown down here. So this is.
So you get a wave pattern? That you would detect a wave?
This is the position of the detector. This is the number of counts. Note the count rate is fairly low. At the time, this was a challenging experiment. Hundreds of counts in a 5-minute interval, and you see this oscillation, and the period of that oscillation is just given by a simple application of Schrodinger equation. Another thing to note here is that this.
Schrodinger? You should be able to get this from De Broglie. You don't need Schrodinger for this.
Distance scale, the characteristic distance between these fringes is small, it's only 10 microns, and to make this experiment work, we required a mastery of microfabrication techniques. All right, conceptual importance of this experiment. Well, since the early 20th century, it was known that massive particles could interfere, and you don't understand the hydrogen spectra if you don't understand wave interference for electrons. Davidson-Germer, you have to accept that matter waves of electrons interfere. Neutron interferometry, we have beautiful examples in the 70s of matter also interfering. So what's the point here? Well, the point was that the atom is a more complicated object than a simple fundamental particle. And in fact, while you could, if you were a believer in quantum mechanics, you could trust you could trust what the Schrodinger equation was telling you ought to happen. It's a different thing to go and experimentally observe that. Now, in the mid-50s, people had been envisioning maybe doing massive particle interference experiments with atomic matter, for decades, and there were some early theorists that basically said, well, you can think of this as something interesting to do in theory. In practice, forget it. You're never going to be able to, in practice, build a device where the wavefronts of the interfering de Broglie waves would be stable enough to observe interference. And so I think that those arguments, Schwaner was articulated some of them, kind of put the field off the track for a number of years. But eventually, the experimentalists became clever and figured out how to build such a device. I think Schwaner had in mind doing something with Stern-Gerlach magnets, which I think is quite correct. That probably wouldn't have worked. Right, so that's where that started the field. And once you have an example of an experiment that works, then you let your imagination run wild. You say, well, can I build an interferometer, other methods, and so forth. And that's this field, my field, atom de Broglie wave interferometry, has now been maturing for nearly a quarter century. And so now I want to fast forward to some recent data that came out of my group at Stanford, and I want to show you ensembles of atoms, which I will claim each atom in these ensembles is in a quantum superposition state separated by a distance of 54 centimeters just before I take this picture. And so each one of these, where you see peaks here, that's where you have lots of atoms, in this case close to 10 to the 5, in some cases approaching 10 to the 6 atoms. And for each and every atom in this ensemble, my claim is that its proper wave function description is as being in a superposition state between this location and that location. And this distance scale being 54 centimeters. 54 centimeters is the distance from my elbow to the tip of my finger there. And that's, I'd argue, starting to be macroscopic. To put this separation in kind of a colloquial scale, you say, well, what's the size of an atom? Size of an atom, half an angstrom, 54 centimeters, half a meter, 10 orders of magnitude difference between the size of the atom and the separation. Now, of course, we know quantum mechanics is there to make things a little easier I'm going to argue that I can show you that I can make these wave functions interfere, thereby establishing the fact that they're in coherent superposition. But just by analogy, kind of if you think classically, if you call the atom the size of a golf ball, then separating that golf ball by 54 times its 10 to the 10 times its diameter, which is the ratio of half an angstrom to half a meter, is basically taking the golf ball, putting part of it on the moon, and then bringing it back and seeing what happens. So that analogy is admittedly misleading. What it does, why I bring that up, is to say that there are some experimental challenges to make such an observation of coherence at this distance scale realize it in the laboratory. Okay, so once I take this, according to quantum mechanics, once I take that picture, no chance of determining or seeing superposition, because for each and every atom in the superposition, I've collapsed the state either to the left side or the right side, the left peak or the right peak. And after that, they behave as if they're classical trajectories, not in this bifurcated situation. But before I take that picture, the way to think about the wave function is a wave function where the atom is, here I speak very loosely for those of you who are sticklers about foundations of quantum mechanics, the atom is very loosely in two places at once. And now, while an atom is still seems like a pretty simple particle, it's a lot more complicated than an electron or a neutron, or for sure a photon. It's the rubidium-87 atoms we use are collections of a lot of particles. And arguably, what we're doing when we create the superposition state is creating a pretty well-controlled Schrodinger cat that's where two parts of the cat are separated by 54 centimeters. And that cat is not something that's so macroscopic that it has lots of floppy internal degrees of freedom, and I have to worry about temperature. But it's still an atom. It's a bunch of particles that are kind of by the energy scales of the interactions that make atoms make it a very controlled quantum system. But this is to me amazing that something as complicated as an atom can separate by this distance and then yet still be made to interfere. So I'm kind of getting a little ahead of myself. I want to prove to you that each atom is in a superposition, and the way I prove it to you operationally is to take those two peaks and bring them back together and see if they behave as wave.
This is unbelievable. This is unbelievable.
Would and exhibit interference phenomena.
He's saying that he's firing or throwing a single atom, which is a complex creature. It's basically a cat, through two slits, 54 centimeters apart. That's basically an arm's length apart. He's saying that's akin, since the particle through the 54 centimeters, like it's like a person to the moon and back. That's the ratio. So, and he's saying that it's in superposition. It's like it's going through both slits at the same time. As one thing. As I said, that doesn't make any sense. It just doesn't make any sense. Wow. That's crazy. That's crazy.
So let me show you some apparatus, and I'll show you data that demonstrates that we do in fact see a quantum interference for those waves. So this is the apparatus in the basement of the physics building at Stanford, and let me just kind of take you through some of the relevant pieces. So here's the real apparatus, but everything looks good in CAD. So let's go to the left side of the screen and take a look at the CAD rendering. So we use kind of now well-defined methods in laser cooling and atomic physics, Bose-Einstein condensation, and so forth to create a very cold ensemble of atoms. And we like them to be cold because once they're cold, the spread in the Broglie wavelength associated with this ensemble is small. It's like doing interferometry with a large coherent length source. I like the wavelength of the source to do interferometry well-defined. So by cooling atoms down to low temperature, I get well-defined, if you will, spectral control over the interfering source. I also solve another problem, and that is usually, like when you think of atoms in this room, they're moving around at speeds of kilometers per second. And so if I know the atom is here at one point in time, it doesn't take much time for the atom to be hitting the wall on the other side of the room if it's at a high temperature. But if I refrigerate it to temperatures, we use temperatures on the order of 100 picokelvins. If I refrigerate them to that low temperature, and what I mean by temperature is that energy, Boltzmann's constant times temperature, is energy which is equal to the kinetic energy spread of the wave function associated with an individual atom. When I'm at that temperature of 100 picokelvin, the atom wave function will spread out at a speed of, taking into account the mass of the atom and so forth, that's just hundreds of microns per second. So if I know I have an atom at this location at time t equals 0, then if I wait for 3 seconds, which is the time it takes an atom to be, this is what we do, we launch the cloud of atoms up this 10-meter tube, they fall back down, it takes them about 3 seconds to go up and down. That cloud of atoms, or the wave function of an individual atom, has not spread out very much at all. And so before we do any interferometry, any of the fancy stuff, one thing I find amazing is I can make this ensemble of 10 to the 5 to 10 to the 6 atoms, and then using light and mirrors and tricks to make the atoms move vertically with respect to the lab frame, I can launch this ball of atoms up this tube. They go up as if it was each atom was, this ensemble was behaving as if it was just an ensemble of sand particles. So I launched up the tube and they fall back down. They go up, they turn around, and they come back down. And if I were to say, well, where are the atoms? I could learn that by taking a picture of them. And I take a picture of them by scattering light, which is resonant with one of the atomic transitions. When the light hits the atom, it scatters in all directions. And I collect some of that light with a camera that's located off this side. And then I just do some standard imaging optics, and I can tell you where those atoms are. And at these temperatures, the small ball of atoms goes up, and it comes back down, and I see a small ball of atoms, literally less than a millimeter in size, after 3 seconds. All right, so this is the atomic source, and there's lots of jargon associated with creating this initial ensemble of atoms. One of the things that we have to do, it's not sufficient just to make a Bose-Einstein condensate. We have to further cool because the chemical potential of the condensate makes the atom cloud kind of want to explode. Just the interactions between the atoms, and so we use a trick known as delta K cooling to further manipulate the momentum spread of the wave packet, so it's at this very low level. How do we make it launch up and down this tube? Well, what we do is we use a force from a light beam on the atoms to manipulate their velocities. And here's what we do. We create a standing wave of light by interfering 2 counterpropagating beams, and by applying a frequency shift to one of the beams with respect to the other, we make the nodes of that standing wave move with respect to the lab frame at the velocity we want to launch the atoms up the tube.
That's genius. So they use a light beam from above and below, and they interfere, and they create a wavefront, and they use the wavefront to move up and down, and the atom basically rides on that wave like a surfer, like a wave surfer.
And just before we do that frequency shift, we load the atoms into this corrugated potential. We can do that because the light polarizes the atom and there's an interaction force. And so the atoms kind of are glued to this washboard potential, which we then make move at a fixed relative velocity with respect to the lab frame. And that sends the atoms on the way up and down this tube, and then we detect them down there. Okay. The interferometry is realized with also momentum exchange between atom and light field. Every time an atom scatters a photon, just conservation of momentum, you can work this out through a non-relativistic Schrodinger equation, but just by conservation of momentum, the velocity of the atom has to change by 5 millimeters per second. So this gives us a nice way of manipulating the velocity of an atom or its wave packet components just by controlled light scattering. As I'll explain on the next slide, I won't give you all the details here. What we do to create a Mach-Zehnder-like de Broglie wave interferometer is after the atom has been launched into this tube, we apply a sequence of light pulses appropriately tuned. And due to momentum exchange with the light field, this creates a situation where as this cloud is flying, each and every atom in that cloud will have its wave function described by one which splits, separates at the top of the trajectory of which we choose by the launch velocity down there at the top of the trajectory. The wave functions are separated by 54 centimeters. If I don't take a picture, I use these pulses of light to bring the wave functions back together. And if all is working well, I might be lucky enough to see interference as manifested by kind of wave-like ripples on the wave function when I take a look at their density distribution at this location. So let's go to that analogy between a golf ball and the moon. What things do I have to control to make this work? Well, one of the dominant effects for us is the rotation of the Earth. And in fact, as the Earth rotates, the entire apparatus if you will, over this 2-second period, is swinging through an angle given by the rotation rate of the Earth. Meanwhile, the atoms have now, after they've been launched by this light, they are in inertial freefall, and they're just going up and coming down this apparatus. And we have Coriolis effect that, if we don't do anything to accommodate, will lead to complete lack of possibility of seeing interference. And so this little picture here is of a mirror, which is located at the bottom part of the apparatus, bolted to the floor of our laboratory, whose angle changes just enough to exactly compensate the rotation of the Earth. And
so because of the rotation of the Earth, when you throw something up, if you throw it up and then wait for it to come down, if you think about rotating the Earth faster and faster and faster and faster, when you throw it up, if you're on the equator, it's fine. But if you're halfway through, if you're in the North Pole, it's also fine. But if you're halfway through and you throw it up, I don't think there's a problem throwing it up. I think there's a problem throwing it horizontally. I don't know. Maybe the fact that it's suspended. I don't know.
Why is that mirror important? Well, to drive these interference transitions, we take a laser beam, we propagate it down the tube, we reflect it off this mirror, and it comes back. And the angle of that mirror is directly proportional to sets the axis of the momentum transfer for this recoil momentum that we'll use to spatially divide, redirect, and recombine the atomic wave packet. We also have to worry about anything that exerts a spurious force on the atoms. So if there's a stray magnetic field gradient, bad news, because that will lead to a coupling with the magnetic moment of the atom that will change its velocity, its momentum, its wavelength, and lead to a situation where I do not have enough stability between interfering paths that I will not stay in well-defined interference ranges. So we have a 3-layer mu metal magnetic shield, which takes the magnetic field over this 10-meter interaction region to well below 1 milligauss in homogeneity. Right, so that's some of the experimental details. Let me back out to a cartoon to kind of explain how the atom interference works. So I mentioned that we use a sequence of light pulses, and so let me take you through that pulse sequence. Here is a conceptual rendering of what I showed you on the last slide.
So it's not going up and down. It's a trajectory. So it's like a parabola. So you're getting the Coriolis effect throughout this so the light hits it from both sides. You control it. I don't know what this arrow is. What are these arrows? I don't know. This is the interference pattern.
And this is the initial cloud of atoms, 10 to the 5 atoms. And they're launched 13 meters per second with this lattice up this tube, and they fall back down. I've displaced the trajectories there just so you can see what's going on. Actually, everything's happening along a single axis. So this is just to help explain. And of course, there.
Oh, so it's along a single axis. Okay.
Accelerating due to gravity, which is responsible for these vertical trajectories. Okay, so here's a space-time diagram. This is time, and this is position. And what I'm plotting here is the relative position of the two atomic wave packets as they go through this interferometer. And I'm doing so in a reference frame that's, if you will, falling with the lower arm of the interferometer. So it's in the frame that's moving up and then falling down with one of the arms of the interferometer. And here's how I make an interferometer. So at time t equals 0, we come in with one pulse of light, which by analogy with MRI spectroscopy, we call a pi over 2 pulse. What this pulse of light is it's associated with a standing wave that Bragg diffracts atoms off the potential induced by the light field. And by choosing the regime for diffraction appropriately, you're familiar with this when you take light and you scatter it off a grating. When you scatter light off a grating, you see a Bragg diffracted peak, and that peak doesn't necessarily have the full intensity of the beam in it. It could take part of the intensity and put it into the Bragg diffracted peak, and part of the intensity will not be diffracted. And if you think about what's happening in that optical experiment, one photon at a time, what you're doing is creating a superposition between the momentum of the photons as a result of that interaction with the grating. Well, we're doing the same thing here with atoms interacting with a corrugated potential of light. We choose the interaction time, which we have easily under control just by how we control the intensity and duration of the laser pulses, so that we have a 50-50 diffraction situation where half of the wave function of the incident atom is diffracted to a different momentum state, and the other half is undifracted. This is a beam splitter. And so long as I now have a way of controlling those two arms, I have the first element of building a de Broglie wave interferometer. So things start off with this first beam splitter pulse via a Bragg transition, and then we follow that pulse with a sequence of pi pulses, which now are tuned to be almost unity efficiency for taking one well-defined momentum state and putting it into another defined momentum state. And we have the Doppler effect of being able to provide a labeling for these two arms so that we can tune the laser so that we can only transfer momentum to one of the arms of the interferometer and leave the other arm alone, for example. So after that beam splitter, in comes a sequence of a lot of pulses. It's
so difficult to know what he's talking about because don't show us him. Show us the board. I need to know where he's pointing at. Like, I don't know what he's pointing at. I wish he said number 1, number 2, number 3, number 4. Oh my God, I don't know what he's talking about.
The work I'm going to describe, 54 centimeters, it's like almost 50 pulses that then we use to, this diagram is not to scale, but used to impart relative momentum of an atom, a part of the wave function in this arm with respect to its partner wave function in that arm. And after this sequence here, which takes a couple of milliseconds, now I have a situation where I have this bifurcated wave function. They're flying apart from each other at close to a meter per second. So I just have to wait. I wait a full second. They're about a half meter separated. That's why I took that first picture. Now, I choose to see interference instead, hopefully. And so I don't take the picture. Instead, I give a bunch more pulses to one arm of the interferometer and another arm of the interferometer. And
where's the interferometer? Well, is this the interferometer? Oh, it starts from 1, 2, 3, 4. So this is the double slit. Maybe.
So this is the 54 centimeter point. More momentum comes here, and this leads to a situation by design which brings the wave function wave packets back together. And at some time, about 2 seconds later, another second later, sorry, 2 seconds after I've launched, the wave packets overlap. I come in with a final beam splitting pulse, and I create an interferometer situation where I have one output port and another output port. And the probability for an atom to be in that output port is going to depend on the relative phase of this arm with respect to that arm. And I detect that interference by counting the number of particles that, just like I do in photon interferometers or neutron interferometers or electron interferometers, I count the number of particles in each one of these ports. In this case, by just resonance fluorescence, I scatter light off this bifurcated wave function and image it on a CCD camera. Right, so that's the experimental scheme. Now let me show you what happens when we do that. So here's false color pictures that are representative of the intensity distribution on the CCD camera. And where you see red, that's where you have a lot of atoms. Where you see blue, that's no atoms. And let me first focus you on these images here. So these were, if you will, our calibration shots, where we used very simple pulse sequences that we knew worked, that separated the atoms by not so much distance, but basically helped us understand that we had the possibility of seeing interference at larger distances. And what were we looking for in these calibration shots? Well, we were looking for high contrast interference, which experimentally means you can tune to or have relative phases between the interfering paths. I have two waves coming together. If they interfere out of phase perfectly, I expect one of the output ports of that interferometer to have no probability of finding the atoms, while the other one I have high probability. Or this is for the case where they're interfering out of phase, and if they interfere in phase, then that port will have all the atoms, and there'll be no contamination, no probability of detecting the atoms in the other port. Now, in the experimental world, nothing's ever perfect, and so you always have a little bit of leakage into these other ports, and that limits the contrast of the interference, and it's the kind of metric that you want to use to understand whether your interferometer is working well. And we were very excited to see at the time we took this data that we had nearly perfect contrast. This was for a situation where the atoms were only separating by 1.2 centimeters, but that inspired us to go to these more complicated pulse sequences where the wave packet separation levers up by the sequence of pulses to distances as large as 54 centimeters. In fact, what limited us to 54 centimeters was a technical detail associated with our arbitrary pulse generators. We didn't have enough memory to drive even longer pulse sequences. So at 54 centimeters, what do the signals look like? Well, here's one where we have maximal asymmetry with respect to one port. Here's one where we have maximal asymmetry to the other port. And which I say maximal, we never observed a shot. Each shot or each experiment takes about 30 seconds. You have to prepare the cold gas, then you have to further cool it, then you have to launch it, and the launching and detection only takes a few seconds, and you go back and start all over again and prepare. For each shot, when we record hundreds or thousands of shots, we never observe less population in this arm or more population in that arm, which then defines kind of a contrast maximum. The pictures I show you here are selected to illustrate these maximal conditions. Most of the shots, you're at a situation where the relative phase is something intermediate between 0 and pi, and you'll see a more balanced population between these two ports. One thing I will get to in a few minutes, but it's important to mention right now, is we do not have good control over the relative phase between these two ports. And the reason for that is this interferometer is extremely sensitive to very small changes in the acceleration due to gravity, as I'll explain, and also vibrations. And so there were just technical noise that was causing this relative phase to bounce around shot to shot. And what we were observing was just the extrema in basically here of a sequence of data. So now if you're an experimentalist, you say, well, okay, so your signature for the interference is looking for fluctuations in the output port. If I don't have interference, I would always see kind of a 50-50 distribution of atoms to one port and the next. I see interference, I start to see fluctuations. A savvy experimentalist will say, well, hang on, there's lots of reasons you could see interference at the output port. Or you could say, are you kidding? That is not smoking gun evidence for interference. That could be like you have a timing jitter in your laser pulse. There's a lot of stuff going on, and there's lots of reasons why it might not work perfectly. So in order to be convincing, I need something that's a little bit more rigorous than that. So this next slide, I think, provides that information. What we've done here, just like you would do in any interferometer, is we've tuned the relative path length between the interfering arms. And any interfering source has a characteristic coherence length, which I can multiply by the velocity of the interfering particle. I can determine the coherence length by the effective coherence time associated with the interferometer. And basically,
I don't understand. I hate presentations. It's impossible to understand. I just don't understand. I mean, I want to see a wave pattern. You need to let each atom fall. It's good that he's using gravity. So what's the purpose? I mean, is this gravitate? Is this where they prove gravitation or interference?
I can tune the interferometer, in our case, by just changing when the optical pulses fire so that the wave functions don't overlap.
What do you mean interferometer? Where is there an interferometer here? I don't get it. What is this?
overlap, or maybe to a point where they do overlap, where I expect maximal interference, to a point where they don't overlap. And I do that by changing the timing of the pulse sequence. And this timing offset is what I'm plotting on the horizontal axis. And on the vertical axis now, I'm showing you what happens when we look at the output ports and we look at the fluctuations of one of the output ports over an ensemble of measurements. And so the data this is derived from are pictures like I just showed you, but now I'm measuring the relative peak height in the two output ports and plotting the variance. And there's a simple theory associated with what I should observe given by non-relativistic Schrodinger equation. And basically, once I know the coherence length of the source, which is determined by the velocity square of the source, which is something that I can measure independently with pretty high accuracy, I can predict for various interferometer geometries what the effective coherence time will be. And so here I plot for various wave interferometer sizes. This is a 54 centimeter. We had 36 centimeter here. We had 18 centimeter there. I plot what this contrast envelope looks like. And then from each one of those envelopes, I extract the width of the envelope, which is proportional to this coherence time. And on this inset, I plot the coherence time as a function of wave function separation. And so don't be misled by the change in heights of those peaks. That's happening. The height is changing because as I go to larger wave function separation, I have more pulses in the sequence, and I don't expect to have as good contrast in the interference. And so what I'm plotting here is the width of these peaks as a function of separation and comparing it to a simple theory that's shown in with the solid lines and my uncertainty in that theory given by my uncertainty in the momentum spread of the source. And here are the data. And so it's this data that I think provides compelling and unambiguous evidence that we are actually seeing a Debye wave interference effect on this macroscopic distance scale and this macroscopic time scale. It takes 2 seconds for the wave functions to separate and then recombine. And that's along that time scale that if you're interested in foundation of quantum mechanics type stuff, you can do with the Lade choice experiment where, for example, we've never done this, but we could launch the ensemble of atoms and then we could go and say, have a vote, a real quick vote for people in this room, and you could tell me how I want to set the settings of my beam splitter, and then we could observe the effects of that choice on the interference. Okay, so what do we learn about quantum mechanics when we do that? Well, as you probably know, there are lots of alternative theories that have been proposed to the standard Schrodinger quantum mechanics. By the way, nobody's found a reason to throw out the Schrodinger equation. But if you're interested in that, there's literature of people trying to solve the measurement problem, trying to understand how you might even parameterize the Schrodinger equation to look for breakdowns in the theory. From my experimental perspective, one of the things I find rather interesting about testing quantum mechanics is that the theory is so darn good and also has so many kind of philosophical issues on its own that it's very hard to generate legitimate test theories. But people try it nonetheless. So I don't want that. I'm not into you though. So yeah, here's where I am. Let me just take you through one of the recent test theories, which are observation of interference as constrained. And this is kind of an interesting mechanism. What this theory, which is known as the KTM model, proposes is that as the wave packets of this interferometer explore two different regions of the Earth's gravitational field, because of the gravity gradient of the Earth, the acceleration due to gravity at this location is not quite the same as the acceleration due to gravity at this location. You could have a situation where, if you didn't understand gravity and quantum mechanics and how they join, you could have a situation where this differential acceleration could essentially be a which path meter for the interferometer. And if I have a which path meter, something that tells me the wave function went on this upper trajectory or this lower trajectory, I don't expect to see interference. And the fact that we see interference means that this model, which is admittedly contrived, and as somebody if you've been a student of quantum mechanics and so on, you at first blush think it's kind of a crazy theory. If such a theory were true, if gravity were designed in such a way that it could provide which path information, then the parameters of our experiment would completely rule this out. And that's what this table is meant to show. This KTM model would be associated with a dephasing time of loss of coherence of milliseconds. And as I mentioned, our wave functions are separated for seconds. And why we can test that with this apparatus is this dephasing rate, this is the dephasing rate associated with KTM, is proportional to the separation of the wave packet squared. So by separating them by 54 centimeters, we can provide a stringent test of such a theory. Okay, and that's one example. Since we published that result, there have been several papers that have appeared that have used our data to constrain various, I would say, not very realistic theories that extend quantum mechanics. But usually when you build an interferometer, you build it for more than just looking for contrast. I mean, you are building an interferometer as a metrological tool. You want to test something by measuring phase shifts. And so let me tell you a bit about the phase shift sensitivity of this instrument. So I want to calculate the relative phase of this path with respect to this path. This is, again, that same space-time diagram. And here, these lines are indicating the center of the wave packet. And lots of ways of doing this. You could just use Schrodinger equation, but because there's so many wiggles in the wave function, it's convenient to think about this in a Feynman path integral formulation. And so in that formulation, you can break up the shift into a couple of terms. One is this difference in action intervals. That's the one that basically I think most of you would be familiar with, where you just count the number of the Debye wave oscillations on one path and the other, and you compare the relative phases by subtracting. And that's formally done by computing two action intervals. There's another shift. Let me jump down here, known as we call it the wave packet separation shift. You could have an arbitrary potential structure that the wave packets are moving through, such that the wave functions of the two interfering paths don't exactly overlap at their output of the or at the output beam splitter. In which case, in a path interval formulation, you need to have some way of comparing the phase of the center of this wave packet to the center of that wave packet, which is what we do with this term here. And finally, there's a term which many people forget the first time they hear about this interferometer, but is absolutely crucial. And that is the one associated with the interaction of the laser fields with the atoms at each of the points that we initiate this momentum transfer between the wave packet and the laser. And when you work through the quantum mechanics of the atom-like interaction, what you find is that in a semi-classical treatment, the phase of the laser at the position of the atom is read into the atomic coherence. And so each and every time you flash in the laser, you have to kind of record, or what nature does for you is record the phase of that laser into the atomic coherence. And so for a simple 3-pulse sequence, we use much longer pulse sequences. So this expression would in principle be much more complicated to write down. For a simple 3-pulse sequence, I get the phase of those laser wavefronts simply by noting where the wave packets are each time I pulse in the laser there, and then I have these two locations, and then at the exit. And I know the position, I multiply by the propagation.
I don't know where he's pointing at. This is useless. Oh, I just want the conclusion.
It's fluctuating up and down. Describe to a scheme in a few minutes where we circle. Okay, so let's talk a little bit more about what we can learn by measuring phase. So I go and I make a simple model that describes the motion of the wave packets in the Earth's gravitational field. I take into account the Earth is rotating. I can also take into account that the Earth has a gravitational gradient and a bunch of other stuff. In fact, we have some analysis. We call it the term list. We put the kitchen sink in there. So this is, and that term list has hundreds of terms in it. Here I have an abbreviated one where I want to focus your attention to a couple of interesting terms. look at this one here. This is the term associated with the presence of the acceleration due to gravity. Well, why do I have a term here? I think that's intuitive to everyone. As the wave functions are spatially separating, they're exploring the two halves of the atom are exploring different parts of the gravitational potential. They have different momenta, different wavelengths. It's clear you're going to get a phase shift. What may not be clear is how big that phase shift is. It's huge for 54 centimeters. It's 10 to the 10 radians per shot for the data I just showed you. Now recall that we have between 100,000 and a million atoms in each ball. If you believe in shot noise statistics, that means I can determine that phase on a single measurement to the square root of that, to a phase uncertainty given by 1 over the square root of the number of particles, or on the level of 10 milliradians almost down to 1 milliradian. And so that means that on any given shot, I am sensitive to changes in the acceleration due to gravity at the part in 10 to the 13 level. It's an exceptional accelerometer. And we exploit that exceptional acceleration sensitivity for various technological and scientific applications, which I'll show you in the last few minutes of the talk. There's another term, and this term has been observed for 20 years ago, and it's the foundation for many really pretty high-performing sensors that measure the acceleration due to gravity. This term here, if you inspect it, is kind of interesting. It's the only term in this list that actually depends on Planck's constant. It also depends on the mass of the atom, and here it depends on the curvature of the gravitational field. This term was identified in the early 90s as being interesting for wave interferometry for the following reason. It's the first term that really fundamentally is associated with the curvature of the gravitational field. That's the gravitational gradient, and also quantum mechanics. You see Planck's constant in there. And so in general relativity, uniform accelerations are sort of uninteresting because if you're a believer in the equivalence principle, you can always boost to a frame where that acceleration goes away and the physics is given by the local physics in that frame. And you wouldn't expect to see use this as a way of testing GR. So it's fundamentally interesting to find an experimental situation where you have the wave function actually exploring the local curvature of the gravitational field. And that's what this term does. I have more to say on that, but just to say that this has been a term that's been sought after as something interesting to observe for decades. And look, for these parameters, that phase shift is huge, 600 radians. Earlier de Broglie wave devices, even with neutrons and other atomic de Broglie wave devices, the separation wasn't large enough to basically explore a significant gravitational gradient, and it was very difficult to observe this term. So we wanted to observe it, and we built the following pulse sequence to create a situation where we were able to isolate that term from the other terms in that term list. And this is what we did. We designed a sequence of pulses. Again, this is a space-time diagram, time, space, plotting the center of mass of the interfering wave packets for single atoms in a reference frame that's falling with the atoms. And just by changing the way we apply that pulse sequence, we can create a situation where a first pulse comes, splits the wave function in two, separates them by a substantial distance, about 20 centimeters. Then we come in and we do interferometer pulse sequences where we open and close one interference loop and another interference loop simultaneously. And then we bring them back together, and they're actually a pair of trajectories here, but because of the thickness of the line, you can only kind of see them as one. We have a pair of output ports. We then take one of these and deflect it so that it comes into the detection region at the same position that atoms in the output ports. Interferometer here measures the gravity gradient response for one value of the Earth's gravitational gradient, and this interferometer measures the gravitational gradient response for another value. I said Earth. What we're going to do is bring in a stack of lead bricks to make it so that there's a differential gravity cancels as a common mode. And so when I compare the relative, the data look like, well, here is but 2D. You have this nice 3D. We're going to put directly spatial fringes across the laser field that we used to do the phase of that ensemble, the upper port and the lower port. And you can see there's clearly separated by there's like a pi phase shift. 7 Gs per meter at better than a part per thousand x, about 7 of them, close to the apex of the tower and the atomic trajectories. And we modulate their positions. We bring them as close as 25 centimeters to these are the interfering wave packets at the peak of their trajectories, and then we pull them away to its head, whether the lead's in or out, if you will. Here, this is the acceleration at the sensitivity of our interferometer. Interferometer does, and so gradient of those two locations. The lead is at the inner position or the outer position where these wave packets are with respect to the mechanics to be correct. I can have a theory curve in our data, and it's basically it's determined by that tidal force. It's depends on the difference in the gravitational acceleration between this arm and that arm. It has to be, in order to understand the spaceship, that gravity is coupling differently to the two halves of the wave function. Every previous de Broglie wave interference experiment with electrons, neutrons, or atoms has been done in a situation where the gravitational coupling between the interfering paths was the same, so I could understand the output of that interference as simply by boosting to an appropriate reference frame and as a kinematic effect. Here it's different, and this is why this is considered interesting. And here, if you're interested in the theory foundation for this, there's this pioneering paper by Enenden in the early 80s, and then Ogresh in the 90s specializing to atoms. This is the first time that somebody did the gravity gradient, say, of that's near the wave functions, and gravity gradient, this configuration out. And so what I want to do in that pulse sequence recording the gravitation apparatus as it's orbiting past, and it did pretty well. It's like it will perform very well. Simulation is that you have thing in your geophysical and validate it in coming years. On some more fundamental science, where we're comparing the free shift in the interferometer out beds. And if there's a we can set very resolve change to talk about, but it looks like we modified that apparatus in order to simultaneously run interferometers for rubidium 85. The wave functions spatially separate, and then we can wave functions eventually over. Doing right now is we're for the interferometer or to the 12 level. We're trying. I'll conclude and for the work on this experiment. Thank you.
Thank you very much, Professor Kadevich, for this very interesting talk. Are there any questions in the audience? Can you just explain a bit more which are the two output ports?
Which are the two output ports?
More in detail.
Should I go back to like okay, so for this data in particular, so interferometer, in comes the laser, and part of the beam is reflected in this direction, part of the beam is reflected in that direction. The interfering wave packets go along different trajectories. And a short time later, those differing trajectories, spatially where the atoms are, we'll see two clumps, and that's rubidium green, if you will.
And if you do the experiment, well, exactly the slide before that, yeah, exactly the Raman shift is proportional to the wave number. And if you do two different, if you split your beam and then you do the thing that you did in the slide after that, where you have your two different interferometers at different heights, do you have to include like things like the gravitational redshift of the wave number into this kitchen sink to sort of get different redshifted wave numbers for the two Raman for the two interferometers at different heights?
Yeah, I love the question. Excellent question. So the question is, do we have, because this is, I mean, we're probing accelerations at some minuscule level, and you might be, since you look at this term list, if you will, and you see that it depends on the size of the magnitude of the propagation vector light, you might causes an observable phase shift. It's used to drive the atom. and then bring them back together. In that
Rate of gravity, is it some Unruh, some Hawking kind of effect? Or?
So it's not as exotic as that. In fact, it just it'd be great. And in this theory, there are I can point to some papers where there are Hawking-like terms out there. But no, in order to see a Hawking-like term, an Unruh-like term, you need to be accelerating at dramatic levels. Like for benchtop Hawking, legitimate Unruh type, 10 to the 20 g, and we're nowhere near that. So Unruh, it would be great to be sensitive enough to see that. We're nowhere close to seeing Unruh. Where does this term come from? It just comes from you can calculate it if you believe quantum mechanics and you do the quantum theory for this interferometer in the curved gravitational potential, where you just have two different values for gravity where the two arms are. And so that's depending on your taste for theoretical rigor, that either triggers a fully general relativistic calculation, or you can use perturbation theory to get the answer with a lot less work. So it just flows from that. And then where it becomes conceptually interesting is if you say, well, I don't really feel like I know enough about gravity to say how it behaves on quantum wave functions that have large spatial extent. And that's where you have a very limited number of test theories that could be constrained.
Is there a last question? Yes.
When you absorb a light pulse, then your wave packet splits into two parts. Now you have a gravity which is no longer homogeneous and constant. So if I think of a theory of gravity, I would also need to quantize gravity. So I could also get splitting of the beams by absorbing or not absorbing a graviton or something like this.
Yeah. So now, thanks for the question. And once you start using the word graviton, I am now no longer in my field of expertise. But what I would say is that if you did want to quantize in this way, which and that's where there is. As I understand, a lot of theoretical interest these days. We're in a regime that you could think of as semi-classical, where there are, given the strength of the gravitation of these classical fields that we're using right now, a lot of gravitons associated with those fields. And so it would be very unlikely to get into a regime where you start to resolve, say, the ill-defined quantum field theory of single graviton with this apparatus. But already I'm on thin ice, as I say, and there are others who are much more expert in talking about this.
If there is no further question, then we'll thank you again, Professor Kazevich.
Thank you.
So let me get this straight. He threw a single atom. No, he dropped. He didn't throw. He dropped a single atom through a. Well, he didn't do it with a single atom. He did it with multiple atoms. So why not do this with just water? So according to you, if you just let water drip through two slits, you should get a detectable wave pattern. Which is basically what he did. He dripped water vapor in a vacuum. So water vapor in a vacuum through two slits will give me a wave pattern. Is that what you're saying? Water vapor or hydrogen atoms. So what is a de Broglie wave? De Broglie was talking about the electron. He was talking about elementary particles, not an atom. How can an atom have a wave function? Doesn't matter if it's single. So let me get this here. He dropped atoms through double slits in a vacuum and got an interference a wave interference pattern. So let me get this straight. He dropped. I don't care if it's a single atom or multiple atoms. Through double slits in a vacuum chamber and got a wave interference pattern. Is this what you're telling me? Well, am I missing something? This is ridiculous. What's going on here?
And eventually they moved up to different frequencies with the Xcarat and some of the other systems that they had that were more effective and more accurate. But the problem they had is that they obviously had shorter distances because they were much higher in frequencies. They started going up into the UHF band.
Yeah,
which doesn't.
Yeah, you get into more trouble with the. It won't reflect in the ionosphere, so then that's their limiting factor.
And then as they got to as they overtook France, they actually started moving up some smaller ones, some smaller antennas that were more for.
Let me ask. Let me ask him the same question. Yeah, I should remove this message. I couldn't do it. No, Mercury precession, it doesn't matter. Anyway, hi. Hi. So I saw is this how you spell barely? So let me get this straight. He dropped atoms through double slits in a vacuum chamber and got a wave interference pattern. Is this right? Okay. Curious. And he gave us this article, Quantum Superposition at the Half-Meter Scale. I don't have an app to read this out loud. How can I search narrator? No narration. No. So quantum. Can I tell something to read it out loud? Summarize. The summary is longer. It's ridiculous. But I want you to read it to me. Yeah, thank you. Go to hell. Can you read it to me? You dummy. What? Video? Brave talk? Alright. How do you close this? A quantum superposition principle allows massive particles to be delocalized over distant positions. Though quantum mechanics has proved adept at describing the microscopic world, quantum superposition runs counter to intuitive conceptions of reality and locality when extended to the macroscopic scale, as exemplified by the thought experiment of Schrodinger's cat. Matter wave interferometers, I don't know what those are. That's just a wave which split and recombine wave packets in order to observe interference, provide a way to probe the superposition principle in macroscopic scales and explore the transition to classical physics. In such experiments, large wave packet separation is impeded by the need for long interaction times and large momentum beam splitters, which cause susceptibility to dephasing and decoherence. What is decoherence? Is that the collapse of the wave function? Quantum decoherence is the loss of quantum coherence. Quantum decoherence has been studied to understand how quantum systems convert to systems which can be explained by classical mechanics. So decoheres, like it becomes classical. Interference phenomena, a well-known and crucial aspect of quantum mechanics, famously exemplified by the two-slit experiment. There are many situations, however, in which interference effects are artificially or spontaneously suppressed. Not quite. I'm held up now, so I can't go into it. But they split them into a superposition with laser pulses. It's atom interferometry. That's the best term to investigate. Here we use light pulse atom interferometry to realize quantum interference with wave packets separated by up to 54 centimeters on a timescale of 1 second. These results push quantum superposition into a new microscopic regime, demonstrating that quantum superposition remains possible at the distances and timescales of everyday life. The sub-nanokelvin temperatures of the atoms and a compensation of transverse optical forces enable a large separation while maintaining an interference contrast of 28%. In addition to testing the superposition principle in a new regime, large quantum superposition states are vital to exploring gravity with atom interferometers in great detail. We anticipate that these states could be used to increase sensitivity in tests of the equivalence principle. Measure, because the equivalence principle has never been measured. Measure the gravitational Aronoff-Bohm effect and eventually detect gravitational waves and phase shifts associated with general relativity. I have no idea what they're talking about. Matter wave interference of particles selected from the Gerlich. It's not Gerlach. Decoherence of quantum. I don't know. I don't know what's going on. This is the book, linear algebra book. He doesn't define a vector. There's no definition of a vector. Is there a search? Can I do a search on this thing? There's no search. Search. What are we searching for? Vector. Oh, there's only 1,189 instances of a vector. Nothing. Lists Fn. I think Fn is the vector. Fn. To define a high-dimensional analogous of R in 2 dimensions or 3-dimensional real number, we will simply replace R with F, which equals R or C, and replace the 2 or 3 with an arbitrary positive integer notation n. Fix a positive integer n for the rest of this chapter. Definition Fn coordinate. F is the set of all lists of length n of elements of F. Fn. That's incredible. In one small sentence, there's a set of all lists of length n of elements of F. F. Wow. For x1 to xn, where for all fn or something, and k. Where do they teach this thing? We say that if f equals r, what is f equals r? F is a coordinate. And any equation previous notation of r. Example, C to the fourth. That's a complex number in 4 dimensions. C4 is the set of all lists of 4 complex numbers. C4 equals Z1, Z2, Z3, Z4. 4 complex numbers. That's 4 dimensions where each dimension is a complex number. That's what it says here. Each dimension is a complex number. If n is greater than 4, we cannot visualize Rn as a physical object. Similarly, C1 can be thought of as a plane. Okay, I don't know what they're saying. I don't understand their language. I need to study their language. Speaking of my language. Anyway, it doesn't matter. It doesn't matter. And nothing else matters. Okay. Okay, we can close this. La 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 So should forward this email to someone who's registered as an endorser for the physics class PH classical physics subject class. Request your endorsement to submit an article, please. And they just click this, please visit, to tell us that you would like to endorse this person. Click here. If that URL does not work, click here and enter this code. Oh, very nice. So this is the endorsement that I need to forward him. Okay. Mm-hmm. How to find echelon. Nature of evil. That's such nonsense. Wave function. I'm a little bit hungry. Breaking crowd flees rally as Trump loses it on stage. Yeah, sure. Pluto just had a collision with Neptune and something alarming is happening. Yeah. If Pluto collided with Neptune, we would be in dire straits. I mean, we probably wouldn't feel it for thousands of years or maybe even millions of years. So I guess we would be fine. Superstar, STEM, alright, whatever. Oh, 2 Israeli embassy attacks. Wonderful. Vegan Gate, Silent Hill, Young Turks. This former Trump official should go to prison, of course. Playing. Blah, 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 blah. Breaking war news with. Okay. The best thing for the world right now would be Trump. If Trump comes into power, he would stabilize the world. That's my opinion. I think everyone is. Because he's strong. He's not weak. I hope he will be strong. It's good that the Iranians are threatening him. That's good. So when he comes to power, he's gonna maybe wipe them off the map. Maybe. Maybe he'll be as tough with them as he is with leftoids. Okay. Anyway, let us continue. All right. So curvilinear coordinates. Suppose P is a point in a coordinate system, xi, in n dimensions, given by P, x1, x2, xn. Okay, P is the point in a coordinate system xi, n dimensions. So there's x to n. There it is. Here is P, x1 to xn. Okay.
Suppose also that I had a different coordinate system in Rn given by xi bar. In this coordinate system, the coordinates of P were given by x1 bar, x2 bar, all the way till xn bar. Finally,
okay. So this is the old and this is the new. So the new is just like the old. It's just x bar. So x bar it's the same point, right? It's still P. So x bar I is another coordinate system in Rn. Oh, it's very nice. So it's the same space. Rn is the space. So a coordinate system lives in this space. Wow. It's so amazing that these things are so well defined. So Rn is the space of n dimensions. Xi is the coordinate system in the real realm, in the space of n dimensions, such that the coordinates of P in this system are x bar 1, x bar 2 to x bar n. Okay.
Suppose that the coordinates in the non-barred system can be converted to coordinates in the barred system using a series of n functions given by this stylized f. Now, this stylized f consists of n functions, so this I would actually go from 1 to n. It consists of n functions that make up a transformation. Now, if the functions making up this transformation are all real valued, if they all...
One second. Suppose that x bar I is equal to x bar I, that's a function, of x1, x2, xn. This is the stylized f. I don't know what this is. This is the stylized f transformation, which is just the x bar I. He's saying x bar I is a function, and it's called a f. Okay, so this is the transformation, and it's curvilinear because the x bar I coordinate system could be curved, and the x also could be curved. Curvilinear coordinates. Okay. Now, if the function x bar I of xn are all real valued, so each x bar I
all have continuous second partial derivatives everywhere, and if they're all invertible, then this transformation f
are all real valued, so they all give a real value, not a complex value, have continuous second partial derivatives. What about first and third and the rest of them? What else is it saying?
Making up this transformation are all real valued if they all have continuous second partial derivatives everywhere, and if they're all invertible, then this transformation f is called a coordinate transformation. In addition, if the...
Okay, good. If the function, okay, real valued second partial derivatives everywhere and are all invertible, he'd never defined invertible. What is invertible? Jesus, why are you saying invertible without defining? Then stylized f is called a coordinate transformation. Yeah, but he already did that before. But what is invertible? What's the definition of invertible in tensor? Tensor calculus, it invertible. In tensor calculus, an invertible tensor is a tensor that has an inverse, meaning it can be multiplied by another tensor to produce the identity tensor. I don't know if that's what they mean. I honestly don't know. Okay, I read this. I can close it. Decoherence. We listened to him. And we're back to this guy. We can close that guy. I don't know. Wait, what just happened? Okay. So, and they're all invertible. Come on. You didn't define invertible at 336. 336. Invertible was never defined. So, and they're all invertible. I'm assuming you can, there's an inverse function, I'm assuming, but he didn't say what it means. Anyway, so, but this is curvilinear, all right?
Coordinates that are being inputted into f are rectangular coordinates, then the output coordinates are called affine coordinates if f is a linear transformation, and they're called curvilinear coordinates if f is not a linear transformation. So this should cover the
Okay, so note, this is just the naming convention. If the xi being inputted into stylized f are rectangular coordinates, then x bar I is a affine if stylized f is linear, b curvilinear if stylized f is not linear.
Definition of curvilinear coordinates. But so far, we've gone through quite a few definitions and assumptions all at once. So let's actually go over some examples of curvilinear coordinates. The first example is polar coordinates. If I had a point P on the two-dimensional plane and the rectangular coordinates of P were x1, x2, then the polar...
Okay, so given rectangular coordinates, and here's a point P, x1, x2, so it's in 2 dimensions. So this is x1, x2, rectangular coordinates.
Coordinates of P would be given by x1 bar, which is the distance of P from the origin, and x2 bar, which is the angular displacement of P in radians relative.
That's already cool. That's the x bar. So the x bar, that's very interesting. It's a polar coordinate system. But is it curvilinear? Well, you see that x2, of course it's curvilinear. It's like, it's not even curvilinear. It's like bizarro universe. X bar 2 is an angle. It's not even a straight line. And x1 bar moves. It's not even stable.
Relative to the positive horizontal axis. So x1 bar and x2 bar comprise the polar coordinates. Because there are two coordinates, there are two separate.
Right, so x1 bar and x2 bar are coordinates you can use because you can use them to define a point P.
Equations relating the barred polar coordinates to the unbarred rectangular coordinates. I can write the radial distance x1 bar as the square root of the sum of the squares of x1 and x2, and in addition, I can write the angular displacement x2 bar as the inverse tangent of the ratio.
Okay. So x1 bar, if you want to convert for transform the x1, x2 to x1 bar, so it's obviously x1 squared plus x2 squared square root. That is x1 bar. Right, because x1 bar is just the length. That, right, in order, right, but that gives you a circle. That's a complete circle, x1 bar. But x2 bar, well, x2 bar, this angle, I would say, is rise over run. That's the tangent. I think arctan is tan negative 1, right? The tangent of x2 divided by x1, no, that is the tangent. So the arctangent, right, because this over this is the sine of the angle. So the tangent of x2, you can just put the tangent. The tangent of x2, or the inverse, or the arctan, I think it's the inverse, is this ratio. So this to this is the tangent, is tangent of x2. But if you want x2 to be alone, you want a full this is so the transformation. This is incredible. This is so beautiful.
Of x2 to x1. Note that the equation for x2 bar is only valid for the first and fourth quadrant because of the nature of the inverse tangent function. For the other quadrant.
Oh, so in this quadrant, x2 over x1 is the tangent of it's a very big angle. So this is just for the first quadrant.
Quadrants, you have to look at the signs of x2 and x1 and add or subtract some angle accordingly. Now I'm going to denote these two sets of equations by the coordinate transformation TP, P for polar coordinates. But how do we know that this is a coordinate transformation? Well, if we go back up to the conditions we had for a coordinate transformation, we can see that TP is comprised of real value functions. You put in real numbers for x1 and x2, you get real numbers for x1 bar and x2 bar. The functions in TP also have continuous second partial derivatives everywhere. The exception.
Continuous partial derivatives everywhere. Continuous partial derivative. Well, I don't know what the arctan looks like. If I remember, tan is a very problematic function. It's like tangent is also sine over cosine, right? It's rise over hypotenuse divided by base over hypotenuse. So it's basically rise over run. That's the tangent. So, but it's also sine over cosine. So sine over cosine gives you discontinuous. It's not continuous. So that's a problem. But he says it's not.
is at the origin where both x1 and x2 are 0, but everywhere else TP has continuous second partial, so we're fine there. And the third condition is that TP is invertible, which it is. So TP satisfies all the conditions for a coordinate transformation. Now, in case you don't believe me on that invertible condition, here is what the inverse of TP looks like. Here, what we're doing is we're converting from polar coordinates in the bars to rectangular coordinates, which are without the bars.
Oh, very nice. So the conversion TP minus 1, inverse TP, transformation to polar, so from polar. So x1 prime is x bar 1 times cosine of x2 bar, and x2, the angle, no, not the angle, x2 is the rise. The rise is x1 bar times sine of the angle. So sine of the angle is rise over hypotenuse, times the hypotenuse gives you the rise. So that's x2. Fantastic. I'm not sure about the second partial derivative. So what does arctan look like? So let's go to a graph convention. Desmos. Come on. Why is it so lit? Do you have a dark version? We're done with linear algebra. Where is Desmos? Okay. Blank. All right. So arc10. No? Oh, so arc10 is perfect. What about 10? Yeah, 10 is no good. What about sine x divided by cosine x? That's basically tangent. So the purple, this is green. Wait. So this is green. 10. You see, this and this are identical. Okay. How do you graph? How do you find this shape? What is it? Is it arc sine over arc cosine? Arc sine is only defined there. Arc cosine is just this. Arc sine x, arc cosine x. I guess not. I don't get it. I mean, we were having a good discussion. Why did they move to this debate?
About a quarter inch on the barometer. Sweatshirt weather, like maybe 48 to 50 degrees, maybe 85 to 90 degrees. I don't go out in this extreme cold, don't go out in the heat. I don't want to do that to my instrument, and I don't want to be there. So this was a recreational survey, essentially. So that's the meteorological conditions are at a very narrow band of temperature and pressure.
Hello. Hello, can you hear me? Elo. 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 Okay. So arctan looks good. What does this look like? Square root looks like a square root. Square root of x1 squared plus x2 squared. Right, so P can go any which way, and we can define it with two coordinate systems. That's fine.
The bars. So we've established that this polar coordinate transformation is an actual coordinate transformation. But what type of coordinate transformation is it? Is it curvilinear or is it affine? Well, it should be pretty obvious that
it's curvilinear. It's not affine. There's squares and there's arctans, so affine is linear, and this is not linear. You have square, square root, and arctan. Yeah.
that the equations comprising TP are highly nonlinear. The arctan and the square root make TP a nonlinear transformation, so therefore it is a curvilinear coordinate transformation. This should cover polar coordinates. Let's move to our second example of curvilinear coordinate systems, cylindrical coordinates. Cylindrical coordinates can be thought of as polar coordinates, but with an extra third dimension added that represents the height of the point. So let's draw what I mean by cylindrical coordinates. Say I had a point in 3D space whose rectangular coordinates were given by x1, the horizontal distance from the origin, x2, the vertical distance from the origin, and x3, the height relative to the origin. Now, in addition to using rectangular coordinates, I can also write t in cylindrical coordinates.
Okay, so this is very similar to polar, probably. I wonder what spherical coordinates are going to look like. So this is just like a course in doing transformation of coordinate systems. You just have to get used to doing transformations of coordinate systems, which is always a good thing to do. I mean, it's always good to think about these things. So cylindrical coordinates, so P let me take some poison. I need some poison. I don't want to waste time. I'm a little bit hungry. Okay, so cylindrical coordinates, so you define a point, x1, x2, x3. That's not a problem. So now we're going to define probably like a polar, like, or at the base, we're going to define something polar and a height. So x2, so wait, this is x3. This is x1, x2, and x3. I guess x3 is the height. So x3 and x3 bar are going to be the same. This we can already see. And x1 and x2, we already derived the transformations of x1 and x2 because x3 and x3 bar are identical. So that immediately gives us the transformation to the cylindrical and from the cylindrical. Again, x1 and x1 bar, x2 and x2 bar, and x2 and x3 are directly related.
x1 bar, which is the distance of the...
And it's curvilinear because of x1, x2.
Projection of P on the xy plane to the origin, x2 bar, which is the angular displacement of P relative to the positive horizontal axis, and x3 bar, which is the height of P relative to the xy plane. It's basically the exact same thing as x3. In this case, because there are three coordinates, there are three sets of equations relating the barred cylindrical coordinates to the unbarred rectangular coordinates. And here's what these three equations look like. Again, the arctan equation is only valid in the first and fourth quadrants. You have to change your answer if you're in the other two quadrants. I'm going to denote the set of three equations by the transformation TC, where C stands for cylindrical. This transformation converts rectangular coordinates to cylindrical coordinates. It also has an inverse transformation which converts cylindrical coordinates to rectangular coordinates, which I'll write over here. Now, just as for polar coordinates, you can easily verify that TC is a curvilinear coordinate transformation. It's real valued. It has continuous second partial derivative.
Yeah, no problem. Real valued, second partial derivative, curvilinear.
everywhere except the origin. It has an inverse, and the equations comprising TC are nonlinear.
It has an inverse? Oh, this is why he does the inverse, to prove that it has an inverse. Oh, okay. Got it.
The last example of a curvilinear coordinate system we'll talk about is spherical coordinate.
That's amazing. Spherical. Oh my God. So it's basically, it's a combination of polar. It's like polar any which way. It's polar this way and it's polar that way. Let's see what he does.
Again, suppose I had a point P in 3D space whose rectangular
x1, x2, x3.
coordinates were given by x1, the horizontal distance from the origin, x2, the vertical distance from the origin, and x3, the height from the origin. I can also write P in spherical coordinates as x1 bar, which is the distance of P from the origin, x2 bar, which is the angular displacement of P relative to the positive horizontal axis, and x3 bar, which is the angular displacement of P relative to the positive x3, or the...
It's funny, it doesn't call them theta and phi. It's x1, x2, x3. That's amazing.
z-axis. In this case, there are 3 sets of equations relating the bar...
Wow, that's so amazing. So x bar 1 is x1 squared. You see, he puts parentheses when he said he's going to put parentheses when he does powers. So x1 squared plus x2 squared plus x3 squared gives you the length x1 bar. That's fine. Now, x2 bar is the angle of the projection of x1 of P onto the xy plane. So he's going to say that it's the arctan. Let's see. So P is here. This is P. So this angle, it's the same as x2 bar. So x2 bar, yeah. Yeah. This is x1 and x2, I guess. This is the x1, x2 plane, right? This is x2. No, that's x1. This is x1, so this is x1. This is x2. Yeah, so it's the x1, x2 plane. This is the x3. Very nice. So x1, so this relates, and by the way, this is x2, so this is x3. x3 bar is the arctan by the same consideration. Like this is, it was x2 over x1, so it might be x3 over x2 or something, or the opposite.
Barred spherical coordinates to the unbarred rectangular coordinates.
Oh my God. Okay, so this is arctan x2 over x1, okay. x3 is the arc cosine of x3 over... Oh my God. Oh, I would never have thought it's so complicated. Square root of x1 squared.
Here's what they look like. Again, the arctan equation
Oh my God. Now you have to do the inverse. Jesus.
is only valid in the first and fourth quadrants. Now I'm going to denote the set of 3 equations by the transformation TS, where S stands for spherical. This transformation converts rectangular coordinates to spherical coordinates. It also has
we're probably going to need this throughout the course.
An inverse transformation which converts spherical coordinates to rectangular coordinates, which I'll denote by TS inverse. Again, you can easily verify that TS is a curvilinear coordinate transformation. It's real valued, it has continuous second partial derivatives everywhere except the origin, it has an inverse, and the equations comprising TS are nonlinear. Now that we're done with curvilinear coordinates, I'm going to finish this video with a short...
Wait, he didn't do the inverse, or did he? Oh, he did. Oh my God, look at that. This is so beautiful. How do you derive that? Well, you have to look at the geometry.
Except the origin, it has an inverse, and the equations comprising TS are nonlinear. Now that we're done with curvilinear coordinates, I'm going to finish this video with a short discussion on the Jacobian and Jacobian matrix. Say I had a coordinate transformation T given by the following series of...
Wow, the Jacobian matrix. Jesus. Suppose that x bar I is equal to x bar I
equations, which transforms the unbarred coordinates x
of x1, x2, xn. Is that tau?
1 to xn into barred coordinates xi bar, where I varies from 1 to n. The Jacobian matrix for this coordinate transformation, which is denoted by J, has components equal to the partial derivatives of the barred coordinates with respect to the unbarred coordinates, and looks something like this. The determinant of this Jacobian matrix is called the Jacobian and is...
So the Jacobian matrix is just the partial derivatives of the coordinates, I guess. So partial x1 bar over x1 time, and this is partial x1 bar over partial x2, partial x1 bar over partial xn. So it's just a transformation. It's just by how much is x1 bar changing when we change x1. And this is by how much does x2 change bar when we change x1. By how much do we change xn bar when we change x1? And this is by how much does x bar 2 change when we change 2. This is 2. Anyway, okay. It's just by how much does bar change when we change the original. That's the first half. The second half, wait, it's the same half. It's just by how much does the new change when we change the old? What's the ratio for each, which is like very mechanical. And that gives us, this is a matrix called the Jacobian matrix.
Denoted by the stylized J. Remember not to confuse the Jacobian and Jacobian matrix. The Jacobian is the determinant, while the Jacobian matrix is the actual matrix. Now you might be wondering, why is the Jacobian important? One reason has to do with the theorem from analysis. I won't prove the theorem here, but the theorem says that the Jacobian is non-zero over a region U in Rn, if and only if the corresponding transformation T is locally bijective at every point in that region U. Recall from the previous video that bijective basically means 1 to 1. So we can essentially use the Jacobian as a mathematical...
So the Jacobian is non-zero over a region U if the n space in the n space, if and only if the corresponding transformation Jacobian is locally bijective in that region U. Okay, I mean it's unique. The Jacobian is non-zero over, okay, that's given, whatever that means. The Jacobian is the determinant of the Jacobian matrix, which just means multiply these guys by the multiplication and then subtract the multiplication of these guys, which is really weird.
Construct to determine where our transformation is bijective. There's many other uses for the Jacobian, which we'll cover later, but this is one of those uses. Another useful fact about Jacobian matrices is that the Jacobian matrix of
why do we care?
Non-zero over a region U in Rn, if and only if the corresponding transform, which is the unbarred coordinates x1 to xn, into barred coordinates xi bar, where I varies from 1 to n. The Jacobian matrix for this coordinate transformation, which is denoted by J, has components equal to the partial derivatives of the barred coordinates with respect to the unbarred coordinates, and looks something like this. The determinant of this Jacobian matrix is called the Jacobian and is denoted by the stylized J. Remember not to confuse the Jacobian and Jacobian matrix. The Jacobian is the determinant, while the Jacobian matrix is the actual matrix. Now you might be wondering, why is the Jacobian important? One reason has to do with the theorem from analysis. I won't prove the theorem here, but the theorem says that the Jacobian is non-zero over a region U in Rn, if and only if the corresponding transformation T is locally bijective at every point in that region U. Recall from the previous video that bijective basically means 1 to 1.
The Jacobian is important to prove a theorem, which just says the Jacobian is non-zero. The Jacobian, not the Jacobian matrix. The Jacobian is non-zero over region U in n space if and only if the corresponding transformation J is the Jacobian is locally bijective in that region U. I don't know what it means. So if the Jacobian is bijective in region U, then the determinant, only then, I don't know if only then, but then the determinant is non-zero. Okay. So the determinant is non-zero in a region where the Jacobian is unique. I don't get it. I mean, just make the Jacobian, which is the determinant, is non-zero over a region U in space if and only if the corresponding transformation Jacobian, this transformation Jacobian, is locally bijective in region U. Otherwise, the Jacobian is zero. So the Jacobian is zero if this is not bijective? So if this gives the loop, the Jacobian knows to become zero? How is that possible?
So we can essentially use the Jacobian as a mathematical construct to determine where our transformation is bijective. There's many other uses for the Jacobian, which we'll cover later, but this is one of those uses. Another useful...
So if we want to discover if our transformation is bijective, we take the determinant and see if it's non-zero in a certain region. What does that mean, region? Like, how do you... I don't know. This is... I don't know. It's like a different universe.
Full fact about Jacobian matrices is that the Jacobian matrix of an inverse transformation T inverse is the inverse of the Jacobian matrix of T. In other words, if J...
The Jacobian matrix of the inverse transformation Jacobian inverse is the inverse of the Jacobian matrix of the Jacobian, i.e. if J is the
Jacobian matrix of T, then J inverse is the Jacobian matrix of T inverse. This rule, of course, only applies to a region where T is locally bijective. So it only applies as long as the Jacobian, the determinant of the Jacobian matrix, is non-zero, which kind of makes sense because if you remember matrices from linear algebra, matrices would only be invertible if their determinants were non-zero. Anyway, that should do it for this lecture. I'd like to thank the following patrons for supporting me at the...
Wish you would scroll up because I don't know what you just said. Who is supposed to understand this? Is this like for normal humans?
Another useful fact about Jacobian matrices is that the Jacobian matrix of an inverse transformation T inverse is the inverse of the Jacobian matrix of T. In other words, if J is the Jacobian matrix of T, then J inverse is the Jacobian matrix of T inverse. This rule, of course, only applies to a region where T is locally bijective. So it only applies as long as the Jacobian, the determinant of the Jacobian matrix, is non-zero, which kind of makes sense because if you remember matrices from linear algebra, matrices would only be invertible if their determinants were non-zero. Anyway, that should do it for this lecture.
So matrices are only invertible if their determinants are non-zero?
Makes sense because if you remember matrices from linear algebra, matrices would only be invertible if their determinants were non-zero. Anyway, that should do it.
Really? Wow. So matrices are only invertible if their determinants are non-zero. So if the determinant is zero, it's not invertible. Holy Jesus.
Do it for this lecture. I'd like to thank the following patrons for support. This video's topic is going to be about contravariant and covariant tensors. Specifically, we're going to talk...
Oh my God. Contravariant and covariant. This is where I lost my mind in the previous courses that I took. I'm beginning to become extremely tiresome. Wow, I'm really tired. I'm really, really tired. Okay, I'm going to go. I'm done. This is very, very difficult. Very difficult. Okay. Bye-bye.